Linux installation. So, what is Linux? Well, Linux is the kernel that powers the Linux operating system. Okay, that's kind of nice. And kernels are programs that talk directly to the hardware and manage resources and processes. So, what does that mean? Well, in a CPU, your chip that runs your computer, ever since the 386 processors, we've had this separation. You have the kernel process, and then you have everything else is in user land, and they're separate. So the way to make security work was they decided to separate them and decided that only one program was allowed to talk to the hard drive, talk to the RAM, talk to all the other physical devices, and that program was then responsible for making sure other programs started up and gave them permission to access things. So the Linux kernel does that in the Linux operating system. It's the only program allowed to talk to the hardware directly. Everything else has to talk to the Linux kernel through things called system calls. Kernels need a whole operating system to be useful. There are different kinds of operating systems. If you look at Linux, you'll see that there are the GNU Linux operating systems, which is basically the GNU software mixed with the Linux kernel. You also find things like Android. Android is the Linux kernel put on top of, well, added to a bunch of other software to run a phone. When a Linux kernel is bundled with operating system software and shipped together, that is called a Linux distribution. In the Linux family or Linux world, there are many different families of distributions. You have the Red Hat family, you have the Debian family, you have all these source code distributions, and then there's this whole recent debate about changing init to systemd. Most distributions have switched to systemd, but some are still back on the old init system. So what's the Red Hat family? Well, the Red Hat family is one of the earliest families of Linux distributions. The Red Hat people discovered there was a problem. And that problem was, how do you package and ship software? And not just ship it, but ship it in such a way that you know which version of software you have and you can install things and make sure that they work together. And so the Red Hat company created this Red Hat package management software. And what happens here is all of your packages come as these RPM files. And these RPM files are then installed, and there is a database that keeps track of which ones are installed, and then each RPM can tell you what its dependencies are. It's become more advanced now. You have big repositories that keep track of lots of different things and keep track of what the dependencies are, so you don't have to try to figure that out on your own. The Debian family is basically the same thing as the Red Hat family. It's just slightly different, and that would be with the deb packages instead of the RPM packages. Slightly different focus. Red Hat tends to focus more on corporate company type things, and Debian's more the end user experience. Then you have these source code distributions. Well, these source code distributions, which includes things like I guess Slackware and Gentoo and Arch, these things, they try to ship something, but it wants to build stuff from source code, because if you build from source code, you have a much higher chance of things being compatible or not compatible and knowing very quickly. You also have situations where you want to optimize your system, and Red Hat and Debian, well, they're written with generic systems in mind, and they're not really optimized for anything. So it's kind of hard to optimize a Red Hat or Debian system much. But source code can get you much more optimized. Of course, it can be much worse as well. And then there is this whole system. So once the kernel starts up, the next big thing is, how do you start up everything else? Well, you have this very first process after the kernel that runs, and init, the system5 init, was something that came out of the old Unix world, and it runs these systems. It starts up your services, and it eventually brings you to your GUI or your command line and starts everything up for you. Systemd was created because they realized there were a couple of issues with init. First of all, it did everything sequential, and you want to be able to do some things in a different order. Maybe you want to be able to start two things at the same time if they don't have any dependency relationship. And then they just changed the whole way of doing things so it's more closer together. Init is just very organized scripts that do things, and systemd is a more organized system of doing stuff. So some hardware considerations. When you are getting ready to install Linux, you need to know, can your machine boot the installation media? So that could be a CD-ROM, hard drive, it could be floppy, or it could be some kind of network-based thing. You have to decide, can you boot it? Because you have to be able to boot into something in order to do your installation. And you also need to know, how much hard drive space do you need? Normally, the earlier versions of Linux could get by with just a couple of, megs. Then it moved up to a couple of gigs. And now you're looking at right around 8 or so gigs, and it's going to probably grow and get bigger as you need more and more in order to run. How much RAM do you need? Well, in the early days, you only needed a couple of megabytes, but now, if you want a GUI, you have to have at least a gigabyte of RAM. And that's just kind of a minimum. You really want more than that. You want to know, will your video card work? One of the issues that originally plagued Linux was these video cards would come out, but they had this whole thing about secret drivers. If you make a mistake with the hardware, all you have to do is just fix it in the driver and no one will know. But now, people do find out, because most of the video cards have source code that is available to look at, and people can see, oh, you messed up. The same kind of thing happens with the wireless cards, because if you have wireless cards, you want to have drivers. Linux likes to run with everything compiled from source code rather than just binary drivers. You also need to look at your other hardware needs. Do you need to have scanners or cameras or other devices hooked up? And do you have software for it? So you can look and try to figure out if the software is available and working for Linux. There are a couple of different installation methods. You can do a DVD installation. So this is typical for physical devices when you want to physically install it on a computer. Also, if you're using something like VirtualBox or VMware, you might use an ISO installation. You're actually doing a DVD installation, but the ISO image is really the image of the DVD before it's burned onto a DVD, and the virtualization software can pretend that the DVD is actually burned and install off of that image. You can do USB installations. You can do hard drive installations if it's already installed in the hard drive, and you can install from there. And sometimes you can do network installations, but that requires having some kind of a boot service and being able to install, off the network. Time and date. When you're doing your installation, you need to have your time and date set. So how does a computer clock work? Well, you've probably seen movies about crystals and stuff like that, and trekking through jungles trying to find amazing crystals that'll make things work great. Really, the whole idea is you're just trying to find a clock, trying to make a clock work. And so they use quartz crystals. The idea is if you send electricity through quartz crystal, it oscillates at a given frequency, and the computer can count that and keep track of date and time. The problem is that not all quartz crystals are created equal, so it doesn't work that way. They get off a little bit. So in order to make things work properly, you have to use things like network time. So let's talk about time zones. Well, if everybody were in the same time zone, it wouldn't matter what time zone we were in. But if we were in different time zones, then there are all these differences. The question of, is it always the same number of minutes different between two different time zones? Well, that's not quite right, because you have things like daylight savings time and other things that mess everything up. Sometimes political changes change your time zones, and you want to make sure that you have the same time as somebody else. If you are in Seattle and someone else is in New York, well, there are a couple of time zones between you. And you want to make sure you have the same time, not the same time of the day, but knowing that you can take the time on your computer and calculate out what time it is in a different computer somewhere else. So it is important to make sure you set the correct time zone so that you know that you are not the same time as someone else. When you're storing your time on your computer, it gets written out into a chip, and the question is, do you want to store local time or UTC? UTC would be your Greenwich Mean Time or your Zulu time. So Windows machines tend to use local time for everything. Well, that's great until you move your computer from one time zone to another time zone, because then you have to sit there and recalculate everything. Linux likes to store everything as UTC, so then all it needs to know is what time zone am I in, and then when it reads it from the computer, it can immediately translate it into your time zone and be fine. Windows, when you move from one time zone to another time zone, you have to change it from your local time to UTC, then to the other time zone. Much more complex. Network time communicates over the network. You send a request to a server. The server sends you the time as UTC, and you have to calculate it and convert it to local time. When you're doing your installation, you have to do your software selections. You have to decide which software should I select. Normally, the default is to have a minimal install. A minimal install has really minimal software. There's very little there. If you want to have a secure server, you want to start with a minimal install. However, if you want a desktop, you don't want to start with a minimal install. You want to start with something like the GNOME desktop option. So make sure you have the right one selected. What type of machine do you have? Well, that's back to your hardware questions. What hardware do you have? And you also need to decide, how is this machine going to be used? Are you using it as a desktop machine or as a server? Are you running it as a web server? So you want to try to pick what you want. If you are running it as a server and you don't want to be hacked, it's best to start with a minimal install. If you want to run it as a desktop, well, just start with a desktop. Can you install packages later? Yes, you can. You can install lots of packages later. Everything that you can do during installation, you can pretty much do later. And where does the software come from? Well, you have these software repositories, and your software comes from the repositories, and you download it and install it. And Linux, when you have these Linux distributions, these distributions are, the main purpose of them is to provide these repositories so you can get your software later. What are the requirements of different packages? Well, fortunately, you don't have to know too much, but the repository does keep track of which software is required by which other software pieces. So when you do an installation of a particular piece of software, it will search through a database and figure out which dependencies are required, check your system to see which ones you already have, and then after it's decided which ones you have, it can download everything you're missing, install those, and then the package you need. So you don't need to worry too much. When you are doing your installation, you need to install Linux onto the hard drive. So where is that? Well, you have a hard drive, and you have it divided into individual partitions. So the hard drive can be different drive volumes, and Linux can be installed in any one of these volumes. Normally you'd want to install at least the bootloader, the main parts of it, on the beginning part of the hard drive, so that you can then read later parts of the hard drive and see everything. You also have this thing called swap partitions. A swap partition is used in situations where you run out of memory. If you run out of memory or hard drive space, really bad things happen to Linux machines. You don't want to ever run out of memory, ever. It's bad. Don't do it. So a swap partition is nice because it takes a portion of the hard drive and it uses it as virtual memory. So when you start running out of hard drive space, well, not out of RAM, you will take pieces of your RAM that are not being used, you'll write them to the hard drive, and if you suddenly need those pieces of RAM again, you will pull it from the hard drive back into RAM and put something else on the hard drive. If you do that a whole lot, that's called thrashing. It's really bad for your system. It makes everything slow because the hard drive is much slower than RAM. So you want to have swap, but you don't want to have a large swap. And you don't want to ever have to use the swap. You just want it there in case you do run into it. So what are the other partition types? Well, you've got these Linux types. You've got your swap. You also have things like RAID partitions or LVM partitions. So LVM is the local or logical volume management. The idea being that you can create a giant partition and then make other fake-ish partitions inside of it. LVMs make it possible to resize and move data around seamlessly. So it's kind of nice to have LVM. But if you aren't making huge changes or adding hard drives, removing hard drives, or if you're using a virtual machine, there's really no need to have LVM. You can just stick with your standard Linux partitions. Once you have a partition, you need to install a file system into that partition. And there are different file systems. Linux came from the Minix world, and so you have this Minix file system. And then you have expansions. So it was extended. The first extension of Minix was ext2, and then you have ext3 and ext4, and these are extensions for the Minix file system. But there are other different file systems. You can have XFS, which is the default on a lot of newer Linux machines. You also have Windows partition types like FAT32, and you have your NTFS. And Linux can create different file systems and put them into partitions and use them. And the way it uses them is through mount points. A mount point is a directory in your directory structure. So you first have your first main partition, which is your root partition for the entire system, and then you'll have directories inside of that. And then you can take any one of those directories in there and say, oh, this directory is going to be redirecting to a different partition. And those redirections into a different partition, where you merge two different partitions together into the same directory tree, are called mount points. On Windows machines, you have your mount points as drive letters normally. So you have the C drive and the D drive and the E drive and the F drive, and those would all be separate partitions. Networking. Why should I set a host name? Well, your machine does much better if it has a host name. Everything seems to work better. Usually, it even works much better if the host name maps up to an actual DNS entry in a DNS server somewhere. But that isn't required. And if you have a host name on your machine, that doesn't mean that anybody else can see that host name. Maybe they have no idea what you've set, and you're not telling them what your host name is. So it's mostly for internal functioning and making sure you don't have to use the host name of localhost. Why should I turn on my networking? Well, you can't do software updates if you don't have networking. It's hard to do any networking-based things if you don't have networking. So really, you should turn it on. But when you turn on, what should you use? Should you use DHCP or a manual configuration? Most computers out there on the internet use DHCP. Most servers actually use a manual configuration. So if you're using a client machine, you're going to use DHCP. in most cases, and you'll use a manual configuration for anytime you need a server. There are some servers that will not run with DHCP. DNS servers really want manual configurations. DHCP servers want manual configurations. Active Directory and things like that on Windows machines want manual configurations and don't really run well on DHCP. Can I change the networking after installation? Of course. Linux networking on these CentOS Linux-based machines tends to be managed by the NM or Network Management Tools, and you can usually click on applets in your GUI to change your networking settings, or you can use the NMTUI command from the command line to change your networking. Root. What is the root user? Well, the root user is the main user that runs the entire system. Root is the process or the user that runs all kinds of stuff and makes everything work. So, is it the same as administrative account? Well, not quite. Administrative users usually have a group that they're part of, and on most Linux machines it's the wheel group. So if you are a member of the wheel group, then you're considered a administrative user. And then the idea is that you can sometimes run administrative commands using different software things like the sudo command in order to run them as the root user. So what are the requirements for root password? Well, you really don't have a lot of requirements. During installation, it might throw a fit if you are having simple, easy passwords, but you want to have a password that's hard to guess and that you can remember. So you need to remember the password and don't forget it. But why is it set during installation? Well, it's a lot harder to set it after you've installed, after you've booted up, when you're trying to log in. So make sure you set it during installation. Additional users. Why should I create additional users? Well, it is not usually good practice to run as the root user all the time. When you're doing administrative tasks, you want to be able to have root access, but you don't want to accidentally click on some link and do something accidentally and have your entire system destroyed because you're running as the root user. So you want to run as a different user, and in order to run as a different user, you need to create an additional user that is not the root user. You can make it an administrative account, which basically puts it in the wheel group and allows you to run the sudo command, sudo. And that allows you to run stuff as root. So you want to make sure you have a good username, and a good username is a username that is not one of these standard easily guessed usernames. So standardly easy guess usernames would be your generic names, your Alice, Bob, and Eve, those kinds of things. You don't want to have bad passwords either. Make sure the password is good and does not match the username in any way. Make sure it's complex enough to be not guessed easily. Once you do your installation and you boot up, you have this initial setup thing. And the initial setup shows up during the GUI installation. They want you to accept the license agreement, and then if you don't accept the license, then they kind of really don't want you using it. So they try to force you to do the license agreement. And then there's this whole thing about kdump. Kdump basically is a feature that allows you to have all of your memory written out to the hard drive in cases of a kernel crash. Usually you're not going to look at that, so you don't really care. But if you are a kernel developer, you might care about it and might want it there. Login options. What are the login options? Well, you can log in from your GUI, or you can log in from a command line. Normally, you start up in the GUI, and you just pass in your username and password, and usually your user shows up. You can just click on your user and then type in the password, and that's how you get in. If you don't want to log in as one of the users that shows up, you can select additional users, type in the root user's name, which is root, all lowercase, and the root password to get into the GUI. Or you can press something like Control Alt and F2, or Control Alt F3, or Control Alt F4, or one of those numbers, and drop to a command line, and then log in as root with a password. When you log in, you want to make sure that you realize that when you're typing your password, it will not echo back any stars or letters or anything like that. So you just have to know that the password is being typed in. Just trust that something's going in there. It makes it so it's harder to do some kind of a screen observing and stealing. So that's what that's for. So what might cause a login to fail? Well, you'll obviously fail to log in if you don't have that user on the system. You will fail if your password doesn't match the user's password. You will fail in some cases if you cannot log in because the hard drive is full or because directories got deleted. You might also fail to log in if somehow permissions got set incorrectly, if the ownership of a directory got messed up, if you break things, if your SE Linux context got messed up. So if you break things, it might not work. So how do you know if they're working? Well, if you log in, it's working. So then what can you do in your system? Well, you can do updates, you can install software, you can run the software. Those are really the things you want to do. All right, so when you're booting up, what is the boot process? Well, you have a bootloader. A bootloader is a piece of software that is there to load your operating system. Why do you need that? Well, originally, when they started looking at operating systems, they decided to start with these really small processes. They decided that the first 512 bytes of memory would get loaded into memory, and then you just start running it. Well, that's great, but 512 bytes is not very much for anything. You can't really run a huge operating system with that. But you can load a program that loads your bootloader that then loads your operating system. So it's a long process with multiple steps. You have your BIOS load your first bit of the hard drive. That first bit of the hard drive loads your bootloader. Your bootloader then loads your operating system, and then your operating system then starts up your initial process, which would be init or systemd. The systemd process would then load up your services and load up your GUI and create all of your terminal logins and all of that. So it's a long, multiple step process. How do you set boot options? Well, it depends on which options you want to set. But normally, when you're talking about boot options, you're looking at what the kernel loads as. And those can be configured in the grub configuration. And that's normally found in the etc boot directory. And sometimes that gets written out there from other directories, and you can look around for grub configurations and just find things. Where are the boot files located? Well, normally in the boot directory. And the boot directory contains your kernel, your initial RAM disk, mapping, your grub configurations, all those be stored in your boot directory. I guess we already talked about how the system starts and when does the GUI start. But there you go. Navigation. So when you log in, where am I? Oh, where am I when I start? So normally you start right there in your home directory. And how do you move around? Well, in the GUI, you can click on things and look at different directories, and they'll show you what's in them. If you get a terminal up, or if you log in from a terminal, you start in your home directory and you can use the cd command to change directories. Then you have to figure out, well, where is everything stored? Well, programs and user files and logs and configuration files are all stored in different places. The programs are usually stored in the /usr directory, but sometimes they're stored in the /opt directory, and sometimes they're stored in the /bin directory or /sbin. It depends on which programs you want. User files are usually stored in the home directory, so /home and then your username. So you store all your files there. Logs get stored in the /var directory, so /var/log. You can go in there and take a look around and see what you find. And then configuration files are normally stored in the /etc directory. So you can look at those and see what files can be edited and changed. When you're doing networking, it's kind of important to know what your IP address is, and you can type in ifconfig on most Linux and Unix-like systems, and that will tell you your IP address. So that's interface config ifconfig. However, on newer Linux machines, you need to type in IP space ADDR, and that will tell you your IP address. It also tells you your MAC address. Your hostname normally shows up in your prompt, but you can type in the keyword hostname by itself to see what your hostname is set to. Where is it set? It's normally set in the etc directory in a file called hostname. So /etc/hostname is where your hostname is normally set. Where is your DNS set? Well, there is the etc directory once again, because that's where the configuration files are at. There's an etc and then resolve.conf. Resolve.conf is spelled without a trailing E on resolve, so it's resolv.conf. And it is your name server that's set there. Where is the IP address set? Well, it is normally, it depends on how it's loaded, but the configuration scripts for the IP address are in the etc etc directory, and it's in the sysconfig network scripts directory. And there is usually a file called ifcfg dash and then your interface name. So ifcfg dash ens32 or ifcfg lo for the local loopback. And so you just go in there and look at that. How do you test your networking? You can use ping, traceroute. You can try to do stuff. How do you edit files? Well, you can view files with the cat command. Cat's actually from concatenate, but you can type in cat space and the name of a file and it will list the contents. You can look at them with the less command if you want to scroll through it. Make sure you press Q if you want to get out of less. Just less in the file name and Q to get out. But what about editing it? If you want to edit it, you can use VI, Nano, Emacs, Gedit, any one of those editors. How do you get more editors? Well, you install them. You can use yum install in the name of the editor, assuming that's the name of the package that installs it. So which editors are best? Well, VI tends to be available on most systems. It's been around for a very long time, and many people who like archaic editors are familiar with VI. It is not the best editor. It is not a very good editor, and it's very cumbersome and complex, and people hate it. And because they hate it, they are starting to remove it. So it's starting to become less and less common on newer distributions, but it is pretty much installed on every Linux and Unix distribution out there right now. Nano is a much better one. Nano is based off of an original editor from the University of Washington called Pico. The University of Washington had bad licensing, so Nano was created as a drop-in replacement for Pico, and that's kind of nice. It's a much easier editor to use, not incredibly powerful, but it is easy to use. Emacs is one of the earlier editors as well, like VI. There was a long time a VI Emacs debate on which one was better. Emacs was written by the same people who wrote the GNU project, so comes from there. Emacs is very difficult to use, and I recommend against using it. Fortunately, it is not installed on Linux distributions by default, so you don't have to worry. gedit is your editor that shows up in your GUI, so much easier to use. You can click on buttons like a save button and open button, and you can see everything. And so gedit is kind of nice there. Software updates. How do I update the system? Well, use the yum command. So you can do a yum update yum, first of all, because you want to make sure your updater is updated all the way. If you don't have a fully updated updater, then weird things can happen sometimes. You want to make sure you update the software of the entire system. You can just do a yum update, and that will update everything. If new programs are available, it will update anything that's new. You can also update new stuff with by just doing yum install any individual package, and again update or install new packages. How do I know if it's already installed? Well, you can try yum install something, and if it says it's already installed, then it's installed. You can also type in the rpm command and look at the rpm database directly. So you can do rpm minus qa to list all of your packages, or just rpm minus q and the name of the package, and see if it's installed. How do you uninstall it? Well, you can do yum remove and the package. You can also do the rpm package directly, rpm minus e for erase, and then the package name. So what happens when you update GUI files while in the GUI? Well, that happens sometimes. If you do a full system update and you're in the GUI, sometimes the GUI gets updated. And as you might imagine, if you're in the middle of running a program and that program changes, sometimes you have to read parts of that program from memory, and sometimes you have to read parts of that program from the hard drive. And if it changes on the hard drive, and you can get an inconsistent state that crashes. So don't update your GUI from in the GUI. Drop down to the command line and do it from there. How do I connect to the internet? Well, with the network. But you also need to have your browsers. So Firefox and other browsers are great. If you want, you can even install Chrome or other browsers. They are available and can be installed. How do I get a remote terminal? Well, remote terminals are things like SSH. So you can use SSH, and it's already installed on your system by default. So you can type SSH space and the IP address of a machine to log into that machine. Sometimes you need to pass a username. I usually do SSH space username @ IP address to log into machines. How do I get a remote GUI? Well, that's a lot more complex. You can have your X11 GUI exported, and then you just go from one Linux machine to another Linux machine, and you can start up things like terminals inside or web browsers inside of your local machine that are actually running on the remote machine. Or you can use something like VNC or other software to get a remote GUI. Capturing data. How do I take a screen print? Well, if you're running a virtual machine, that gets a little bit tricky. Sometimes the screen print button works for taking pictures, and sometimes the screen print button doesn't. If you want to take a screen print of something, and you want to show what's going wrong when you're trying to talk to people, it's usually best if you're outside in a virtual machine to take a picture of the virtual machine's window using your local screen printing tools, such as the snipping tool on Windows. How do you get data from a terminal? Well, it depends on how you're connected. if you're connected to your virtual machine through your virtual machine's window, maybe you can't. Maybe you can, maybe you just select it and copy it. Sometimes it copies out, sometimes it doesn't. What's usually easiest is if you SSH into your virtual machine or SSH into your machine, it's easy to copy and paste into an SSH terminal emulator, and that makes it much easier. In addition to that, if you have a terminal emulator that allows you to do file copying, you can just usually drag and drop or copy it. Sometimes you use the SCP command to do a secure copy between machines as well. And then last, how do I get out of my GUI? Usually there is a button in the upper right hand corner, sometimes it's the lower right hand corner, sometimes it's the upper left hand corner, and sometimes it's the lower left hand corner. So you just have to figure out where it is, but click on the button and it will allow you to log out or shut down the machine. How do I log out of a text terminal? Just type the exit command until you are logged out. How do I shut down? Well, in the GUI, you just find the button to shut down. On the command line, you type in the shutdown command to shut down. Usually you have to tell it when you want to shut down, so type in shutdown and then the keyword now to shut down now. How do you reboot? Just type reboot on the command line, or from the GUI, find out where your button is. And this has been a quick little overview of your Linux installation and using a Linux machine. So good luck. Command line navigation. When you first log in, you're in your user environment, and there are things you can do and things you might want to do, but you need to know how to do them. One of the things you want to do is probably bring up a terminal window. Many things, many different commands are written specifically to run well in the terminal, and if you don't have access to the terminal, it's hard to run them. Not everything is created to run in the GUI. So how do you bring up a terminal window? Well, let's look at this right here. You can see if I click on my application, then I can scroll down to favorites, and off to the right side there is terminal. You can also go down to utilities or system tools, and you can find your terminal down here. Either way, you can launch the terminal, and once you have the terminal up, you can start typing in commands. And that's pretty useful. So what do we have? Where am I? If I do a pwd command, I can see my present working directory. I'm in the /home/Joseph directory. If I do an ls command, I can see things that are in that directory. I can do an ls-l to list it in long format, which makes it easier to read for some people. Or I can do an ls-al to show all files, including the ones that are hidden. Hidden files are basically just files that start with a dot. I can see all these files in my directory. So let's go back to the slides. Directory I'm in. Well, the pwd command. What does my prompt tell me? Well, the prompt tells you your username, and it also tells you the directory you're in, and that can be useful. It also tells you the host name, and we'll look at that again when we go back to the terminal. When you're logged in, you have an environment. Well, what are environment variables? Environment variables are basically name value pairs that are stored that your programs can use. So if you look at your environment, you will see a bunch of name value pairs. One of those name value pairs would be something like username, and it would actually list the user. For in my case, it would be Joseph. So username equals Joseph. I might also have things like my path. A path is a list of directories that I look in whenever I type in a command to try to run that command. So it doesn't matter what my environment is? Well, it does, because if you have a environment and your environment doesn't have certain things in it, then you will have to explicitly indicate where those things are. Programs rely on the path to be able to find things. You can look at your environment with the env command to show the environment. You can also change them with the export command. So let's go ahead and look at this again. So if I type in env, I can see all these different variable sets, such as my home and my actual home directory, which can be useful because then I can use a program and I can tell it, instead of going to /home/Joseph, I could do something like use the home variable. So how to use the variables? Well, if I wanted to type in echo, I can type in echo and it will tell me things. It will repeat whatever I tell it to repeat. But I can use variables here, echo home with a $sign, and it will not echo the word home, but it'll echo the value of the home environment variable. Some of these variables are set in some of the files in my directory. So if I do ls-al, I can see there is a .bash_history, .bash_logout, .bash_profile, and .bashrc. So if I take a look at the .bashrc file, you can see that it has information here. You can also see the keyword export is in the file, but there is a hash mark in front of it, meaning it is commented out. If I look at my .bash profile, .bash_profile, I can see another thing right here. I can see path is being set to whatever the path was currently at, but then it's adding stuff to the end of it, and then it is exporting it into the environment. So whenever I log into my system, this file, the .bash_profile file, will be executed. And you can see the cat command can be used to display contents of files. All right. Terminal redirection. When using the terminal, what do the greater than, less than, and double greater than mean? Well, greater than is used when I'm running a program to direct the output into a file. So whatever comes after that greater, whatever is pointing to, is where it goes. The less than, I am directing a file's contents into the input of a program. And then the double greater than means that I'm taking the output and appending it to a file. I can also use variables in commands, and I can use backticks as well. So let's go back to this terminal and take a look at it. So if I type in something like time, it will display the time. If I type in date, it will display the date. What if I wanted to save the date? Well, I could type in date greater than saved date.txt, and it will save the date. If I go cat saved date, I can see the date's been saved. If I run it again, the same command, it will overwrite it and replace it. If I use the cat command, I can see the new contents of that saved date text file. If I use the double greater than, now it will append it to the end of there. I can append it multiple times, and then I can go look at the contents of the file, and I can see now we have multiple entries that are in this file. That can be useful. So what's the backtick? Well, the date command also has options you can use. So if I do date plus %d, it says 09. Well, that's because it is the 9th day of the month. I could also put in quotes right here, add some more things like a %Y, And now it adds the year. I do a %m, and it adds a month. And if I want, I can even add dashes in here. So now it displays that. So how can that be useful? Well, what if I want to save the date and I want to save it into a file? So I can do date, redirect that into a file that has whatever this thing produces, .txt. That's a little complex. So basically what I am doing is taking the date command, running that. It will produce a date in the format we saw above. And then this format above will be sent to the output. The output will then take this command and run it, and it will generate a date. It will then append a .txt to the end of that, and it will create a file with the contents there. So now I can do a cat and 2019-4-9.txt, and I can see the contents of that file. So that's what the backtick does. It takes whatever it runs, whatever the output is, and puts it right there on the command line for you. Manual pages. How do I find information by commands? What command or what information is provided by manual pages? How do I find out, or how do I get out of this man command? And what if there are C functions and programs with the same name? Well, what if I want to know how to use that date command? I just used it, it worked. I can type in man date, and then it lists information about that command. I can use the up and down arrows to scroll through it. I can see, instead of using a %Y, I could use something else, like a %y, which would only give me 2 digits instead of 4 digits. If I want to get out of this, all I have to do is press the Q button. That's kind of nice. It's very useful in giving me information about commands. Also, if you want to, sometimes the command also shows up in programming languages. So if I type in man2 date, it looks to see if there is a section 2. Man3 date, is there a section 3? If I look at man time, you can see that there is a time 1, which means I'm looking at man page 1. Well, time happens to also be a C function, so I can do man2 time and see if it shows up there. And we can see, oh, this is a little bit different than the man1 time. This is man2 time, and now we're looking at C code. It tells me how the C code is used and what it does. Now, file management. How do I create files? How do I edit files? What information does the file system keep on each file? How do I move a file? How do I rename a file? How do I copy a file? How do I delete files? All of these things are kind of important things to do. So let's jump right back in there and see how we do them. Okay, you can create files, obviously, by redirecting output from something to another file. And you can see that I've created a few files. One of them is this date thing. If I do ls-l, I can list a bunch of directories and files, and maybe I want to get rid of that saved date, so I can do rm saved date, and that gets rid of the file. I can also rename files, so mv is either move or rename, so I can do mv 2019-04-09, and I can call it some file.txt, and that will either move it or rename it. Basically, moving and renaming are the same thing. The reason why we use the move command is because the way that we are moving something is by actually changing the entry in the file system that points to the data on the drive. So we're just changing that entry. And so that's the exact same process as moving something. So it made a little bit less sense to have two different commands. I can also create empty files. So look right here. There is, well, the sum file.txt. And if I want to create another file that's empty, I can do touch. What touch does is it touches the file, it changes the modify date times and things like that. So if I do touch new file.txt, it will change the date, the modification date of that file. Well, the file doesn't exist, so it creates it and then changes it. So if I do ls-l, you can see that a new file has been created, and there it is. You can also delete files. In addition to using the rm for remove, you can use the unlink command. So if I unlink new file, it takes away the symbolic link, or not symbolic, the hard link to the file, and then the file is gone. On the directory entries here, you can see this number 1, number 1 right here, and then the rest of them have 2s. That is the number of links pointing to that entry. And when the number of links goes to 0, the file is gone and the memory is released. Okay, so that's how you do some modifications and things like that. If I wanted to move the sum file into my desktop, I can move the sum file to my desktop. Now it is case sensitive, so lowercase desktop is not the same as uppercase desktop. So if I do it with a lowercase d, it says it's not a directory. If I do it with a capital D, it does say it's a directory, and suddenly it shows up on my desktop right here. And if I want to remove it, I can either remove it, well, by giving it the location of the file, or I can go into the directory, take a look around, see it's there, and remove it there. And then go back down to my directory I was just in. And that's how you can do some basic file manipulation. But what about editing files? Well, I can use nano new file.txt, and then I can type in some file contents, something, and I can press Control X to exit out. It asks me if I want to save it. I say yes, and asks me if I want to use the same name that I typed it in, and I just press enter, and then it creates a new file. And I can see this new file.txt, and I can use the cat command to display the contents of the file. All right. Searching and editing files. How do I find files containing some string of characters? How do I display the contents of a file? How do I know what type of file a file is? And how do I edit a file? Well, we just edited one, so we can see that. We know how to do that. But what about finding files that have contents? We know how to display the contents because we've used the cat command. So now let's go ahead and find files. I have a file in my directory somewhere that has the word something in it. We know which one it is. I can do a grep command, grep something and star to search all the files in my directory. Well, all the ones that don't start with a dot. And then it shows me, okay, a bunch of these things are directories. We can't search those, but there is this thing, new file.txt, that has the word something in it. And I can even use parts of that, smaller pieces. If I'm using the word some, I can see that something still has some in it and it still shows up. So that helps me find the file. If I wanted to search in other directories, let's say I move this new file up to my desktop, it's gone. If I do a search, nothing shows up. Now, if I want to search all of my directories for files inside of them, I can do a */*, and then it finds this something up there. Doesn't really tell me where it is though, which is kind of difficult. but it does give me an idea that it is existing somewhere. All right, so that's searching. How do I create directories? How do I move directories? How do I rename them? And how do I delete them? Directories are kind of like files. They're files that contain contents, including, well, files. If I do ls-l, I can see that I have a bunch of directories here. I can create a new directory with mkdir for make directory. So my new directory is going to be called new directory. And then I can use ls-l, and I can see that this new directory is there. I can rename that new directory mv neuter as older. And that changes it, ls-l. Now I have to be careful. If I decided I wanted to rename this old directory as desktop, what would happen? Well, if I do move older desktop, that directory already exists. So what it will actually do is it will move it onto the desktop. So you have to be careful with these removing or moving of directories. I can also remove that directory of rmdir desktop older. So it'll go up into the desktop directory and remove the older directory, but only if that older directory is empty. So if I drag this new file into the older directory and then try running it, it will say directory not empty. So I can go into that directory, or I can remove the file first. Desktop, older, new file. I can remove the old file or the new file, and then I can remove the directory. So you cannot remove directories using the rmdir command if they have contents in them. If I create a new directory, new again, and I create a file inside of it, touch neuter new file, I can't remove the directory with the rmdir command, neuter. However, I can remove it, neuter, with a recursive command, minus $R to recursively remove it. And that will remove the new directory and all the files inside of it. So it cleans it out and it's gone. So that is a little bit of directory management for you. Links. What are hard links? Well, hard links are entries in a file, usually a directory file, that tell you where the contents of a file are on the system. Symbolic links are like shortcuts. They tell you a location. And this is not a physical part of the drive where they're located. They tell you a directory and a path all the way to the file. So they are not quite the same thing as Windows shortcuts, but they're very similar. Windows shortcuts are files that contain all kinds of information, including the path. So how do I create links and symbolic links? We know how to remove them because we can use the unlink command, and as you might guess, you can also use the delete command or the rm command. So I'm going to create some links. So if I look at my directory, I have no files. So I do touch new file.txt, and now I see that there is a new file. It also has one hard link to that new file. So I can do ln new file and then new file 2.txt, and this creates a symbolic link, well, not symbolic, a hard link from new file to, well, the new file to new file 2. So if I do ls-l, I can see now there is the number 2 right here, indicates there are 2 hard links to the new file and new file 2. I can do ln -s for symbolic, new file, and I can create a new file 3.txt, which is not the same thing as a hard link, so the number 2 will still stay a number 2, but you will see a new entry. And that is my symbolic link. The symbolic link has one link to it, and it points to new file. And so if I were to look at the contents of new file, which is empty, then, well, they'd all have the same thing. So let's go ahead and put something in it. So I echo hello, and I'm going to append that to new file.txt. Now if I do ls minus l, I can see that the content size of new file 2 and new file has both changed to 6, but new file 3 still has the same 11. Any one of them will display the same content. So new file.txt, new file 2, and new file 3 all display the same contents. But if I want to remove things, if I do an rm new file, well, what do I have here? Now we can see that new file 2 is still there. And new file 2, because it was pointing to the actual physical location on the hard drive, will still have contents. New file 3 was pointing to the name new file, so the contents will be gone. So if I cat new file 2, I can see the contents still. And new file 3, well, it says, well, there is no new file, so I can't do that. So I remove that, new file 3, and remove new file 2. And they're gone now. And then absolute path versus relative path. Absolute path starts with the very root of the system, so it's a slash directory all the way down to the location of the file. Relative is based on where you're at. So all of the symbolic links I was doing were relative paths. All of the directory entries I was doing were relative paths, all based on where I was currently at. So they can be used interchangeably in certain situations. So let's go ahead and look at this. If I wanted to look at my current directory, I can do ls minus l space dot. Dot is my current directory, and I can see what's in my directory. Also, because I know which directory I'm in, I can use /home/Joseph. So ls minus l /home/Joseph will also display my current directory. But I could look at the /home directory and see other users. Well, there's nobody else, just me. Or I can look at the slash directory and I can see all of the directories on the system and get an idea of where things are. This is useful because using these absolute paths, even if you are in a different location, the absolute path always works. If you're in a different location, if I do ls minus l dot dot, it'll show me the home directory. But if I go down into my home directory and use the same command, it will show me the slash directory. But no matter where I am, ls minus l /home will still show me the home directory. Even if I move to the slash directory, it'll still show me this directory. If I want to go back to my home directory, I can type in cd /home/Joseph, or I can type in cd, or I can do cd tilde to get back to my home directory. Anyway, these are some of the things you can use for going around looking at directories. And that is the end of our slides for this chapter. File systems. In understanding the basics of file systems, one of the first questions that come up is understanding what is the purpose of a file system. A file system helps you organize your space. A hard disk is really a large set of bits that are organized by, well, into bytes and organized by addresses. And you can use the addresses to address anything on the entire hard disk. So you have this huge space with lots of addressable bytes. And then you have to decide, well, okay, if I want to store data on this, how can I store it? If you have a large, gigantic file, maybe your file is a 1 terabyte file, you can start from the very beginning of the drive and start writing the file out, and then at the end of the file, you'd have it all written there, and you could just read that single file back and it'd be fine. But sometimes you want to put more than one thing in there. So if you put 2 files in there, the question is, well, where does one file begin and the next one, well, where does one end and the next one begin? And you have to decide how to keep it organized. So a file system allows you to overlay a piece of information that contains all the addresses in that partition, and lets you keep track of where files are, what space is available, what permissions are set, which users have what permissions, and all the information that you can use to provide security and organization. So how much space does the disk really have? When you go in there and you look at your machine and you see how much space it has, is that the real amount? Well, not usually. Usually what you're seeing is how much space is available in the file system. So then how do you know which disks you have? Well, you can use some of the GUI tools, or you can use tools such as fdisk, which will allow you to see which disks you have, which partitions you have, and then even you can look in there and figure out things like how they are formatted and set up. So what is a partition table? Well, when you take your original disk and you decide to break it into individual pieces, there is a table, usually the very front of the disk, that will tell you where a partition begins and where it ends. Partitions are individual, well, blocks that we turn into volumes. And there are 2 main formats that are currently in use. There is the MBR, which is the master boot record, and then there is the GPT. GPT is, well, it's an acronym that contains an acronym. And the G is GUID, which is globally unique identifiers. And then PT is partition table. So GUID partition table. So MBR was written with the idea that machines would only go to 32 bits. And because of that, the addresses are only 32 bits, which means that your largest, you basically only address beginning and ending of partitions in 32-bit numbers. And if you know much about 32-bit numbers, that basically means you have 4 billion different possible addresses. And so that's how you would have to have your partitions set up, to be based on the idea there are only 4 billion addresses. You'll find that's quite a bit of a problem with 32-bit file systems as well as the MBR, and it limits it quite a bit. With larger hard drives, in order to be able to address everything, you have GPT, which has much larger, well, addresses. And it also resolved quite a few smaller issues with MBR, such as the number of partitions you could create. MBR originally was limited. It didn't have things like extended partitions and logical partitions, and well, anyway, it was a mess. So GPT solved a lot of that. So then how do you edit the partition table? Well, you can use the fdisk command to edit it. And once you edit the partition table, you write it out. And what it does is it writes out to your, well, either MBR or GPT, and that information is stored there. But then the kernel doesn't know about it unless the kernel goes back in and rereads that information so it knows about it. So you can use things like partprobe or other utilities to tell the kernel that it needs to reread the partition tables and reload that information, and then it can start using that information as it mounts partitions and puts them into its setup. So what partition types are good? Well, at this point, it's probably a good idea to actually create some partitions so we can get some ideas of how it works. So let's jump into it. I have right here settings. My machine is currently turned off. I can go over to storage and click on my controller SATA. and then I want to add an extra disk. So I create a new disk, and this will be a nice virtual disk, dynamically allocated, and I can go with whatever size I want. Let's just go with a 1 gigabyte. It's a nice small disk, and I can keep new virtual disk, or I can just say spare. Doesn't really matter what I call it. I create it, and then it's ready to go. Once my machine boots up, I will be able to use that partition or use that disk and make partitions out of it. So I'll go ahead and start that. All right, I kind of skipped through the booting process. Now I am ready to log in. So I log in as root with my password aloha123, and I go into my machine. Now at this point, I have the option of either using command line utilities or the GUI. You want to probably get used to using command line tools because the GUI isn't always there. But let's look at the GUI. So I click on applications and go down to utilities, and I can see there's this disks option here. I created my old disk, and that one is 32 gigabytes, and then the new one is 1.1 gigabytes, and it's all unknown space. Now you can also see the device name is dev/dev/SDB. The first one is /dev/SDA, and I guess it's got multiple partitions in it, SDA1 and SDA2. In the SDA2, I can see that the partition type is Linux Volume Management, LVM, which means I can then create individual, volumes inside of that. The original one is a standard partition, and that one is where I have my kernel and other information stored. So I want to work with this second disk, and I can click on icons here and create stuff, or I can drop down to the command line to show you how that works. So go to the terminal. All right, so in order to build partitions, I can do fdisk -L to list all my partitions. It shows me I have a couple of different partitions. You can see there is a /dev/SDA and a /dev/SDB. SDB is 1073 megabytes. So I will go edit that one. So I do fdisk /dev/SDB, and I can use my M key to show me my options. This will list all the commands I can use. P is to print my partition table, and I have no partitions. So I want to add a new partition. So I do N for new. I can decide what kind of partition it's going to be. And this one is going to be a primary partition. So P, partition number 1. And I can decide what my first sector is. I can just press enter here and decide how big this is. I have a full gigabyte to work with, so I will make this first one, let's make it 200 megabytes. So I can do plus 200 M. It creates a partition. I can then use P to print my partition table, and I can see the type is Linux. Linux works great if I want to make a file system. Other options I can also list with the L option. And you can see there are quite a few different partition types. And all of these partition types are listed in hexadecimal index values or type values. So Linux is 83. If I want to do swap, it's 82. I can also do things like LVM and other partitions as well. So LVM is 8E. I'm going to leave this as a standard Linux partition type. So I will do write W, and then I will be out. At this point, I can type in part probe, and it does not have the command. So I can install it, yum install part probe, and it has no package there. So we will just go ahead and assume it's there, and the kernel will just have to figure it out. So the kernel will try to read it. So to mount this, you first have to build a file system. So which file systems do I have? Well, there's the mkfs command. If I run it by itself, it tells me that here are my options. But the nice thing is this is just a front end to the other commands. So I do mkfs tab tab, and you can see these are other commands that start with mkfs. So mkfs dot, and then you have different file systems. So let's go ahead and go back to the slides. All right. So which partition types are good? Well, you want to have Linux probably for most things. All right, what file systems are available on Linux? Well, we just looked at that. The mkfs command will show you which file systems are available on your system and which ones are installed there. You usually have a couple of different things to install. There is the programs or utilities type packages to go with things. So if I wanted XFS, which is already on here, there might be an XFS progs package, which would give me the XFS information. Some of these things require a kernel module to be loaded. Sometimes you have to do other things, but that usually provides the utilities you need in order to format the file system. So what is the difference between different file systems? Well, some file systems have features that other ones don't. For example, the FAT32 file system, which is very common in the older DOS and early Windows operating systems, has all kinds of features to allow you to create files and do things with the files, but it doesn't really have a lot with permissions. And in addition to not having permissions, it doesn't really have things like SE Linux or other security features that Linux has. It works great for cameras, it works great for computers that don't have multiple users, and that's really what it's good for. When you go to other file systems, such as ext3, that's what a Linux file system, ext3 is different from ext2 in that ext3 added journaling. Journaling is the ability to write to your file system and tell your file system what you're going to write before you write it, and then after you write it, you remove your entry. And this makes it in a state where you don't ever get to a place where you're in the middle of writing something and you have no idea if you've completed writing it, because you say you're going to write it, and then you remove the entry that says you're going to write it. And if you crash anywhere in the middle, then you can figure out where you were at. And you can back out of things if you can't get it completely done. ext4 has more features added. You have XFS, which also has journaling and other Linux type partitions, permissions, and other things like that. So which file systems are supported? Well, once again, you have this mkfs command, which will show you when you press tab twice which ones are available. You can install additional ones, and that's usually using the yum package management system to install other packages. Sometimes you'll have to go and make kernel modifications or get kernel packages as well, but most of these are packaged in a way that makes it pretty easy to get them. So, formatting. Why do file systems need to be formatted? Well, if you mark a partition you create as, well, you create this partition, it still is just a block of space. You have to decide how to put the file system in there, and the way you do that is through formatting. What formatting does is it starts writing the file system in the beginning and then puts in all the indications it needs through midpoints and other places in there, so that you can, well, start doing stuff. So let's go ahead and create a file system. So I'll jump right in here. So I'm going to create this one as ext3. So mkfs ext3, and the question is, well, which partition is it? Well, we know the device was /dev/sdab, and it's the very first partition I created, so it's /dev/sdb1. So sdb db and I can see a 1 here. So now I type in this, and it will create an ext3 file system. And that was quick. But there are other options you can add in there as well if you wanted to, such as labels and different things like that. So now that it's formatted, I can start using it, but I have to figure out where I'm going to use it and how I'm going to do stuff with it. So let's go back to our slides. How can I change how a file system is formatted? Well, let's go back to this file system and let's change it. I don't really want ext3, so let's change it to ext2. Now it's ext2. Let's change it to ext3. It's ext3. Let's change it to xfs. Now it's not xfs yet. It says that it appears to contain an ext3 file system. Use the -F option to force an overwrite. So I do -F. And then it reformats it. So now it's xfs. And then I can change it back to ext3 or ext2. And convert it back. All right. What happens if there's data on the file system and I want to convert it? Well, you can actually modify it in place for some file system types. For example, going from ext2 to ext3, all you need to do is add a journal. So if I do tune to fs, I have the option to add a journal to the file system. So how do you do that? Well, it's with the -J option. So I do tune to fs -J dev slash ext2, not ext2, sdb1. And now I've added a journal. So basically, I've now converted the ext2 file system into an ext3 file system without damaging any of the files on there. But there are no files. Not really. I mean, there's a empty directory for lost and found for if I lose things. But that's it. I could also do things like add a volume label. So I want to call this my maybe storage. It already has a journal, so I take that away, say fine. And I put this storage label on the partition. All right, on the file system. Now, if I want to use it, well, I just need to mount it. All right, let's go back here. How do I know if a file system has been formatted? Well, sometimes you don't. The easiest way to figure it out is you try to mount the file system. If you try mounting it and it doesn't mount, usually that's an indication that it's not done correctly. It does some auto detection. That helps a lot. Trying to format over it usually tells you, if you're trying to go to something like XFS, it will tell you that it has something there, but you don't always know. So what is mounting then? Well, mounting is where you take part of your directory structure and you link in this new partition into that structure. So you have a directory and your directory can then be redirected to a new partition, a new file system, and you can start seeing things. So where are the file systems located when mounted? Well, the file systems are just integrated into this entire directory tree. You can use the mount command by itself to see which ones are currently mounted. You can also see what mounting options were used when mounting. Mounting options are things like mounting it as read-only or read-write. You can mount it with information about how fast you can write to it, which users are allowed to do things, lots of things. Can you mount uncommon things like DVDs? Well, DVDs aren't that uncommon, but yes, you can mount them. You can mount them as actual DVDs, or you can even mount the ISO images. So let's go ahead and mount this partition we just created and formatted. So I have to figure out where am I going to put this partition. So I call it storage. It's a /dev/sdb1. So let's make a directory and we will mount it there. So if I do mkdir, I can create a directory. So I'll do slash, and let's say new storage. Doesn't really matter what I call it. And then if I look at my file system, there is this directory called new storage. If I go into new storage, there's nothing there. So I go back out of it. So I'm at the root of the file system, and I want to mount this new partition there. So I do mount, and I can tell the mount device SDB1 and the mount partition or mount point. So new storage. So I do that command right here, and it mounts it. If I go into this new storage directory, I can see there is a lost and found directory here. This lost and found directory is stored at the root of any ext type file system. So now I can see it's mounted, which is kind of great. Of course, if I reboot the system, it will no longer be mounted because I manually mounted it and it's not being automatically mounted. So that could be kind of a problem. So what is the file system table? Well, the file system table is a file on the file system that tells you where everything is mounted and how they're mounted. So I could actually have this directory automatically have my new partition mounted to it at boot time. So how do I edit this file system table? Well, use a nano or some other editor, and you edit the /etc/fs tab file. Okay. Then we have to figure out if it's working and look at what happens if I mess up. So I was mounting the device SDB1 to new storage. So I'll do nano. I'll tell the etc fs tab. If I go in here, I can see these are the partitions that are mounted. So I'm going to add a new partition here. So you first start with the device. My device is /dev/sdb1. You have some space, it could be a space, a tab. I just put a tab. My mount point is new storage. Then I have to tell it what type it is. This is ext3. Give it the defaults. And then these numbers indicate things like backups and other stuff. Just put zeros here, you're fine. Exit out. Now there's this file. Because it's mounted, well, I should be able to use the mount command and see that it's mounted. And you can see at the very last line down here, there is an indication that this thing is mounted. I can see which options are in place. It's read write. I can see it's mounted to ext3, and I can unmount it with the umount command. Umount /dev/sdb1, or I can tell it the mount point. So I can unmount it that way, or I can remount it and unmount it with the mount point. Either way, we'll get it unmounted. Then I can run the mount command by itself, and I can see that it is no longer mounted. Now, if I try running the mount command, mount dev sdb1, well, what happens? It mounts. And the reason it mounts is because it looks at this device and says, where is that device at? And then it finds the fs tab file and sees the device listed in there as the last entry, and it knows where to mount it. So I run this mount command again, and I can see that it is mounted right there in this new storage directory. I can umount that again, new storage. And then if I want to mount the new storage, I can just tell it to do mount new storage, and it'll mount it because once again, it looks up in the fs tab or file system table file and figures out what it needs to mount and how to mount it. And then I type the mount command again, and once again see that it is mounted correctly. Now if I mess up this file, let's go ahead and mount it first, and then nano etc fs tab, and let's say I tell it some directory that doesn't exist, like new storage without the E. If I try mounting mount dev sdb1, it says mount point new storage does not exist. So if I try mount new storage, it says it can't find it in the fs tab file. So you can see what it's going on here. That's how it's doing it. Now imagine what would happen if you booted up your system like this and you had a mistake in there. Well, that could be bad, especially if it's a critical file system for your system to run. It could cause the entire system to basically crash. You don't want that. That's bad. All right, back to the slides. What features are available with a file system? Well, you have all kinds of features. You have the ability to read and write to files, edit files, set permissions on files. You can use things like SE Linux, disk quotas, all kinds of things. So permissions, how do they work? Well, the way they work in Linux is each file has some kind of an associated number. And the associated number indicates, well, what the permissions are. You have users and you have groups, and you can see all this information with the stat command. So if I go into my file system, new, let's create a new file. So I use the touch command. Oh, actually, it's not mounted, is it? Mount new storage. Go to new storage. Do touch new file.txt. If I do a directory listing, I can see that the new file is owned by root and it's 0 bytes in size. It's kind of a small file. If I do stat new file, I can get some information about this new file. I can see the size, I can see the blocks it takes up, other information. I can see information about inodes and links, and then I see this access permissions. Well, it says it is 0644. 0 in the front is for things like your set user ID and set group ID and your sticky bit. The 6 and the 44 indicate the user, the group, and the world permissions. You can see the owner is UID 0. The group is UID 0. You can see the SE Linux context is listed right here. Basically, it's kind of unlabeled. And you can see all the information about its access, modification, and change times. So that's all there. And that's all stored, most of that's stored right there in the inode, not the actual file name. It's stored in the inode that the file is linked to. So when you create a directory, your directory has a list of file names, and those file names are pointed to inodes on the system that allow you to then edit and modify the contents on the system. So how does SE Linux work on a file system? Well, you set your SE Linux context, and then the SE Linux piece is tied to the kernel, so that whenever you have access or try to access a file, it looks at the kernel, asks the kernel what it says. The kernel looks at SE Linux and says, yeah, you're allowed, or no, you're not allowed, and it blocks it. It doesn't matter what your permissions say. If SE Linux blocks you, then you don't get to the permission level and you can't see it. So that can be a bit of a problem. It also makes things a lot more secure if you have services that have to run as root and you really don't want them to be able to touch certain files. You can use SE Linux to block them from touching them, even if they have full root access, because they don't really have it with SE Linux. And the file system helps to support that. How do disk quotas work? Well, disk quotas, you have a couple of files on the system, and then those files are updated whenever you make modifications to the file system, and they then keep track of how much space you have, what you're allowed to do, and it protects it. If a file system is read-only, then you read things, but you never modify things, including the access times. Access times for files don't change if you're reading it from a read-only file system. Read-only file systems are great when you don't want someone to mess with something. So, anyway, that is your lecture on file systems. People and permissions. On a Linux machine, it's good to know which users are on your system. You need to know who's in there, what they're doing, and sometimes you need to work with the users. You need to remove users. You need to change passwords, delete users, create users, lock accounts. All these things can be done. So let's start with the beginning and look at a system. So here is a system fully logged in, and I can type in the W command to see which users are currently logged in. And I can see that I am logged in as root. Well, okay, that's nice. It looks like I'm showing up twice, 2 different root users. What's really happening is one is this GUI is logged in, and then from within my GUI I have a terminal up and going, and inside that terminal you can see I'm running the W command to see, well, who's logged in. You can also use the last command, last, and it will display all the users that have been logging in, when they logged in, what happened when they logged out. You can get an idea. You can see that down here a few days ago the Joseph user logged in and apparently logged out at a crash. So the system must have crashed for some reason, and that's when the Joseph user was logged out. Ever since then, the only user that's been logged in is the root user. There is also the reboot user, which apparently logged in probably from the GUI when the system was rebooted or shut down. So that gives you an idea of what happened with the system. You can also see, if you jump back to the W command, you can see things like how long the system has been up. And it looks like it's been up for 48 minutes. So gives you an idea of what's going on. All right. So what are they doing? Well, the commands right here is what they're doing. So then how do I create new users, delete users, change passwords? Well, let's start with changing Joseph's password. So I do PASSWD Joseph. I'm logged in as root, so I can change Joseph's password. If it was Joseph, he'd have to type in his password and then type in the new passwords. But I can just set the password for Joseph. So I'll set it to aloha123, then aloha123, and it's set. If it doesn't like the password, let's say I do something like ABC, it says the password is shorter than 8 characters. Type in ABC, it will still change the password, but it's not as happy. It just warns you. I can still change it back to whatever I want though. All right, so now the password is set. If I want to create users or delete them, there is this user del or user add commands. So type in user and then tab twice, and you can see there's user add, user del, and user mod are the good commands I can use. So if I do user add and hit it by itself, it'll tell me all of the information about this command. Okay, well, so how do you use it? Well, user add and then the login name. But before that, you can put in a bunch of options. So what options do I want to use? Well, I want to tell it things like, I don't know, the comment. The comment is usually the user's name. I can tell it any groups I want to add it to. I can do the primary group or secondary groups. Just remember, lowercase g is your primary group, capital G is your secondary groups. Anyway, those are some nice things you can do there. User del, same thing. User del, the big difference is that you can decide what you want to do with the directory. So usually I do a -R option to remove the directory when I delete the user. Now, if there are important files in that directory and you don't want them to be deleted, you could remove the user without the -R option, but remember that the user's files are tied to the user ID, and you would have to go in there and change the user ID or change the user ID of the files in order to make sure that the new user, if you create a new user afterwards, doesn't get those same files. All right. Can I lock accounts? Yes, you can. But that requires understanding basically how things work. When you have a user and you have a password, if I look at the etc shadow file, that's where the passwords are stored. You can see that this user, Joseph, has a long password thing right here. It's actually this long section right here is my hash. The first part of it, the $6 indicates which method I'm using. From here, I can see that my salt, this is a random string of characters mixed in, is, well, this. And then this salt gets combined with my actual password using method number 6 to generate this long string right here. And then whenever I type in my password to log in, it will take my password I type in, combine it with the salt, use method number 6, and then see if it generates this exact same long string right here. And that's how you do password calculations. So if I want to prevent someone from logging in, all I have to do is modify this right here so that it doesn't work correctly. So if I do a user mod minus capital L Joseph, it locks the account. So if I cat this, well, let's do a grep Joseph, you can see that something happened. What changed? Well, if you look at it, it's almost exactly the same, except there is now an exclamation point at the very beginning. And that exclamation point makes it so that my account is locked. I believe I can unlock it with a minus capital U. And then I can see that it has removed that exclamation point and it's no longer locked. So that's how you lock accounts. Groups. Well, what are groups on my system? There is an etc groups directory or etc groups file, and in it, it lists all the groups and it lists who are the supplementary users of those groups. So who is a member of each group? Well, you can see the supplementary members there. Primary users don't always show up. Sometimes they just get it because it's assigned as their group. You can use the ID command to indicate which groups users are part of. And so I can type in ID Joseph to figure out which groups he's part of. And, well, let's go look at that. So ID Joseph. I can see that Joseph is got a GUID of 1000. That means his primary group is, well, the Joseph group. His supplementary groups are Joseph and Wheel. So if I cat out the etc group file, I can see that, yes, Joseph is part of the Joseph group as a supplemental member. And then if I scroll up a bit and find the Wheel group somewhere, you can see that the Wheel group has right there Joseph as a supplemental member of that group. I could go in and add them to other groups by just modifying this file, and that would take effect the next time you logged in. So that can be useful, but you can also use the user mod command to modify him and add him to extra groups. The Wheel group is actually tied to the etc sudoers file. The sudoers file says, well, okay, down here, all people in the Wheel group can run all commands as root. So this Wheel group right here basically means that my user Joseph has the ability to use the sudo command, sudo, and then run something that only root could run. So like ls/root. Of course, I'm logged in as root, so root can do that. But if the Joseph user were to do that, He would be prompted for a password, and after being prompted for the password, he could, well, run that command. If I wanted to change that, I could go ahead and modify this sudoers command and take this one right here, right below it, without a password, and take out the hash mark, and then hash the one right above it. All right, so that's this group thing right here. When you have files, you can see there's a group owner and there is a regular user owner, the owner, and then the group owner, and then the permissions are set appropriately. So this is the user permissions and this is the group permissions. You can set files so that a group has access to the file, and then if a user is not the owner but they are part of the group, they will still have access to the file with whatever permissions are set. If you don't put them in the group, then they would be stuck with whatever the user, the world permissions are set at. So how do I create and delete groups? Well, group add, group del, just like the user add, user del, except it's much, much quicker. How do I modify group membership? Well, you can modify it using the user mod command or by modifying the group file directly, group file directly. The etc scale directory is really interesting. When you create a new user, the question is, what files do you put in the directory? What files do new users get automatically? Well, they get everything that's in the etc scale directory. All right, so let's go modify that. So if I jump into this directory, so I go etc scale, I can see what they get. They get a bash logout, a bash profile, and a bash rc file, and they also get the Mozilla directory. So I can create a new directory, public HTML, and I can see this new directory here, and then any users that are created now will automatically get this public HTML directory. So if I look in the Joseph directory, he does not have the public HTML directory. There's no public HTML because, well, it didn't exist in the scale directory when it's created. If I do user add -c Alice, and her username is going to be Alice. Now if I look in the home Alice directory, I can see she has the public HTML folder, and she has everything else that was in the scale directory. And not only that, but you can even see the date that these things were added to the scale directory. So if I look in here, you can see April 15th for the public HTML. Once again, April 15th, everything matches. It's just a direct copy of what is in the scale directory. Okay, so that's the scale directory. It's kind of useful. You want to make sure you set it up before you create users. Otherwise, you have to go manually back and create it. So I look in the Joseph directory, and you can see there still isn't a public HTML folder there because it wasn't in the scale directory when his directory was created. How are regular users and root users different? Well, root has access to all kinds of amazing things. They can edit all kinds of files. They can edit anything with that they don't even have permissions for. They can change permissions. They can change ownership of any file. So how do regular users get the right of root? Well, we looked at that just a moment ago. There's that wheeler group thing. With the wheeler group, sudoers, you are able to run command with the sudo command and access things that root could access, because you can run these commands as root. So what can regular users do if they do not have root rights? Well, they can ask for somebody with root rights to do it for them, or if the root user wants to, it can grant them access so they can do it with the sudo command themselves. What do the RWX permissions mean? Well, R is read, W is write, and X is execute. And that means different things in different contexts. For example, if it's a R and it's a directory, it means you can read the contents of the directory. That means you can see which files are in the directory. If it is an R and it's a file, it means you can read the file. W means you can write to it. You can write to the directory, you can write to the file. X, if it is a file, it means you can run it as a program. It can execute it. X as a directory means you can get into the directory. So that's what executing a directory means, is going into the directory. So can a directory have the execute permissions? Well, we just answered that. Yes, it can. What are sticky bits? Okay. Well, before that, you have these permissions, right? RUX, but you have one more permission. So let's take a look at some permissions in, well, this directory, for example. If I do stat and I look at my desktop, I'm in the wrong directory, aren't I? Let's cd back to my root directory, stat desktop. I can see it has these permissions. A 0, 7, 5, 5. Okay, 7 means that it has read, write, and execute. 5 means it has read and execute, read and execute. So that's good. If I create well, let's take a look at the command. If I want to change my password, I use which user bin password. Now, the password command itself edits files that only root has access to. So the question is, how does a regular user run or change their password? Well, they can't. A regular user cannot change their password. The only way they can do it is if root does it for them. So if I do a stat on the user bin psswd command, I can see it has a 4755. The 4 gives it puts this little lowercase s there. And it means that it will run as a root user. So the 4 means it runs as the root. And if you had a 6, that would mean it would run as both the root user and the root group. And then that last bit, the 7, if you went 7 there, is the sticky bit. Sticky bit means that when you run the program, it stays in memory instead of being flushed out regularly. So that could be useful if you're running a program regularly again and again and again. But these are the set UID bits and the sticky bit. So let's go back here. How do programs run as different users? Well, you can use the set UID bits, and that's basically how you do it. If they have the set UID bit, it will run as the user, as the owner of that file. Is a set GUID, it will run with the group set as the group owner of the file. And we talked about the file and directory permissions a little bit. Let's talk a little bit more about file permissions. If you want to run a file, you need to have the execute bit set, right? Well, what if you are running binary files, it just needs execute bit and it runs. If it is a shell script of some sort, the way it actually works is it starts running, it looks at the very first line, and that very first line gets executed, and it passes in the contents of the file to that first line's program, which then runs it. So the very first line of a script is the interpreter. So if you're writing a Python script, it would be a hash mark, exclamation point, and then the directory and path all the way to the Python binary. So hash, exclamation point, slash user, slash bin, slash Python, or something like that. And then what happens is that program is run, and it's passed the URL or the location of this file, and then it tries to read the file. So if it is a script, it needs to have the read bit set, otherwise it will not be able to actually run the program. So binary programs just need the execute bit set, and scripts need to have both the execute and the read bit set. All right, so what are default permissions? Well, so if you are creating new things with root usually creates new files, and it has read, write access to all of its own files. But if a user sets it, it also has read, write set, but the user sets both the owner and the group permissions, and root sets basically just the owner permissions to be something that's open. And the reason for that is to prevent root from accidentally giving too much rights to things it doesn't want to give rights to. And that is all set with the umask. So let's go ahead and take a look at that. We jump in here and type in umask. You can see my umask for the root user is 0022. What does that mean? Well, if you take whatever it is, so if it's a directory, it normally starts with 777, or you assume 0777, and you subtract that. So a 0777, you're looking at taking 077 off of that, and you end up with a 755. And if you are a regular user, it would be set to a umask of 0002, and that would give you a 775. So imagine your permissions of 0777 minus 0022 for a directory will give you 0755. And for a regular user, your mask is going to be a 0 here, which will give you a 7 here. So that's kind of the idea. So you can change your umask if you want to, someplace along the way in your bash profile or bash RC or something else, and that will get you changed, but you can leave it alone, and that's what happens with the default permissions. chmod and chown. So chmod is to change the mode, or basically change your permissions, and chown changes your ownerships. So how do I change permissions on a file or directory? Well, you type in chmod, the new permissions, and then the name of the file you want to change it to. Chown, you can do chown, the new user, and then the file you want to change. And then you have both a binary and non-binary representations we can look at. So I'm in my directory. Let's go make this new directory temp, and go into the temp. I can see there's no files here. Touch A, B, and C. Now create 3 empty files, A, B, and C. I can type in chmod, and right now their current permissions are read, write, and read and read. So chmod, and I will do group plus write for A. So I added the group write. So if I do ls minus l again, I can see now it has the write for the group. I can do let's say B, I'm going to do a group plus write, and I'm going to do other minus read. So I'm going to add write to the group, and I'm going to subtract read from other. Now look at it again, and you can see that it has these permissions right here. So if you look at these things, they're all kind of like binary numbers. Well, they don't look like numbers, they look like letters, but if you think of it, the first one has a value of 4, the second one has a value of 2, and the last one has a value of 1. So this first one right here, A, well, it's got 6, 6, and 4. 6 because of 4 plus 2, 4 plus 2, and then 4. If I do a stat on A, I can see that it is, in fact, 664 right there. What if I want to change it to something else? Maybe I want it to be executable. Well, the execute bit is the one, the very last one. So if I do chmod 775 on A, and then I look at it again, 775 makes it read, write, execute, and then read and execute. If I want it to be just executable and no read, no write, then I can do, well, 111. Look at that again, and you can see that it's just execute bits. If I want to make it just writable, then I can make it 222. And you can see that now it's just writable. And if I want to make it just readable, I can do 444. So you can see you can mess with the permissions with chmod and set them that way, both binary and with other things. And you can learn about that more using the man chmod command. You get information about all the different modes and options you have here. And Q for quit. All right, what if I want to change the ownership? Well, I created this new user Alice, so I do own Alice. I set the user, and I want to maybe I set her to the group Alice A. So now look, and it is now owned by Alice. The Alice is both the owner and the group owner. They're both named Alice. And that's how you change the ownership of files, is with own. All right, SE Linux. What about SE Linux? Well, SE Linux allows you to control files and control access to the files. SE Linux was created by the NSA. So the big question that pops up is, can we trust them? Well, NSA is a group of spies, right? Can you trust spies? Well, they actually did this for their own selfish reasons, because they were required to have mandatory access controls, and Linux didn't really have good mandatory access controls. So SE Linux was built there. SE Linux is the security enhanced Linux. It provides mandatory access controls. So files have these different contexts, and you can change it. And if you mess it up, bad things happen. So let's go look at some files right here. If I do ls minus capital Z, I can see these all have the admin home T context type. You can also see which roles and the user stuff, but we can really ignore that stuff. All we really care about is the type for most of what we're doing. So I can do a chcon for change the context type, and maybe I want to change this from admin home T to conf T, and then change A. Okay, maybe conf T isn't a valid argument. Well, let's see what other types we have. Down the etc directory we have, let's do a capital Z. We can see we have etcts. Let's make some of those. So I look at that, and we may change this one to an etct. And now I look at my directory right here, and I can see that it has been changed from an from an admin home T to an etct. If I want to change it back, I can just use the chcon command again, or I can use restore con A, and it will restore it back to what it thinks it should be, which might be correct, it might not be. And you can see it changed back to the admin home T. This is important because some programs are set to only be able to read certain types, and that becomes critical when you start doing things with a lot of servers. But just to be aware that you can do that, you can look at the types and you can change them. And that is it for our peoples and permissions. Software repositories. When you're using Linux, one of the big questions that come up is, what is the difference between Linux and a Linux distribution? Well, Linux technically is the kernel of the Linux distribution. So what we have is we have a system which is a collection of software.
And the main piece that runs your operating system is your Linux kernel. So a kernel is the only program that is allowed to access memory, access the hard drive, lots of CPU things. Lots of these things are restricted to just the kernel. So when a computer starts up, what it does is it starts up the kernel. And the kernel is then able to start the other programs that then run. So then you have this thing called kernel space, and you also have this thing called user space. And things that run in the kernel have access to the physical hardware, and things that run outside the kernel have access to asking the kernel for things. Well, the kernel only manages the hardware and other programs and doesn't do a whole lot of user-specific tasks that users see. If you want to run a GUI, that's not run in the kernel. If you want to have a command prompt, that's not in the kernel. All these things are run by external programs that are outside of the kernel. And then you take all these programs that are run outside the kernel and you gather them together to make a working system. The kernel is the main piece, the brain that runs everything, and then all these other things are what makes the user experience. So Linux is the kernel, then a distribution is that big collection of software. People can decide which pieces of software they want and collect them together as a Linux distribution. So you'll see sometimes people say GNU Linux distribution. GNU is a project that includes lots of different commands that you'd use. Your shell, all of your commands to change ownership and change files, and all these things are commands that are written to access or to make requests from the kernel and have the kernel do things, and also provide an interface for users to type things. So the GNU project got combined with the Linux kernel and created this GNU Linux thing. And then you have other pieces of software such as your databases and your GUIs and all these things thrown together, and it makes a Linux distribution. So can Linux be installed without a Linux distribution? Well, kind of. Yeah, you can install it without a Linux distribution. But basically what you're doing is you're installing the kernel, and then when the kernel runs, it won't be able to do anything. So you really need something. Linux needs to be able to start something that you can use to run the rest of the system. So sometimes you'll have Linux kernel show up in things like Android phones and other devices, but those are still Linux distributions of some sort. So why do we need Linux distributions? It should probably be obvious at this point. You need Linux distributions because you need to be able to do something more than just work with the hardware. You need to be able to work with the users as well, and that requires the Linux distribution. So what do Linux distributions leave to you? Well, Linux distributions come with a set of software, and they assume that this is the software that everyone or most people will need, and they bundle everything that's very common together, everything that makes your system work. At that point, you need to decide which other software packages you want to install. If you want to build your own software packages, they're not part of your Linux distribution. Some distributions come with compilers, some don't. Some you have to build them or add them later. Sometimes they're in a Linux repository. You download them and you get them installed in your system. Sometimes you have to manually go and grab things and build them or install them yourself. So, repositories. What is a repository? Well, the Linux distribution usually comes on a DVD or some bootable media, and then you install it, and it gives you your basic set of files. However, the DVD might not be updated on a regular basis, so that could be a bit of a problem. You might have a bunch of old files that need to be replaced. Additionally, you might have programs and files that you want in your system but are not part of the standard Linux distribution because they're not very common, or they just assume that most people won't need these. They've taken what most people want and put there, but a DVD is limited really only to about 4 and I have gigabytes of data. So all the other things you might need but aren't on that DVD are stored in repositories. So a repository is basically like a website with a base file that indicates what files are there, and then it has references to everything else. Inside these files, you also have information about what packages need. You need to know which dependencies each package has, and this is all stored kind of in the repository so you can download and build packages. So what's the difference between a repository and Linux distribution? Well, the repository is your extra stuff. It also includes your Linux distribution as well, but it's everything else you need. It could be terabytes of data, terabytes of files and programs, different versions, different things you might need to install in your system. A Linux distribution is more of this smaller, confined grouping for getting you started. So what repositories, or which repositories, does my system have? And how do I add additional repositories? And why would I want to add more repositories? And then are there disadvantages? So let's go ahead and take a look at a Linux system. So right here we have a Linux system. So if I go down to the etc directory and I go into the yum.repos.d directory, I can see a list of files. And all these files have the repo extension. These are my standard repos. So I can go in here and I can look at each of these files. So the CentOS base, let's take a look at that. CentOS base. And I can see that it has a bunch of comments, and then it has this base thing. And it looks like a name, and then it has this mirror list, base URLs, GPU check, things like that. So what do we have here? Well, the name is the name of the repo. The mirror list is where you're going to find your files to download. You have this base URL as well, which gets you started there. The GPG check basically says, well, these packages could be signed. Do we want to check the key to make sure they're signed by the person who's supposed to sign them? There's this whole public key, private key thing. And once the repo is installed, you need to accept the key, and then any packages that are created and added to that repo get signed with their private key, which you can then verify with this public key. And the public key is right below in GPG key. So this base contains a whole lot of files. And then after that, you also have updates, extras, different repos that you can look at. There's also one thing you want to look at, the very bottom one, CentOS Plus. There is enabled equals 0, which means this one is not part of your lookups. So how does this work? Well, when you want to install something, it has to go look in the repos, you have to download files. Let's add an additional repo. So one that's very common is the epel release, or epel repo. So I do a yum install epel release. This is a package that will give me the repo files for the epel repo. And you can see right here at the very beginning, it did loading mirror speeds. You can see it's looking at your base, your extras, your updates. These are repos that are active, and it's going through and grabbing these and checking these, making sure that you have everything you need. It looks at the dependencies in order to get the epel release, figures out if there's any dependencies that need to be installed, and there aren't any, and then asks me, do I want to download and install it? And I say yes. I could do D for download and just download it and not install it, but Y for downloading and installing. And then it installs this epel release. So then if I wanted to do a yum install epel release again, it's already installed, but you'll see, looks like my GUI decided to take over. I can kill that process. Sometimes the applet on the desktop decides to take over. Alright, so I yum install epel release. And now you see, in addition to checking base, extras, and updates, it also checks epel to see if there are packages here. Now if I take a look at my directory again, I can see that there is a new set of files right here. There is the epel repo file. So if I take a look at that one, I can see it has a list of things as well. I can go through and I can disable the epel if I want, or I can leave it enabled. You can see there's two other ones right here that are both listed as currently disabled. If I wanted to get the debug info versions, I could just turn on this one right here and probably turn off the other one. If I want to get source code, I could get the epel source and just enable that one. If I wanted to install a package from the epel release, Alpine, which is a great mail client based on the Pine client, is part of that. So you do yum install Alpine, and then it looks and it says, okay, you want to install Alpine, and it says Alpine right here. It says Alpine is part of the epel repository. It also requires mailcap, which is part of the base repository. So you can tell where it's getting it from. So I do Y. It downloads this mailcap, and then it says, wait a second, we don't have the key installed for epel. So I look at it and say, do I want to install it? Yes, I want to install the key. And I install the key, and then it installs both of the packages. So that's how you get the new repo. That's how you use it and get it in place. All right. Where are the repository files stored? Well, that's in the etc directory, etc yum.repos.d directory. So you can see those. Can they be edited from the command line? Yes, they can. You can go in there and change them. You can disable and re-enable them. You can also remove these on the command line. So you can delete the repo files. Once you delete a repo file, it will remove the repo from use, and you will not have to worry about it taking up memory every time you do a yum update. Also, it doesn't then give you the option of downloading the packages from that repo, so they are removed. How do I update packages on my system? We have a system, and I probably have updates. So how would I update packages? Well, let's go take a look. If I go back over here, let's clear the screen, and if I do a yum update, it will then check all my repos, and it will see I have lots of packages that need to be updated. So I can say, okay, let's update them all. So I do a wide update them, and then they start updating. The first thing they do is they start downloading, and after they've downloaded all the packages, then they will start installing the packages. Now, if you have not accepted your key before, it will then require you to accept your GPG key before it will install the packages. How do I search for new packages or for new programs provided by the repository? Well, you can use the yum command once again. You do a yum install to install things. You do a yum update to update. If you want to search, it is a yum search. So if I wanted to find something such as Alpine, which I've already installed, I could do a yum search Alpine. Now that could be quick, could be slow, but much faster than just going to the web maybe. Sometimes the search will not tell you which package to install because you use the wrong search terms, so keep that in mind. It doesn't find everything always. How do I install new programs from a repository? Well, you use the yum install and the name of the package you want to install. And then how do I know which packages are installed? Well, there are a couple of different ways you can look at that. When you use Yum keeps track of all the packages that are installed in your system. However, there is the possibility to go around that because Yum is actually a front end for the RPM package. So RPM is what's used to actually install and remove packages, and Yum is a front end that downloads repository dependencies and everything and installs everything and keeps track, but you can look at things with RPM by itself. So let's jump back over here, and we have everything installed. If I do a RPM minus QA, I will query all packages, and this will list all the packages that are installed on my system. You can see that there are things like, well, there's a name, the name of the package, you have a version number, you have a release basically for which repo, or not repo, which distribution it is, and then which architecture this is specific to. Most of these you can see is x86-64, which means it's the 64-bit version for the x86. So it runs on the newer processors. No arch means that it's really configuration files or something that doesn't depend on a specific architecture. If I wanted to do a update of something, I just update everything, but I could do a Yum update and list a specific package like nmap. It will check to see if there's any new updates, and there are, well, none. If you want to install a package that isn't installed, let's see if we can find something that's not installed. So maybe bind Yum install bind utils. Well, it's already installed. So you can install packages that way. If I want to search for something, I can do that. Let's say I really want to run a web server. So I can do a Yum search web and see what shows up. It shows everything that has web in either the name of the package or in the name of the, or in the description. You see lots of things here. It's usually best to figure out what package you want to install, and that helps you narrow it down. So if you did a Yum search for web server, you might find a shorter list which might include what you want. Now typically people use Apache, and Apache is not listed in this list of packages. So how would you look for it? Well, you wouldn't search for web server because that didn't work. You might have searched for Apache. And then you come up with this list that includes other things. You got like Apache Commons and all kinds of things. And you start saying, well, which one is it? Which one has Apache? Well, it turns out it's the HTTPD package. And you can see httpd.x86_64 is the name of the package. It's actually, the package is called HTTPD. This is the architecture, and this is the description. So if I want to install the Apache web server, I do a Yum install HTTPD. And then you can get it installed. So now we know how to install packages, how to update packages, and we also know how to figure out which packages are installed on the system. And this is your brief overview on using software repositories. Programs and scripts. So what is the difference between binary programs and text-based scripts? Well, binary programs are basically programs that are files made out of machine code readable stuff. And then text-based scripts are human readable programs. So when you run a binary program, well, there's multiple parts to a binary program, but one of the main parts is you have actual machine code that is understood by the CPU, directly. In a text-based script, what you have is human-readable code that is interpreted and converted to instructions as it runs. So the binary programs are going to be much faster, and the text-based stuff is going to be much easier to read, modify, and update. So how does the operating system tell the difference? Well, there are pieces in the very beginning of a program that indicate what it is. So for a script, they all start with the hash and then exclamation point. And after that, they have the name of a binary program that's going to be run. And then what happens is it reads that, it sees the name of the binary program to run, it runs that program, and then passes the script as input to that program. So that causes the interpreter to then interpret that script and run it. So how do users tell the difference? Well, it's pretty easy. You just open the file and take a look at it, and if you can read it, it's probably a script. If you can't read it, it's probably not a script. How are they made? Well, you use text editors to create your text-based scripts, and you use compilers to take source code that's made with a text editor and convert that to binary. So the conversion process happens with a compiler. So what is a compiler? Well, a compiler reads through a source code file, and it will then interpret and figure out what this means and convert it into binary data that can be understood by the CPU. It's the same kind of thing as an interpreter, but it converts it all the way down into binary and stores it as binary. They still have to do the same kind of thing as interpreters because they both have to read what the human readable version is and understand it. So why would I want a compiler? Well, you need a compiler every time you want to write binary or create binary files. And that could be because you need to download some source code someone's provided. You need a compiler to do that. And you also need it if you're going to create programs that are not going to be script-based programs. So which compiler should I get? Well, that depends on what the source code is written for. There are multiple different compilers out there, but the most common one on Linux systems is the GCC compiler. So it's the GNU compiler. And that one is the one that I would recommend, especially if you don't know any other one that you need. Although it is possible there are some minor differences in the source code, and different compilers will be required to do different things. So you need to make sure if you download some source code from somewhere, you figure out if it requires a specific compiler or if it'll work just fine with the GCC compiler. So building source code. Where can I go to get programs that are distributed as source? Well, a lot of people go to GitHub. You can go to GitHub and you can download source code there. You can also go to other source code places such as SourceForge and download your source code there and get it. Many different people who are creating projects have a source code distribution that you can download as well. But then you have to figure out how to build the source code programs. So how do you do that? Well, that can be tricky because sometimes you have all kinds of libraries that need to be compiled and built into it. So you need to make sure you have all the libraries, all the dependencies, everything. You need to make sure you have the compiler, one that'll work. Then you need to sometimes run scripts on it to then prep it up. Sometimes there are configure scripts that will check your system and see what hardware, what packages you have, and then customize your build to use that. Then they have makefiles. Makefiles, you run the make command, and that will install all of the, well, it'll build everything according to the makefile instructions. So that seems kind of complicated and difficult. So why would I want to build my own programs or build them myself? Well, you want to build them yourself because it gets more efficiency, or because they are not built, or maybe you want to make changes and you can't make changes to someone else's binary very easily. So you need to build them yourself. So how then are source code projects installed? Well, what happens is if you use a package management system such as an RPM package, it installs and it puts files all across the system in different places, but it keeps track of where they're at. If you do a source code project, you can do the same thing. You can put them all across the system wherever you need to put them, and then you need to keep track of where they're at, or you need to make sure there's some way, some script in there to remove them, because otherwise removing them can be very difficult. So, what does a Hello World program in C look like? And how to use the GCC compiler to convert source code to binary. And then we'll just look at the makefile and then how to run the binary program. So let's jump right in here. So let's make a file. So I'm going to make a directory first. Just make dir, and I'm going to make this the hello directory. And I go into hello, and now I'm going to create a file. So I do nano hello.c. So your C files end up with the C extension, and in it you have to tell it you are using your libraries, stdio, standard input output, each, and then in main, you have to have main function. You can pass the variables here, or you can just skip that and go directly into your main function. And in the main function, I can do a printf to print hello world. I have a new line, so it's not on the same line. And then I want to make sure I have a return value so that when the program ends, it knows that it returned successfully. Return 0. So that's really about it. You can do much more complex. You can add things like int arg c, char, maybe star char arg v. You can do whatever you want here, but you pass in variables. Anyway, let's go ahead and save that and exit out. Next, I want to compile it. So I need to use the GCC compiler. If I try running it right now, I don't think I have it installed. And it says command not found. So I need to get my compiler. So I could search for the GNU compiler and find it that way, or I can just do yum install GCC. And that will get it right here, get it all installed. And that's kind of quick. The compiler does take a little bit of time. It's a little bit bigger than the average package, but it's not too hard to install. I get it installed, and now I can try compiling again. So I do a yum install, actually not yum install, do a gcc hello.c. And I take a look at my directory, and I can see I have two files now. There's the a.out and the hello.c. So if I do /a.out, it runs hello world. If I don't want it to be called a.out, I can change what it's saved as, or what it's created as, in the command gcc hello.c -o for output hello. So I want it to be called hello. So I do that. It creates, instead of the a.out, it creates a hello dot, or just a hello binary. You can see it's the same size as the a.out. If I run hello, it runs. And the way to run it is, because the current directory is not my path, I have to tell it a relative location, which is the period directory's current directory /hello. So then what's this whole thing about makefiles? Well, if I do a nano makefile, I can go down here and I have my hello. In order to create hello, I need to make a hello.c file. And every time hello.c changes, I want to run this command right here, which is gcc hello.c -o hello. I can also have another option here, so a clean maybe. And I want to remove hello. So it removes the hello binary. Exit out of that. So I do a make, and it says hello's up to date. I do make clean, and it removes the hello. So do a ls -l. I can see that hello dot C is there, but hello is not there. So then I do a make again, and it compiles my hello program. So that's how I convert my source code into a binary file using GCC and also using a makefile. Gives you a bit of an idea how it all works. Alright, how to run the binary program? Well, you want to make sure you tell it which directory it's in, and then you run it. So period / the name of the binary program. So what does a hello world program look like in Perl, Python, or Bash? Let's go back in here and take a look at each one of these. So Perl. It uses the Perl executable. So if I do which Perl, I can see it's in user bin Perl. Now, a source code file, Perl usually has a PL extension. So I do nano hello.pl. I want to tell it right here to use user bin Perl, use that binary, and then when I run it, I want to do a print, and I want to do hello world, and then a new line, and a semicolon afterwards to print hello world. This right here basically runs with this stuff in the beginning. It says, okay, this is a script. I'm going to run this program, and I'm going to pass it this entire thing as the input. So exit out, save that. Now, I can see that the permissions are not set to executable on this PL thing, so I need to set them to executable. So do chmod 755 hello.pl, and then I do period / hello.pl and oops, .pl, and that runs. Now let's try it with Python. Nano hello.py. This one's a little shorter. Well, not shorter. User bin Python print hello world. You don't need the new line character, and you don't need the exclamation and the semicolon at the end either. This will just work like this. chmod 755 hello.py. Run that hello.py, and that runs. Now, bash or shell scripts use the echo command. So I do nano hello.sh, and I don't need to tell it an interpreter. I could, I don't need to, because it'll just assume if it's a text file, it's got to be run as a, well, as a script. So I do echo hello world, and that's it. So I run that. Oops. Sh. hello.sh, and that runs. So those are your shell scripts. You can see how they look. The shell script could be done as a, I could actually pass it the bash if I wanted to. So do which bash, which is user bin bash, and then do nano on my hello.sh, and I can put that line at the top. User bin bash, and it will run the same. And there we go. All right, so multiple different ways to write a program and make it work. Standard in, standard out, and standard error. So how do I use a text file for the input to a program? Well, many programs can receive input and you type in input. What you can do is redirect these things. So standard in is whatever you type in from the keyboard usually. Standard out is what you print to the screen. And standard error is what you print to the screen if you can't see things, if you wanted to put out error messages. So how do I redirect from standard in, or from a file to standard in, or out from standard out into some other file? Let's go ahead and take a look at some of those things right now. If I do a command like cat, it's now taking input from my command prompt. So I can type things in here, and then Control Z to end. Well, that doesn't end. Control C maybe to quit. Or I could do Control D to end. That's what it is. What I can do is do cat, then redirect from output, or redirect the output into this new file.txt, and then I can type in things right here like hello new file. Press Control D to end that. Now if I take a look around here, I can see there's a new file.txt. I cat out this new file and see it has contents. I could do something like ls-al, and that lists the directory. Then I can redirect that into new file, and it will replace the contents. So then if I cat out the new file, it will list what was in the new file. I can also redirect standard in, or redirect it so standard in comes from something else. So the cat command, we just saw cat. I can, instead of typing something in, I can say, well, I want to get my hello.c file as the input to cat. And then I want to redirect the output into my new hello.c. So what does that do? Well, it takes the cat command, it sends all the hello.c contents into that cat command, which just prints it out, and then it redirects the output into new hello.c. So if I cat out new hello.c, I would expect to see exactly the hello.c contents. They're the same. So you can redirect the standard in or redirect that. Then there's standard error. So if I do some commands, such as, I don't know, find, if I do ls-al dev, it does searching there. I could do a grep to search for something, grep. So I look for the word hello in the etc directory, all files. Some of these things are directories and I cannot search them. Well, I don't want to see this directory stuff, so I can decide I'm going to do this, but I don't want to see the errors, so I redirect the to into dev null, which basically throws it away, and then I see everything that doesn't have an error in it. So there you go. If I wanted to get rid of all the stuff that does look normal and only have the errors, I can get rid of my regular output and just see the errors instead. So that's redirecting file input and output. So let's clear that. Using pipes. Which character is the pipe? If you look on your keyboard, above the enter key, there is this, well, there's a slash usually. It's not always on the same place on every computer, but there is this vertical line. So let's use the pipe command. So if I run hello, /hello, it prints that. That's nice. If I run a different command, like wc, well, wc does word count. So I can take this and redirect the input into the output, or the output into the input of wc, and it says, okay, we have one line with 2 words and 13 characters. Okay. So now I want to try doing something more exciting. Let's do ls minus al. That's quite a bit more. I'm going to redirect that into WC. It says, well, 12 lines, 101 words, and 566 characters. And that's nice. What if I want to do something like sort this? I could sort it. Sort. Well, now these contents have been sorted alphabetically. Not quite the same thing, but I do that, and then I can run through word count. Same thing, obviously, but you know, it does sort it first and then runs it through. So you can run multiple different things and run multiple programs at once. Just have it pass the output into the input of the next thing until you're done. So that's pipes. File types. What types of files exist on Linux machines? Well, we have these different letters when I do ls minus l. D is for directory, L is for link, B is for block device, and C is for character device. So you can look around and see things. Do file extensions mean anything? Well, they're used by some programs, but they don't necessarily mean anything critical. What does the file command tell me? Well, it tells me something interesting. It tells me what the file is. So let's jump back in here and take a look. So if I do file star, it tells all these files what's in. So a.out is an ELF binary. Hello is an ELF binary. C is a C source code, ASCII text. You can see each one of these things, it lists what they are. So ELF is the the Linux file format for binary files, because it has not just binary code, it also has things like memory and other things all set up in there, and so it uses that. So you got to make sure you know how these things are. If it says ELF, it's a binary. If it says text, it's not binary. It's text, right? So you can keep track of those things, and that can be useful for figuring out what type of file you're working with. So the last thing right here is symbolic links and hard links. So let's take a look at them. So we have over here, we can do a symbolic link. So if I do ls minus, or ln for link minus s, I can do hello, because that's my program, and I want to make it a symbolic link, hello 2, and I can do a hard link with without the s, and do hello 3. So then I take a look at my directory. There's it again. So the ln does a link. The 2 created a symbolic link. What that does is it says hello 2 points to hello. So if I deleted hello, it would be gone. Hello 3 points to the same address of memory as hello. And you'll notice over here, there's this number 2. That's the number of links pointing to that actual content on the disk. 1, because it's just a link. It's telling where to go. The 2's right here are both addressing the exact same space in memory. So then if you edit them, if you edit any one of those 3, it will edit the same exact file. However, some editors, when they make file changes, will save a new file and then move the new file to replace the old file. So keep that in mind. When you want to unlink them or delete them, you can do either delete or remove, or you can do unlink. So unlink hello, and I look at my directory listing, and I can see that now the hello 2 says, oh, there's no hello. But hello 3 is still fine because it points to the memory. And the number 2 has decremented down to 1. So the hello 2 doesn't work, but the hello 3 still does because it pointed to the actual program. And then you could go and remove or unlink things like hello 2. Alright, so that's your symbolic links. And I think this helps you get an idea of how programs and scripts work on Linux systems. And that's it. Services and firewalls. On a Linux machine, one of the questions you might ask is, what is a service? And then a related question might be, what is a daemon? So a service is basically some program or something that runs in the background, something that serves requests and answers things and helps you work. So a web server is a background program that runs, and when requests come in from the outside, it receives these requests, processes them, and then sends out pages and information. So that's a service. There's also other services, such as a time service, which will sit there and periodically go and check to see what the time is, compare the time to its clock, and update the clock depending on the differences. So that would also be a service. So then what's a daemon? Well, a daemon is basically, or a daemon, is something that operates in the background. So basically the same thing as a service. So where did the name daemon or daemon come from? Well, there's this Maxwell's daemon thing where it just serves its master. So which services do I want running? Well, that can be a tricky question. It depends on what you're doing with your server or with your machine, what you're running, what you need to run, and how your machine needs to react. But there are some services that are kind of essential, not really essential, but kind of essential, such as the mail server. So all Linux machines, all CentOS 7 machines, have a mail server running. And the reason for that is not so they can receive mail, it's so that the other services have a way to communicate back to the administrator that something happened. So things like your cron jobs, your tasks, will send a message to the administrator when something produces output that's being run as a job, so the administrator knows something happened. So that can be useful. There are other services that keep track of things like if you're doing DHCP-based addressing, your DHCP service needs to run in order to maintain and update your lease so you don't run out of IP addresses. So then the question is, which services pose security risks? Well, any services that can be accessed from the outside or the inside pose a slight security risk. The more rights a service has, the more of a security risk that service becomes. Managing services. How do I know if a service is running? Well, on newer systems with a systemd as the service or the system running the machine, you can use the systemctl command for system control to check to see if a service is running. You can also use other programs to check to see which processes are on the machine and try to figure out if a service is running that way. It's probably easiest to use the built-in service checking utilities. So let's take a look at the systemctl command. So we have on a default machine a couple of services running. You can type in systemctl status, and that lists a whole bunch of stuff, which is kind of useful, but then you're like, well, what does all this mean? Many of these services you can see are running. You can see process numbers, what was used to start the services, and that can be useful. But let's say I want to look at a specific service. I want to know if the SSHD service is running. So I do systemctl status SSHD. Right here I can see that the service is running. The green active indicates that it is running. So you got to make sure you can keep that straight. The active green right here says it's running. Then you might see this other thing, enabled. What does enabled mean? Well, enabled means that it is not just running, but it will start at boot time. You also see this vendor preset enabled also. So when you install the software, it assumes it needs to run, and then it's currently set to enabled. If I wanted to not start at boot time, I can disable it. And if I want to stop the service, I can stop the service as well. So let's do a check right here. So if I do system CTL disable SSHD, and now I look again at the status, I can see that it is still active and running, but now it says it is disabled, so it will not start on boot time. If I do a stop on SSHD, the service stops. So if I do a system check again, I can now see it is inactive or dead, and it is still disabled. If I want to enable it, enable, and I look at it, you can see that it is enabled, but it is still inactive and dead. If I want to start it back up again, I just do a start. Now, one thing you might have noticed is when I disabled and re-enabled, what it was doing is doing something with symbolic links. You can see it created a symbolic link. So etc system system D system multi-user target wants SSHD service. So currently my run level is multi-user target multi-user. So in this directory, there is a list of symbolic links that include the SSHD.service symbolic link, and they link over to another place on the system, user lib systemd system SSHD.service, which is where the service scripts are actually located. So we'll be looking at that a little bit. So, will the services be running after I reboot the machine? All you need to do is figure out if they are enabled. And you can change that using the systemctl enable or disable commands. And you can start and stop them with the systemctl start, stop, and you can use restart as well. So how does the system use the scripts? Where are the scripts stored? What is contained in the scripts, and what does it mean? Well, so when you go over and you look at these scripts, so let's take a look over at them. First, we'll go over to the etc directory, system D system, and then multi-user target wants. I can see there are a lot of symbolic links, and these links link over to my actual scripts. And these are the services that start. In older startup processes, so we have a system D right now, but before that we had init. And init had this thing where each service had a number, and that number indicated the order in which it was started. And so that was great. You just need to make sure you know which number your service needed, and it would start before things that required it, and it would start after things that it required. So you just figure out what number they had, and you put it in the right place. This is different. With systemd, now it can look at the dependencies in there. So if you think about the SSHD service, what does it need? Well, it's a secure shell that you use to log in over the network. So what does it need? It needs to have networking working, right? So we cat out the SSHD.service. It shows us this is our OpenSSH server daemon. It's got some documentation information. It has to be started after network.target and the SSHD keygen service. So it needs to actually have a key in place. It wants the SSHD keygen service, And then it's got all these other pieces of information. Tells you things like how to start it, how to stop it. And that's all used by the system CTL command when it starts and stops things to make sure that things are ready. Also, when you're enabling it and you're booting it from the beginning, it will take a look at these things and figure out which services need to be started in which order and calculate out that little tree and then start things in the order to make them work. All right. NetStat. How do I know if my services are really running? Well, we've started the SSHD service, and systemctl tells me that SSHD is running. But is it really running? We know that the SSH service listens on port 22. So we want to figure out if it's listening on port 22. So let's go and take a look. So if I type in netstat, it lists all this stuff. And you can use different letters. So I want to make sure I use my TCP and UDP, and I want numbers instead of names, and all of them, so I do tuna. Netstat minus tuna. And then I can see this right here. My SSH service is running on this right here, which is useful information because I can tell, oh, SSH is listening on all IPv4 interfaces, and it is port 22, and it's in listening state. I can also look at this thing right here, and it says it's also listening on IPv6 interfaces, so all of those, and it's in a listening state. If I want to see a little bit more information, I can add the P option, which will show me which processes are running these things. So I can see that the SSH service right here is using the SSHD process, and you can see the same exact process ID number and program name is running on the IPv4 version right there. So IPv6 and IPv4 are both running. They're both TCP. I don't see anything with UDP, but I can see other processes here that are running and what's going on. So how do I know if there are any current connections? Well, there aren't any current connections right now, but if there were, you would see something about established connections, not just the listening. Because this right now is just listening, but no one's trying to connect to the SSH service. Nmap. Are my services visible from localhost? Well, that's an interesting question. So let's go back and take a look. So if I do a yum install nmap, and I recommend nmap to anybody who wants to be a decent administrator. It was considered originally kind of a hacking tool because you can scan ports and things like that, but well, it's useful for other things too. So nmap localhost, and then it comes back and says, oh, when I did a scan on localhost, these are the ports that responded. So one thing you want to pay attention to is it says not shown and it says closed ports. So what are closed ports? Closed ports are ports that when I tried talking to the ports, the kernel responded and said these ports are not open. And that means they got past the firewall. Then I got this thing right here where it says these ones right here are open. Okay, so SSH is open. SMTP is my mail service and it's open for at least localhost, so local connections. RPC bind is for some things like network file system and NIS, some of these things. And then there's the printing thing right here. So IPP for your internet printing, that is actually run by the CUPS service. Now, if I say, well, what's my IP address? If I do IP adder, you can see my IP address. It's kind of hidden in here, and it is the 10.0.2.15. So I want to scan that one. So the nmap 10.0.2.15. Since I'm on my own machine, you'd expect to see the same things, right? Well, not quite. Some of these things are only listening on localhost. So the mail service, procmail, was only listening on localhost, and the print service was only listening on localhost, but RPC bind and SSH are both listening on the external interface as well. So what would I see from the outside? I would see anything that gets through the firewall. So SSH is currently getting through the firewall. That's the default configuration, but RPC bind would not get through the firewall. So externally, all I would see is the stuff getting through the firewall. So let's go ahead now and take a look at what a different machine would see. So switch over to a different machine, and right here I can use Nmap to scan 10.0.2.15 and figure out what gets through. So what we'd expect to see is the SSH service getting through, and that's all we see. Notice how it doesn't say closed ports right now. It says not shown 99 filtered ports. That's interesting. So what does that mean? It means that the rest of them didn't actually send a response back. So that means there's a firewall. Scheduling tasks. How do I schedule tasks? Well, you can use the cron tab service. And there are different places you can look at for scheduling tasks. The most common is using the cron tab -e option. So let's take a look at that. So clear this out. Let's go down to var spool cron tab cron. So if I go to var spool cron, I can see in this there is nothing here. If I do cron tab -e, it will use your default editor, and you can go in and put something in here. So you can put in a bunch of different numbers. So if I want something to run every minute, I could do this right here, and then I can type in some command. Now, one thing to keep track of is that cron, when it runs, it does not necessarily run with the exact same environment that your user logs in and runs as. That means that file locations and executable locations might not match exactly. So you usually want to pass in the not just relative, but the absolute path names for everything. So what I wanted to do, let's find a Control-Z switch. No, can't do that. Let's go ahead and leave a comment here. And let's figure out what command we want to run. So we write and quit. And if I type in a command right now, like ls, it tells me what's in my directory. And if I do which, actually that's the part of bash, which ls will say it's really an alias. But let's try this user bin ls. So if I type in user bin ls and go back in my cron tab -e for edit, and then I for insert mode, type user bin ls, then I can write this, and it will install a new cron tab. And if I take a look at my current directory, there's this thing called root. If I cat it out, you can see it is that text file I just edited. And now, I put it here in my var spool cron directory. Didn't have to put it here, but it does, because that's where it puts all the cron tab files. It's not just because I'm in this directory, it's because that's where it puts them. So now it's supposed to be running every minute. So you can see that in about 30 seconds it'll run again. So then what were all those stars? I put 5 stars there. So we look at my cron tab, information, you can see all this stuff here. It says, here you go. There's a bunch of stuff about using cron tab to get in here. If we want to see more information and actually see what these things are, we look at not the cron tab file, not the cron tab executable, but the information page. So I can do man 5 cron tab, and now it'll tell me the information about how to set up cron. So I scroll down and it says, okay, there are 5 fields. The first one is your minute field, which if I put a star there, it means every minute. If I put a number there, it would mean that minute. So if I wanted to run on the hour, every hour, I put a 0 there. And then if I wanted to run maybe every day at midnight, I could put 0, 0, and then 3 stars. Then I can limit things like the day of the month. I can pick which day of the month from 1 to 31. Some of these days of the month might not be hit. 31 might not show up for every month. So maybe you run things on the first day of the month, or maybe some random day in the middle of the month. You can pick which month, 1 to 12. You can also pick the day of the week, which is 0 to 7. So 0 and 7 are both Sundays. There's also other combinations. You can do commas to separate multiple different things, and you can do slash things. I usually do things like */3 for every 3 minutes or hours. That can be useful. All right. So now if I look at my date right now, I can see that some time has passed. So the ls command should have run multiple times. So if I go over to my mail, or spool mail, I can see there is a root file, and if I cat out my root file right there, I can see all the mail. And it's probably generating something, but maybe not. Sometimes when you have a cron job that runs, it produces mail. So just be aware of that. All right, so that's how you schedule tasks as a normal user or as the root user. There's also the etc cron directories. So there's etc cron.d for your configurations, cron.daily, cron.hourly, monthly, weekly. So if I want something to run every day, I can do cron daily. And in this cron daily, I can see that these 3 commands are running every day. It doesn't tell me when they're going to run, but they're running every day. And now it says I have mail in my root directory, or root mail spool. So if I cat out this root thing, it looks like it is running again. And you can actually see this is actually output from the ls command. It's running in the root directory, and these are files in the root directory. Doesn't matter where I'm at right now. If I look at the root directory, I will see the same files, but it's running it slightly different. It's not running it the same exact way, but you can see how it's slightly different when it runs versus when I run it by hand. All right, so that's scheduled tasks. How do you know if a cron job runs? Well, you don't necessarily know if it runs if it produces no output, but if it does produce output, then you can see it right there in the mail. So firewalls. What firewall is used in my system? Well, it depends on which system you have, but it's changed quite a bit. When I first started using Linux, the Red Hat distribution I was using had IP chains, which was later replaced by IP tables, and now we are in CentOS 7, which is a little bit different. It uses IP tables kind of in the background, but it really has Firewall D as a front end to it. So it uses kind of both things there. Firewall D is kind of a front end to manage it. But in CentOS 8, they are switching out firewall D and go into something different. So just keep that in mind. They keep changing back and firewall. So firewall D is what's used on my system, but you can use IP tables as well. How do I see the current firewall configuration? Well, you can use the firewall CMD command to look at it. So we can look at that, how to open ports and services, and figure out which services are supported and how I do a permanent service and what that means. Okay, so let's go back to my home directory. If I do firewall wall dash CMD, no space there, dash dash list all, like that, it will list which services are allowed through the firewall. This is the active current services getting through. You'll also notice this is the public firewall rule, and we can see the SSH services getting through, and we know that was getting through because we already did an nmap. And we can see this DHCP v6 client service is allowed through, which means that if I'm running as a DHCP client, then I'm allowing responses from the DHCP server to come back into me and tell me what my IP address is. So that's important. Nice things to know. What if I want to add a service? So I do firewall CMD add service equals HTTP. So add the web service. It says it's successful, and I think, well, okay, that's great. But if I reboot my system, it will no longer be in my firewall because this is an active only change. If I wanted to be permanent, I would use a dash dash permanent. But let's take a look at what this does. Since I'm not running a web server, what if I jump over to a different machine and scan myself again? So I jump over here and I scan myself again, and I can see that the SSH service should still be open, but now it should say something different about HTTP. It says HTTP is closed, which means that the firewall is open, but the service is not running. So keep that in mind. That's what that means. I should probably stop my cron job. So I do cron tab -E, and I can just do D a couple times and quit. There we go. All right. So where are these rules stored? And how does that all work? Well, if I added the HTTP firewall service. If I wanted to get something else, what do I have? Well, I can do a firewall all CMD get services, and that will list a complete list of all of the known services. So that's quite a few of them. So how do I make it all work? Well, I have to figure out which service I want, and then I have to turn on that service. What do these services do? Well, we can probably assume that when I turn on the HTTP service, it turns on the port for HTTP, which is port 80. And we probably saw that when we were looking at nmap, we just didn't pay attention to it. So now what do we do? Well, we can now take a look at some more information here and see where does this actually get stored. So I take a look and we look at the user lib firewall D, and you can see there's a bunch of stuff here. And one of these things is the services directory. So if I look in there, I can see the exact same list of services. But what does SSH do? So I can cat out one of these services, cat SSH, and I can see it says that I'm going to allow HTTP, for when I'm going to start up SSH, it will do TCP port 22. If I wanted to look at something different like DNS, what does it do? Well, it does two different things. It does TCP port 53 and UDP port 53. So most queries when you're doing DNS lookups are UDP, but if you're doing a zone transfer, it does TCP. So you could modify this or change it if you wanted to. I wouldn't recommend it. Or you can also add new services here. Just put in the information right here. So we can see what services are there. Now, what else do we have? If we look at the etc directory, there is a firewall D thing, and in here there is zones and public. So there's a zones public file. If I look at this thing right here, I can see some information. It says that SSH and DHCP version 6 client are both listed in this file. What happens if I add something permanently? So I added the HTTP service. Now I do a permanent. And I look at that same file again, and you can see that it has been added to the file at the bottom. This does not make it active. It means that the next time the firewall service will start up, it will add that to the firewall. If I remove it from this permanent thing, so we do del service, nope, not del, it's remove. Remove service. It removes it from the permanent, but it is still in the active. So we do firewall cmd list all. I can see what is currently active. And if I want to see what is in the configuration file, I can look at the file, or I can add the -- permanent to it and see what is in the configuration file. So you can see actively we have all three of these. In the permanent, we only have these two. So that's interesting to pay attention to and be aware of. So where are the firewall files stored? Well, we just saw that. Can the firewall be updated using the files? Yes, you can update it using the files. You might need to restart the service, but that's you. And can you add additional services? Yes, you can. So you can go in there and just create new services, just use the same file format and create them too. And that is services. Well, let's look at ports and then we'll be done. So I'll add over here. Let's say I want to add port 123. What is it? I don't know, but we'll add it anyway. So we did firewall. We did add service equals something to add a service. And if you want to do a specific port, you can do add port. Then you got to figure out what's the format. Well, you got to remember if it's TCP/123 or if it's 123/TCP. And one of them will probably work. So you can try both and figure out which one works. In this case, I did the 123/TCP and I added it. It's not permanent, so if I restart my firewall, it will be gone. So let's take a look at that. So if I list all, I can see there is a port section and ports are listed. If I restart my firewall, actually let's do systemctl restart firewall D. And if I look at the same thing again, I can see the port is now gone. You can also do the remove port as well. Just remove it the same way you add the ports. And that is the end of this lecture. Processes and resources. What is a process? What is a thread? How are processes and threads different? Well, a process is basically a program. What happens in the CPU is there is a program counter and there's some memory, and so what happens is the program gets loaded into memory, and then the program counter tells the CPU which part of that memory is looking at, which process or which operation is going to do next. And so that process counter continuously moves through, and then the CPU executes these commands. So each one of these programs that gets loaded into memory is a process. Within those processes, you might have different pieces of execution. And those different pieces of execution within the same process can be called threads. So if you have a process that has threads, what really happens is your process is running and your process switches between the different portions of the process to do different things. It's very common to have some larger applications have multiple threads, and even some of them are starting to have multiple processes. Games were pretty common to have multiple threads back in the day. They still have multiple threads. The idea is that maybe you want to have your audio be one thread, your GUI be a different thread, and some of your game logic be a different thread. So your audio can continuously run and not have to wait for it to make other decisions about game logic while you're playing your game. And one of the big changes with the Chrome web browser was they decided that there were too many problems with one tab would crash and take down the entire browser. So Chrome decided to break it out and have each tab be a separate process. They've changed it a bit since then, but originally that was the idea, so that if one crashed, that tab could crash and the rest of the tabs could stay live. So processes, when they crash, they can take down a lot. Threads, when they crash, well, sometimes things continue to run, sometimes they don't. It depends on how they crash, what happened. If it crashes, the whole process goes down. If it somehow gets in an infinite loop, then that portion of the thread can just loop forever, and the rest of it might stay live, keep going. So that's basically processes and threads and how they're different. So then what is a multi-core CPU? Well, there's this whole thing about Moore's law where the speed of CPUs doubles every certain number of months or years. And things kept getting faster and faster and faster, and then they ran into this problem. The problem was that when you get things small enough, it doesn't really work out so well. So they were making all these CPU pieces smaller and smaller and smaller. And when you have electricity going through a CPU, at some point the electricity jumps across and breaks things. So you have two wires right next to each other, and there's a really high charge, then they'll create some kind of a lightning bolt thing, little electricity charge between the two of them. And that can destroy stuff. So what do? Well, your electricity is basically watts. But your watts are either going to be amps or volts. So amps create heat and resistance and fun things like that. And volts, they create your arcing jump. So as you take your larger CPUs and you shrink them down, you have to worry about these volts jumping across. So what you do is you convert your volts into amps. So that's kind of nice. It means that you can go much stronger but not have to worry about it jumping across. The problem is that then your CPU heats up more. So it's kind of a trade-off. If you have a higher number of amps, your CPU overheats. If you have a higher number of volts, the charges jump across and destroy stuff inside of your CPU. So when I first got into computers, CPUs could handle something like 200 volts, and then it got down to like 50 volts, and now it's probably even lower before they start causing problems. And they're always worried about this electrostatic discharge problem. So what does this have to do with multi-core? Well, they discovered we don't have to make smaller and smaller CPUs. At some point, they're kind of small enough. And so what we need to do is now have more CPUs on the same CPU. So they created these multi-core CPUs, dual core, then quad core, and some people even threw like 3-core CPUs, and then 6 and 8, and well, 3 and 6 are basically because they failed on a couple, but that's okay. Anyway, so the idea is you get these multi-core CPUs with multiple different CPUs on the chip. And that is what a multi-core CPU is. It's a CPU with multiple different CPU cores on the chip. So what does it mean when a CPU has hyperthreading? Well, we talked about processes and we talked about threads basically. The idea with hyperthreading is that your CPU tells the hardware, the rest of the hardware, it has more than one core. So if it's a single core multi or hyper-threaded CPU, then it will tell the computer it might have 2 CPUs on the chip. And so the computer sends 2 different processes, one to each one of its virtual CPUs. And then these virtual CPUs both have a little bit of memory and a little bit of other information there. And it only has one actual CPU, but the chip can then switch between them very quickly. And so it simulates 2 just switching back and forth very quickly without having to worry about the operating system keeping track of which processes are where. It just sends them both there, and they're both handled without the operating system needing to copy things out of memory and move new things into memory, what it does with other multi-process type operating system tasks. So you can have both a multi-core and a hyper-threaded CPU. So you could have something like a quad-core CPU where all of them are hyper-threaded. So instead of showing up as quad or 4, it shows up as 8 CPUs, which could be nice. It makes it so you can run things faster. But in a hyper-threading situation, you still only have one process running at a time. In a multi-core situation, you have multiple processes that can actually run simultaneously. So then that brings us down to the next thing. What is a race condition? Well, a race condition is when you have a situation where the outcome is determined by what happens and what order. So I like to think about the ATM example. Say for a moment you have an ATM machine and you want to make a $100 withdrawal from the ATM machine. If you go to the ATM machine, put your card in there and withdraw $100, you get $100 taken off your account and you get $100 that comes out of the machine. But what happens if at the exact same time you are making a withdrawal, you have a direct deposit? Let's say that you have a job, you get $200 deposited into your account. So the question is, well, does it matter what order you process these things in? So what does an ATM machine do? Well, first it reads your account balance. It sees if you have the $100. It takes the $100, subtracts it from your account, and then it sends you the $100. Now the direct deposit might look at your account, figure out how much you have, might add your $200 deposit into your account number and write it back to your account. So what happens if they both read at the same time? So they both find out your account balance. One subtracts $100, one adds $200, and then they both write back. Well, then it matters which one wrote back first as to what your account balance is going to be. So that is a race condition. Obviously, the ideal situation for you would probably be that you withdraw the money at the exact same time the direct deposit goes in, and the direct deposit reads, and then the ATM machine reads, and your direct deposit is the one that gets written after the ATM gets written, which means that instead of having a net of $100 more, you'd have a net of $200 more, which would be great. The bank probably not like that though. Okay. How do I know which processes are running? Well, on a Linux machine, you can look at which processes are running. You can actually do it on other machines too. Pretty much all of them have a way to look at the processes running. And the easiest way to do that is with the PS command. It'll show you the processes that are running. You can have processes that are running in the background and processes that are running in the foreground. So a background process is one that runs and doesn't send out input to you or output to you and things like that. It's just running in the background. A foreground type process is if you have a terminal or something open and you're running a program, you will see text printed to your screen. You'll be typing things. Those are in the foreground. Background, you don't see anything, or you rarely see anything. So how do you get into background processes? Well, you can actually pull them to the foreground, and you can disconnect, output, and things like that, and these will all be taken care of. So let's take a look at a machine. So here we have a client machine, and I'm going to run the PS command. So if I type PS, I can see these are two commands that are running. The bash command, which is my shell. So my terminal opens up. It's a terminal window. Inside the terminal window, we have this program running that allows me to type in commands, and then it runs them. That is my bash shell. And the command I just typed in is PS. And so it says, well, bash is running and PS is running. If I type it again, you can see that bash is running and PS is running. Now, what you might notice is that the process ID number for bash stays the same because it's the same shell. But my PS command is different because I started one command and it printed out the output and then it ended. Then I started the next one, it printed out the output and it ended. So how do I start a background process? Well, let's try the sleep command. Sleep. If I type in sleep 5, it will wait 5 seconds and then the command will end and it will return back to my terminal. I can do sleep 5 ampersand and start as a background process, and it immediately gives me control of my shell again, but it's still running. If I press enter again, it says, oh, it's done, by the way. Alright, so what if I want to sleep for much longer than that? Let's say I want to sleep for 5 minutes. I can do sleep 300, and it starts in the background. And you can see there's something here. It also says that there's a process number, 5047. If I type in PS, I can see that 5047 is the sleep command, and it is running. I can also see that my bash is running and my PS is running. If I want to, I can type in jobs. Jobs says that number 1 is running. I can bring this to the foreground if I want by typing in FG. And that will take the default one, but I can also do FG1 to pull in the number. So now it's running in the foreground. If I want to put it back in the background, I can type in Control Z, which will stop it. So now it's not doing anything. And then I can do a jobs command again to see what it is, and it says, oh, it's stopped, by the way. So I can do a BG1 and start it back up again in the background. If I want to end the process, well, I can do that too. But I need to figure out what process I have. So I like PS and I say, oh, okay, my sleep command is 5047. So there are a couple ways to stop the process. One is I can bring it to the foreground and press Control C to kill the process, or I can use the kill command. So if I look at the kill command, and kill, it says terminate a process, and it says I have to type the word kill, and then I give it some signal number if I want, and then there's a PID number, and all these things here. You say, well, that's great. So I can also look at other things like, well, there's a kill 2. Oh, that's interesting. Kill 2 means it's probably tied to the programming language kill. Then I've got things like signal 7, which is probably more informational. So do man 7 signal. And it says, okay, here's some information about how these signals work. And it says, okay, here are some signals. And you get some information. Oh, okay, so what does it do? Well, if I do a kill, then it's going to send one of these signals. It's going to send this sig term signal over. So the program receives the sig term and it says, oh, it's time for me to terminate. And that works. However, some programs don't like to terminate there. because maybe they're crashed or something else and they won't terminate. So maybe you need to do it not from telling the program to terminate, but you want to have the operating system itself kill it, which case you will do a sig kill, which is number 9. So let's try that. We can see, once again, my sleep command is still running. So I can do kill and 5047, and it says terminated. So I do PS, and you can see it is gone. I think, oh, I want it back. So now I'm going to start it back up again. And I do a PS command. You can see it's there running. It's going to be running for another 5 minutes. I can also do kill -9 or -S9, and then the number 5246, and it says killed, which is different from what it said previously, which was terminated. It's terminated, and this one is killed. So if you're having trouble getting something to stop, use the kill command. So once again, I'm going to start this back up again. Now I'm going to do a FG to bring it to the foreground. And I will press Control C to kill it. Now if I do a PS to see if it's still there, I can see it is not there because I killed the process. So that gives you an idea about starting things in the background and what happens there. So the next big question is, well, what happens if I close the terminal? Well, if you close the terminal, it dies. And it's gone. So that can be a problem, especially if you log into a server, you start a process in the background, and then you log out, and suddenly your terminal is gone, and the process dies. How do you get that to work? There's a no-hup command. So if you do man no-hup, what it does is it runs a command immune to hangups with output to a non-TTY. So you type in no-hup space, the command name, and it runs it in the background without your intervention, and you don't really, well, it kind of keeps running. Kind of. You can still kill it. So let's start the sleep command again with a no-hup. No-hup. Now it says ignoring output or input and appending output to no-hup.out. Alright, so now it's running. If I close my window here, it will continue running. If I do a PS, you can still see that it is running. So I can still kill it just like I could before. And I can do a jobs, and suddenly you see it there. So if I do FG, I can bring it to the foreground, and then I can press Control C to kill it. Or I could have killed it with the kill command. So I can still kill the process. However, it doesn't die when I close my terminal. Alright. So back to these questions. How do I start a background process? Just with the ampersand at the end of it. How do I get into a background process? You can go to FG to bring it to the foreground. You can do jobs to get an idea of which processes are running in the background. And then what happens when a process, well, what happens to a process when a terminal closes? Well, it dies unless you use something like no-hup to keep it alive. How do I know which processes others are running? Well, other users, who are they and what are they using? How do I know how much resources each process are using? So how much are they using? And can I end running processes? Well, we know we can end the processes because we saw the kill command. What do I do if the process refuses to die? Just give it a stronger signal. The -9 is much stronger than the -15. So let's figure out what processes are running. So I jump back into my machine here, and let's take a look at my processes. So I can do PS, and it only shows me my processes. But there's got to be other stuff running. So I do PS AUX. AUX is a bunch of special keywords, key letters. Anyway, it displays this long list of processes running. If I want to have a nice list to look at, I can do pipe through less, and I can scroll through it and see all the different process numbers, what they are, who's running them. You can see there are other users here as well. Well, mostly root, but there are users here, like the like the GDM, which is your login manager thing, and ColorD and Postfix, which is your mail server. So all these things are running, and some of them have user accounts for it. And at the top, you can see the user running it. You can see the process ID number, the amount of CPU they're using, the amount of memory they're using, and then there's a bunch of other stats here. And the last thing over here is the command that was used to start it. Well, kind of. I mean, it's not always exactly that way. So I can go in and kill any one of these processes with the process ID number. I can also use another command, top. Top is a more active, dynamic list of processes running. So you can see which processes are running and what's going on. It tells you how much memory is being used, the total number of processes, number of running processes, sleeping processes. You can see that most of the processes are sleeping at any given time. That's what they mostly do. They sleep. And you can see how much you're using, how much CPU, how much memory, and you can sort things. We don't really know how they're being sorted right now, but you can use the greater than or less than commands or keys to shift how it's sorted. So how is it being sorted? Well, if I go all the way over, it's now being reverse sorted by process ID number. And I can go now over to user, then PR, then NI. NI is the nice level, so how aggressive it is in running and stuff like that. And ver, res, sure, has CPU. So now it's ordered by the highest CPU down to the lowest CPU. And I can switch over to memory from the highest memory down to the lowest memory. So you can do lots of different things. You can also press other keys such as K if I wanted to kill a process. So let's press K, and it says, well, there is this default process, some number, the one at the top. If I kill my gnome shell, then that will probably log me out. I don't want to kill that one. I want to kill the top command. So I do 5427. And it says, do I want to use the sig term? Yeah, let's see. Yeah, sure. So what happens? The top command now ends. So that was a quick way to end it, right? I could have just pressed Q as well. Q to quit out. That's okay. But you can see how this works, and you can see which processes are running on the system and what resources are being used by these processes. What is the proc directory? Well, the proc directory is an interface to the kernel. What does that mean? Well, it's actually a fake directory. I mean, there's a directory proc, but you have this whole entire file system that includes lots of files that don't really exist. They're not really files. They're just virtual files. And these virtual files have information in there. And some of these pieces of information are things like your CPU information. And what you do when you look at that file is you get information from the CPU, from the kernel. Actually, not CPU, from the kernel. It tells you what information it knows about the CPU. Your memory information shows you about your memory. So all these different things you can look at. So let's go take a look at the proc directory and see what we can see. So let's clear out here. If I go to the proc directory and take a look around, you can see there's a whole bunch of empty files. Well, they're like 0 size. So if I look at, let's say I take a look at version right here at the bottom. So version, 0 byte file. So I cat out version, and that's clearly not 0 bytes. But it tells me the version of the kernel running. Okay, so I cat out something like zone info, and it says, well, this is some information you might like to know. I'm not sure why I know this, but it's all there. I can cat out things like my CPU info, and it tells me, oh, I've got a couple processors. This one right here is processor 0. It says it is genuine Intel. It tells me about the CPU family. It tells me how fast the CPU runs. and all that information. I can also do things like cat out my mem info, which tells me how much memory I have, tells me my total memory, it tells me how much is available, and it also tells me things like how much swap is being used. It talks about dirty memory, which is basically memory that is, well, it's been loaded into memory, but it has not been written out, so there's no copy of it, and so it cannot be flushed out to swap cleanly. So you got my swap total here, my swap free. All right, so these are all these different memory information pieces. If I look back at the directory, ls again, you can see that there are a whole bunch of numbers here, and then there's a bunch of words. Numbers and words. So what are these numbers? Well, let's type in my ps command. You can see that my bash shell, once again, is 4722. So if I go into the 4722 directory and take a look around, you can see there's a bunch of stuff here. And these are different pieces of information. You can see the executable, there's a symbolic link over to my bash, and you got these well, information about your process, your CPU things. Here, right here, is the command line that was used to start my process. All kinds of pieces of information you can use, such as your environment. So different things here you can look at, you can mess with. Well, you can't mess with a whole lot of it, but some you can mess with. So this information can be useful, and this information is kind of what you get when you run the ps command. You get all of these processes here and information about them. But then there's other directories in here, things like sys and fs and stuff like that, and they are really kind of what they sound like. Well, let's go into sys and take a look at sys. So you have in here sys. Let's go into net. Now you got IPv4, so let's go into that IPv4. A bunch of things in here. All right, so what do we have? Well, one of these things is a value. So the IP forward thing right here, let's take a look at that. If I cat out IP forward, it says it has a value of 1. Well, it could be a value of 1, it could be a value of 0. So let's do echo 0 into that IP forward. Now if I cat it out again, it's 0. So you can change the values. And, well, so let's leave it as 0, but let's do ls minus L IP forward. And you can see that even though I've changed the value, it still has a value or a size of 0. So what I did is just change a kernel value somewhere. IP forward is basically the value that tells your kernel that your computer can run as a router. So why would you want your Linux machine running as a router? In fact, that was the default value. So let's put it back to 1. The default value was running as a router. Why would I do that? Well, if you ever want to set up your machine as a NAT box, you're doing your network address translation, or you want to run as a normal router, then you probably want to have that router switch flipped on. So then manually going in here and using the echo command to set it will only set it in active memory. What if you want it to be there on boot time? Well, you can do that too. So let's go down to the etc directory. There is a sysctl command, or sysctl command, and also a file. So if I cat out sysctl, ctl.conf, I can see, oh, here we have a bunch of stuff. And if we want to figure out how do we use this, well, we could do, look at the man page, man sysctl.conf, and it says, okay, well, all you need to do is figure out what you want and put them in here and tell it what you're doing. Okay, well, that's kind of confusing. So what are we doing? It also says you have other files you can look at. There's the etc sysctl.d directory, which has a bunch of conf files. So let's take a look at that one. sysctl.d directory. And you can see there is a 99 sysctl.conf file. Okay. So it says, all right, we just want to load this one first. Or not first, but after everything else, because they're in order. And all it says is, well, the sysctl.conf file, which we looked at. So if you wanted to have something start up on boot time, you could use the sysctl.conf file to make it happen. So how does that work? Well, the IP forward command had this long path. So if I do ls minus l, u is proc sys net IPv4 before IP forward. That was the file. Now, everything from sys, after sys, this net IPv4 IP forward is all you need to know about. So I can go into my sysctl.conf file, and I just need that part right there. Net IPv4 IP forward. So go down here and do a net dot IPv4 dot IP forward equals 1. And that right there will set it up so that when it boots up, it will set the IP forward to 1. Well, it's already being set to 1. So I could change it to 0 if I wanted, but that's how you do it. You set values in there. You can also use the sysctl command. Sysctl, how does that work? Well, it says you type in your options and your variables and values and stuff like that. You can do a -p to read from a file. So I just do sysctl -p, and it sets my net IPv4 IP forward to 1 because it's reading it from the file, the default file. I can also have other files I read from as well. But that's how you set those. Alright, so what other variables are stored in the kernel proc directory? Well, we saw the IP forward. Can I change things? Well, we know the answer to that. You can use the echo, and you can also use the sysctl command. And that brings us to the last question. What is the sysctl command used for? It's for changing those things. Alright, file systems. How do I know how much hard drive space is being used? That could be important, right? How do I know how much space is used in a directory tree? We can do that too. We'll look at that in a moment. And then what happens when the machine runs out of drive space? I'll tell you, it's very bad things happen. If you think about it, we have a journaling file system. So, in theory, what would happen if you absolutely ran out of space? In order to write something to the hard drive, usually you have to write to the journal first, say I'm going to make changes to the hard drive, and then you make those changes and then you remove your entry from the journal. Well, what happens if the journal takes up extra space? Then you cannot write to the hard drive. In fact, there are some file systems that are written so poorly that once the hard drive is completely full, if you try to delete a file, it has to write to the journal that's going to delete the file, which it can't do, so it can't delete the file. So the only way to get it clean is to completely reformat the file system. That's a very poor design. So that can be really bad. Don't ever run out of hard drive space. Linux is fortunately written by people who are much more intelligent, and they leave a little bit of buffer space and things like that so that you can still do stuff even if you run out of space. Kind of. They kind of run out without actually running out. So how do I get more space? Well, you can delete things. You can add more hard drives. And if you have something like an LVM in there, you can add more hard drives and expand your current drive size and then use your file system tools to expand your file system in your drive space. So let's go look at the file system, see how much space is being used, and how we can look at directory trees. So let's jump right in, clear that. If I type in DF, it tells me information about my space being used. Now these 1K blocks are great. We love seeing 1K blocks, but what does that really mean? Well, let's do a DF minus H into human readable form. It tells me, okay, this is how much space you have. And it rounds these things a little bit, so they're not quite exactly accurate, but you know, it's accurate. All right, you can see which devices I have and then how much space is available on each device. You can see that there really are only two devices that have real space. You have your first one right here, your CentOS root, which is your main file system. And I also have this boot directory. The rest of these are all kind of virtual-ish things. They're not really real. They're kind of more memory things that are kind of fake-ish. So they don't really count. But those two are real hard drive space. All right. So I know how much space is there. I know how much is left. But what about directories? How much is being used by my, I don't know, my home users? If I look at my home directory, I can see there's a Joseph person there. So if I go down, take a look, I can go into my home directory, I can go into Joseph, I can look around and see how much space is he using. Well, it looks like he's not using very much. How do I find out how much it is? We can sit there and add everything up, or you can have the du command do it. So du, and let's do the home directory. It says, oh, 12 is being used. What's 12? Well, let's once again use the minus h, which happens to be the human readable form, and it says, oh, it's 12k. Like, oh, okay, thank you. What about the user directory? If I do a du minus h on the USR directory, well, that's much larger because it has to go through and parse through all of these directories and figure out how much space is being used in everyone and add it all up, and it comes up with a total and says, oh, the entire USR directory is 3.5 gigabytes, more or less. I could do that in less human readable form if I wanted to get more exact numbers, and it'll say, oh, this is the number of blocks being used. These are the 1K blocks. And that's how you can figure out how much space is being used on your system. Anyway, these are, that's how you can figure out the space. That's how you can figure out what's in a tree. And once again, don't run out of hard drive space. Bad things happen. And that is the end of this video. Kernels and hardware. When you're running a Linux system, you might have questions about a kernel. Well, first of all, what is a kernel? Well, the kernel is the main program that runs your operating system. It's the main thing. So Linux is the kernel. So which kernel version am I running? Well, there's lots of different kernels. Which am I running? And where is the kernel file stored? Where is the source code for the kernel? And what options were used when building the kernel? So let's take a look at these questions and see if we can figure them out. So here we have a system. I'm running my Linux system, and I want to know which kernel I'm running. Well, if you look in your etc directory, there's a bunch of files in there. So if we cat out our etc, there's a Red Hat release file. And that tells me which version of CentOS I'm running. But it doesn't tell me which kernel I'm using. So that's kind of tough. So you start saying, well, where else could it be stored? It actually turns out there's an easy way to do it. We just type in the uname command, uname minus r. And that tells me my kernel. So my kernel is 310.0-957.12.1.el7.x86_64. So these el7 maps up to this CentOS release thing, which is 7. Same 7 right there. Now the 7.6, well, that is kind of tied to the Red Hat release, and this 18.10 basically tells you which CentOS release this is. All right. So we've got that. How was the kernel built? Well, most things on a Linux system are built with the GCC compiler. But do we know if it was built with that? Well, we can actually take a look at the kernel, and the kernel can tell you something as well. So cat proc version, and we see, once again, that same exact number. So this number right here, the kernel number, is showing up right here. So that's the kernel. You can see where it was built and the GCC version that was used to build it. All right, so that's good information. So where is the kernel file? I mean, it's built, it's loaded in memory, I get that. Where is it at? Well, fortunately, you can find it in the boot directory. And some systems have boot mounted by default, some don't. You can always cat out the etc fs tab file and see what it says about your boot directory. It's got my device here, so UUID, and then this boot, and it says XFS defaults, so it's not being not booted. Sometimes it doesn't actually load for some older Linux versions because they don't plan on changing the kernel often, and so they just don't load it. And it also protects it a little bit. But it is mounted, and it should be there. So I go over to the boot directory and take a look. There are a bunch of files here. And if I go back to my uname command, once again, I can see this is the number I'm looking for. So if I do ls minus, let's do L, and then pipe that through a grep, and we want to do a backtick uname minus R. And what we're going to do is we're going to look at all of the files, and we're going to filter out just the ones that happen to have that string in them. Grep uname minus R, minus R in there. All right, so you can see there's a bunch of stuff here. Okay, what is it? Well, this first one on the top is your config. That is the configuration options that were used when creating this kernel. So, as you might expect, you less out that config with 12, and you'll see a bunch of options, tons of options with yeses and modules and not set and things like that. And you go through, you say, okay, so that's how the kernel was built. All of these options are set, and there's lots of options. You just kind of keep scrolling through them. Lots of options to set. All right. Then you have this RAM disk thing. RAM init RAM FS. Well, it's the initial RAM disk file system thing, and that's kind of important. What does it have? Well, when your kernel gets loaded in memory, the way it happens is you have your, your BIOS loads the first part of your hard drive, and the first part of your hard drive loads your bootloader, and your bootloader looks at your configuration files, figures out what to load, and then it loads your kernel. And when it loads your kernel, there's always that risk. There's a slight risk that your kernel will load up and it will not have the drivers in order to read the file system. So that could be because you have some kind of a RAID set up. Hardware RAID, you need to have the hardware RAID drivers in there, otherwise you can't read the RAID, and if you can't read the RAID, you can't get anything from the hard drive. Could be all kinds of problems. But the BIOS, when it's reading, it reads things differently than the kernel reads them. So it has the ability to read things that the kernel cannot read. So that could be a little interesting. So it's always possible to get in a situation where your kernel is loaded, but your kernel cannot read the hardware because it needs some kind of drivers. So where do you put those drivers? Well, you can put those drivers in the initial RAM disk. And so you put drivers in there, these little kernel modules, and they get loaded, and then it can suddenly read the rest of the system. So that can be important. Let's get down to the bottom. We've got this VM linez thing. So the Z is for compression. It's basically a compressed file. It's really a larger file. And that is your kernel. That's your kernel built out, compressed, waiting to be loaded into memory. So that's what happens. That gets loaded. But then where is the source code? Well, Source code for the kernel is usually stored in the USR src directory. So let's take a look over here. We've got this directory called kernels. So let's go in here and take a look at our kernels. Kernels, take a look, and it's empty. Why is it empty? Well, if you think about it, most people don't need their source code for their kernel, right? You just want the kernel to run. You don't need the plans. You just want it there. So some versions of Linux ship without the kernel. Well, that can be a bit of a problem, because what happens if you need the kernel? Well, that's okay. We can get pieces of the kernel. So when do you need the kernel? If you are changing some of your libraries and your libraries need to be able to access the kernel, so you need to make system calls to grab stuff from the kernel, you might need to have your kernel headers. And the kernel headers can be loaded with a special package. So let's look. If I do a yum install kernel devel, it will install the kernel headers. So I do yes. Now, contrary to common belief, if you install this kernel devel, it doesn't give you everything you need to develop the kernel. No, not quite. Not that at all. In fact, all you're really getting is the kernel headers. Quite a small little piece of information. You need more in order to actually build the kernel. But we can go in there and take a look. So now we suddenly see there is a directory here. So I go to that directory, and I can see all kinds of files here. One of the files is that config thing. So cat.my.config, and I can see this looks like, well, a bunch of the same thing that we had in that boot directory. If I do a diff to compare my .config in this directory, config, to the one in boot.config, right here, you'll find those two files are exactly the same. So there's no differences. So that's great. That's kind of nice. But what if I don't want this kernel? What if I want to get a new kernel? Well, you can download it. Or what if I want to actually build a kernel? Well, you can do that too. In fact, you can look at your options even. There is a menu config thing. You can do a make menu config and look at your options, but it doesn't quite work without some development tools and a little bit more. So let's do a yum group install. And we're going to get our development tools. That's the entire development tools package set, which includes your GCC compiler and all kinds of other libraries. So this will get you most of what you need in order to be able to see what the kernel needs in order to be developed and some of them. So after a couple of seconds, it's all downloaded and you're ready to go. And I want to do a yum install ncurses. Ncurses allows me to have menus. So I can do up, down, navigation through menus with the keypad. All right, so I do a make menu config. So I want to make sure I'm in this directory, which I'm in. You can see I'm in the correct directory. You can see there is this make file here, which allows me to run the make command. So I do a make menu config, and that will do this right here, print a few things, and suddenly it'll pop into a nice GUI right here. And I can go look at the options that were set at the time that this kernel was built. You can go into individual things, say, okay, do I have the second extended file system that's ext2? Do I have it? No, I don't have it. Do I have ext3? No, I don't really have it. But I do have ext4. That's great. And ext4 can read ext2 and ext3. We just want to make sure we use that. And so you can say, well, what if I want something like RazorFS or JFS or XFS? I can put those in there. I can even build it into the kernel if I want to not use modules. But you probably want to just use it as a module because maybe you're not using XFS. But if you know you are, maybe you build it in. All right. So exit out. And if you make changes, you can save those changes, and that's good for building your kernel. Usually what you do to make your kernel is you use the make command and you do a, well, make all. But that doesn't really work here because we don't have the source code. So where do we get the source code? Well, the source code actually can be found in other places such as right here in kernel.org. You can see kernel.org, you can see the Linux kernel archives, has a bunch of files here. You just download one of these tarballs and decompress it in the USR src kernels directory. And then from in there, you can just go inside of it and build it. Make sure you have your development tools, make sure you have ncurses, make sure if anything else is missing, and yeah, then you're good to go. All right, but that doesn't really get it all taken care of. So let's go back and see what drivers do we actually need, right? Because you think about it, you've got this thing. We know where the kernel, what version you're running, you know where it's stored, you know the source code's not there, but you can get the development headers if you want, which can be used for building other stuff, and you know what options were built or used when building it. So how do I know what hardware I need to use? So you need to know what hardware you have on your system, and you can figure out which USB devices you have. You can see which PCI devices you have. You can see which drivers were used or are being used, and you can see specific versions of all kinds of stuff. And this information is going to be useful. So let's take a look at it. So if I do ls USB, it says these are the devices that are connected to me. Okay. Well, these are the kinds of things I got, which is kind of nice. Doesn't really tell me much because there's nothing really there. I can also do ls PCI, and that says these are the PCI devices that I have on my system. Well, what if that's not enough information? What if you need to know more information than just that? Because I can see, okay, I've got a VGA compatible controller thing here. That's nice. So I know that's what I need for my graphics card. And I can also use my Ethernet controller right here. But I don't know what drivers I'm using. So you can do a LSPCI -V for verbose. And that says, oh, here's some information. And you can see, for example, my video card right here. Got some information about it. That's nice. Drop down to my Ethernet controller right here. And it even tells me things like, this is the driver. This is the kernel module that's being used. The E1000 is being used. Some of them tell me the drivers such as the sound cards and PCI things. All these things are showing up and giving information. But what if that's not enough information? What if I want more? I just add another V. Suddenly we have more. What if that's not enough? I want more. I just add another V. Okay, so it doesn't give me that much more. So really 2 V's is about as much as you get, but you can use 3. So add a couple of V's and you're good. You can see what hardware you have with this PCI thing. So why is that important? Well, you need to know which drivers you're using if you want to guarantee you have them when you do your installation or building of a new kernel. It can be kind of important. You want to make sure that they're either built or make sure that they are built into the kernel so that you don't need to build the modules. Kernel modules. So what are kernel modules? Well, kernel modules are your drivers. They're the little pieces of kernel code that gets loaded in and used. So you might say, well, why would I build kernel modules for hardware I never need or don't use? Well, I don't know. Why would you? Well, you might use it. But if you know you will never use something, you don't need that module. It's not necessary. So then, why were the kernel modules built outside of the kernel instead of in the kernel? Well, the reason they're built outside of it is because you don't necessarily need everything. And there are even problems where multiple different kernel modules can conflict with each other. And you can't have two of the similar modules because maybe one will work and the other one won't. There might be two different modules built for the same hardware, and you only want one of them. Maybe one's open source and one's a proprietary closed source, and that could be, well, a good reason to have them outside the kernel because you can only have one in the kernel. And if it's in the kernel, it's guaranteed to be in the memory. And what if you don't ever use XFS or ext2 or 3? If you don't use ext2 or 3, why would you want that kernel module built into your kernel? Just don't build it. So which kernel modules are loaded? Well, you can use the ls-mod command to see which ones are being loaded and things like that. So let's go take a look at that right now. So clear this up. I do ls-mod, and suddenly it shoots us a big list. So we knew we were using the E1000 driver for our network card, and we can see right there it's being used. The E1000 is loaded up, and it's in there. But you can see lots of other drivers in there as well. So which drivers do we have? Well, you can do mod probe, and that kind of tells me something. It says, well, here's some things you can do. And it's just saying, well, what do I have? And you've got this -a option. So let's figure out what that does. So do mod probe -a. And nothing there. We want to, usually you can use mod probe to load drivers, and sometimes you can use it to list the drivers as well. Let's clear this up. So let's approach this a different way. So mod probe apparently doesn't have the option anymore to look at all the modules, but we can still load modules. And let's take a look at the directories where they are stored. So if I look at the lib directory, ls -lib, there is a lib modules. All right, so that's interesting. There's a lib modules, and then we want to get our kernel, which is 3, right there with the 12, and we can see this stuff right here. Well, that's a lot of modules, right? Maybe. So we'll use the find command, find, and we can list out a bunch of things in here. Well, we know that we want to look for let's find their network driver. So we know it's E1000, so we do grep E1000, and we can see suddenly this is where you can find the drivers for the E1000. There's the E1000 and there's the E1000 E, whatever that is. But you can see the directory where it's stored, and you can also see the actual module stored there. And most of them end in a KO, but these ones are apparently compressed, so they have an XZ at the end. And so these all get loaded at boot time. And well, when it gets loaded. And sometimes they get loaded at other times. So once again, if you look at ls mod, you can see the list of modules. If I wanted to remove a module, I can do that as well with an rm mod or ins mod for insert mod. And mod probe, once again, can add or remove modules. So those are a couple things with kernel modules. So we can see, first of all, which kernel modules are loaded with the ls-mod command. We can see which kernel modules there are by just doing a look at the lib modules directory. And then how do I load kernel modules? You can do mod probe to load them, or ins mod. So why would I want to build my own kernel? Well, sometimes you want to build a kernel for a specific purpose. Maybe you don't want to have any extra modules built in. Maybe you want to just build a kernel that specifically meets a set of hardware and you're done. If you do an embedded system, you want to make sure your hardware meets exactly or matches exactly what the kernel has. Are there any performance advantages to building a kernel? Yes, there are. You can build a kernel specifically for your hardware, and then you can optimize everything. Is that a lot of work? Yes, it's a lot of work. How do I build a kernel? Well, first you need to get the source code. And we saw where to get that because you get it from kernel.org. You download that. You put it into your user src kernels directory. Decompress the file. You go into that file and you then can make sure you have your libraries installed, and you can do a make menu config and set your settings. If you want to copy over a config, you can copy over a config from a previous or different version of the kernel that you know works, and then change the settings up a bit. Then you do a make all, and it will build it. Why do I need a compiler? Well, you need a compiler because you need something to convert your source code into machine code. How long does it take to build a kernel and the modules? Well, that's an interesting question. It depends on what your CPU is. If your CPU is a nice, slow virtual machine CPU, it could take you, I don't know, 2 to 3 hours to build your kernel. If you were building on much harder, faster, multi-core CPUs, you can do it much faster. You can do it in 10 to 20 minutes. So why does it take so long? Well, there are a lot of files. There's millions of lines of code in that kernel. So you are looking at a lot of stuff, parsing a lot of stuff. And it depends on how many options you build. The more options you put in there, the longer it takes. Once a kernel has been built, how do I change which kernel I'm using? Well, remember the bootloader loads the kernel, right? So all you need to do is tell the bootloader how to load your kernel. Alright, that sounds pretty easy. So how do I change the default kernel the system is using? Well, with the bootloader. And let's go take a look at that. So clear this out, the bootloader. So let's drop back to that boot directory again. In here, there is a grub and a grub2. So let's take a look at the two directories. So if I do ls-l grub, I can see a splash.xpm.gz. That is the splash screen you see when you boot up your system if you're using grub. So it's being loaded. Great. That's not where you make changes. If you go into grub2, this is also not where you make your changes, but you can see what changes have been made. There's a grub.cfg file here. So let's take a look at that one. grub.cfg. And it's got all this information here. But what's useful is it tells you basically where the files come from. So it's a collection of files from the etc grub.d directory. So it goes through and it reads in these files. So it takes this first one, 00_header, and then it puts the header in there. And then you can see it's adding each piece one at a time. All right. Well, if you go down here, you see there's this 10 Linux, and you can see there's an option here, menu entry. Menu entry. So whatever here is in this menu entry quote is what you will see when you're booting up. That will be the option you can choose to boot. And then it tells you things like which modules have to get loaded, and it then has this line right here, Linux 16, where it tells you this is where you load the Linux kernel. Then right after you load the Linux kernel, you load the initial RAM disk. So it loads that image right there. So those two get loaded, and then you're good to go. So how do I know what it's using? Well, it says a couple of things that are interesting here. There's a timeout that says you got 5 seconds to actually choose which kernel you want to load. And yeah, you can also figure out which kernel is being loaded because you got this default value, things like that. Okay, so what do? We just need to go in there and change what the default is, right? or you can add another line in there. So you go to the etc grub.d directory, and in here you can see all these files that are then thrown together to generate your kernel. If you look at the README file, let's README, you can see information about these. Well, okay, so these are how it does it. So you've got these 00 things for reserved for the header. You got this 10 stuff for your native boot entries. And then you got this 20 stuff for your third-party app stuff, so that they can all jump together and build it up. And it builds this when you run a script or a program to do that. So now let's look at how we can actually generate this. You can generate these things, and you gotta be sort of careful when you get to some of this stuff, because if you mess things up too badly, it can be bad. But there is a grub2 command. So you can see there's a bunch of commands here, but grub2 make config, and that one will generate your configuration file. So you'd want to do -o and tell it your file. So you do like a boot grub2, and if I want to do a grub.cfg file, I can do that. Let's just do a new so I can compare it. So I run that command right here. It grabs all the stuff. That's good. So if I go over to my etc, or actually not my boot grub2 directory, I can see I've got a grub.cfg and a grub.cfg.new. If I do a diff on the two of them, grub.cfg and grub.cfg.new, I can see there are a bunch of differences. What are they? Well, things like, this one, different versions of the kernel, so it's changed the menu options. It looks like I basically just got a new kernel, and I haven't installed it yet. But that's about it. Right there is just slightly newer kernel. Alright. And also it changed the default things for that. So you can mess with your grub configuration there. You can also do things like set a password. There's a grub to make password thing, and you can run that and type in some password like aloha123, aloha123, and it will say your password. You just need to copy that piece and install it into your grub configuration files if you wanted to add something. But yeah, you can mess with your bootloader and change it, and that's how you can work on installing your new kernel and making things work. Mess with grub. So your etc grub.d directory, and then you can just build your grub configuration file at boot time. Anyway, that gives you an idea of what grub is. So is it important to be able to change your kernel? Yeah, sometimes, but it's done automatically whenever you install new kernels. It automatically rebuilds everything for you. Anyway, that is it for your kernels and hardware. System logs and queues. So what are system logs? Well, system logs are basically files, some kind of file that stores information about events that happen. So when something happens on your system, it's usually sent to one of the many log files in the var log directory. And then those files record the events and allows you to look back and see what happened in order to lead up to certain situations you're in, or to figure out what's happening in your system. So what kind of information is stored in the system logs? You have your regular messages. Whenever you start and stop services, that's starting there. You have logs that indicate whenever you boot up your system, what options and things happen there. You have logs that indicate things like mail coming in, going out. You have logs for your web services. You have logs for logging in, logging out. SE Linux has a set of logs. All of these things are in the logs, in the log directory. So why do logs take up so much space? Well, Logs are written anytime some major event happens. And there can be lots of different events that happen, and all these events have a line entry or more in the log files. If someone tries attacking you, you can actually fill up the entire partition that those logs are stored in because you start generating too much data, and it's, well, bad. And if the logs completely fill up the system, well, it depends on where the logs are. So some people will put their logs, their var log directory or their var directory, in a separate partition so that if it does fill up all the way, the system can continue to function. However, if it's not in a separate directory, then whatever directory or whatever partition they're in could completely fill up. And if that's your main boot, maybe not boot, but your main root of your system, that means your system might become difficult to use for anything. So you got to watch out for that. So who reads all these logs? Well, lots of people can read the logs. Well, some of them anyway. But there are some files that can be read only by people who have special rights. So the root user or administrators who have the ability to become root. And those logs usually have more sensitive data. The less sensitive data can be visible to all users. So why can't normal users read all the logs? Well, imagine if someone were to try logging in, and so you saw a login attempt with some username, and you noticed that username looked very much like a password. And then right afterwards, after they failed to log in, a user logged in. And they logged in with the correct password apparently, but you see their name. So then you might be able to take that password and that name and put them together and figure out what the user and password pair is. That might not be something you want normal users to be able to see. Also, other things, if you try doing something bad on the system, maybe you'll generate a log and you don't want that log entry to, well, everyone to know what log entries were generated when people are doing bad things, because then they can figure out what they can get away with without having logs generated. So it can be helpful. So let's go take a look at the log files and see what we see. So if I jump over here to the var log directory, I can see a lot of files. And there are, well, lots of them. Some of them are big, some of them are small. But let's just go through some of the main ones. So we can see that there is a dmessage file at the top. So if I cat out dmessage, D-M-E-S-G, you can see this is information about how the system started. You can see what started, what order, and that can be useful for a few things. Also, you can see there is this last log. Last log is, well, let's take a look at what we can see here. Last log. It looks hard to read. So you can actually type in last, and then it will tell you who's been logging in and when they've been logging in and information like that. It is a binary file, so we can look at it using that tool. You have messages. So let's cat out messages. Messages is where your default log files are for everything. You can see lots of things running through. You can scan through it and figure out what's happening if people are having login failures, all that information. Also, you have the secure log. That shows your logins attempts as well. Cat secure. You can see all of your PAM Unix things, which is basically your login attempts. All right. Then, after you see all that, there's a few other logs in there, but there are some directories as well. So let's go look at these directories. So there is one for audit. So if you go into audit, this is where your SE Linux audit logs are. You cut out your audit file, and you can see all of these SE Linux violations or passes. And you can see what succeeded, what failed. If something failed, it will tell you in here what failed. And this can be very useful for troubleshooting problems. If you're doing something on the web and the web's not working properly, you can go look at your web logs, assuming you have Apache installed, and you can look at web logs and you can see those, but maybe it wasn't a violation there. Maybe it was an SE Linux violation. And then you can go in here and look and see, is there something showing up? All right, if I install Apache, for example, I will see an HTTPD directory show up. So let's do a yum install HTTPD, just so we can see the directory. And now I can see that there is an HTTP directory that just showed up. And I can go into this directory and take a look at that. Nothing here, but then you'll see an access log and an error log whenever there are problems with your web pages. All right, so those are your log files. So what is the var log messages file for? Well, it's your standard default location for your log messages. For any log messages, if you don't have something specific, such as SE Linux has its own audit directory, and HTTPD or Apache has its own HTTPD directory. If it isn't one of those type of services, or it doesn't have something special, it might just write it to the messages log directory, messages file. Can you read it in real time? Yes, you can. It's not very exciting if there's something happening, but you can read it using the tail command. So let's take a look at how that works. If I wanted to look at it in real time, I can do a tail -f messages. And you can see, press enter a few times, that's what happened. There's nothing going on. So if I were to pull up another terminal over here, and let's say, oops, I pulled up a terminal, that didn't do anything. But if I were to install something, so yum install, let's do nmaps, it is there. It's probably already here. Oh, I guess not. You can see that suddenly it says, oh, installed nmap. And you can see that showing up right there in the logs. If I do a yum update, which could probably be a really bad idea from the GUI, but it's nothing replacing GUI. If I do that, you can see suddenly it's showing up a whole bunch of stuff being updated. And you can see those in real time if you're looking at the messages file with the -f switch in the tail command. So tail -f, the file, and you can see changes happening to that file. All right, you press Control C to get out of that. Can the logs be changed? Yes, they can. I can go in there and edit the logs if I wanted to. I could delete things out of it. So if I were some kind of a hacker and I wanted to mess up your system, what I'd probably do is either edit your logs or just delete your logs altogether. So I've had hackers hack into my systems before and delete the logs. And if you notice your log directory is all empty, well, that's usually an indication that something bad happened and some got in your system. The var log secure. So var log secure, once again, I mentioned that one indicates who is logging in your system and if they are failing to log in. So what information is stored in that directory? Well, it's got attempted logins. So let's go ahead and fail a couple of logins so we can see what that looks like. So I could do a tail -f secure. So you can see where it starts. I'll pull up another terminal right here. And now I'm going to fail a few logins. So I do SSH root localhost. Yeah, sure. Password. Nope. Nope. And you can see that it is failing to log in. And then you can look at this and say, well, what happened? Well, you can see failed the password for root, and it says where I logged in from, so it's actually saying, well, I should use IPv6, logged in locally. Okay, from localhost. That's fine. But if you see it from a different IP address, what tends to happen is there are a lot of script kiddies out on the internet, and they are using these lists of passwords, and they'll just sit there and guess your passwords. And, well, try to guess your password. And they grab all the common passwords, and if one of them goes through, then you'll get it hacked into and it'll be over. So don't pick a common bad password or bad things can happen. So don't do that. All right. Can I use the information to identify hackers? Yeah, you can. You can see that clearly I came in from ::1, which was my IPv6 localhost. Can the information identify users who are doing things, or can I identify users who are doing things they should not do? Yeah, sometimes. It depends on what you mean by identify users also. Sometimes they are trying to switch over to root when they're not supposed to, and that could show up. Sometimes, other things can happen. But what it really tells you is what user is trying to do it or what IP address is trying to do it. It doesn't tell you who the person was or where they came from. Can I use the information to detect system compromise? Well, sometimes. Sometimes you can't. Sometimes all you can see is that they were attacking your system and trying to get in. But that doesn't mean they got in there. Can I use the information to identify users who forgot their passwords? Maybe. You can see who's failing login. Does that mean they forgot their password? No. Does it mean that they're a hacker? No. It could be either one. It could be other things as well. It could be their cat jumping on the keyboard. We don't know. All you know is that someone is failing login. And that's all you see there. What does it mean to rotate logs? There is a program you can install called log rotate. And what that does is it will take all of your log files, or many of them, and every week or whatever set period of time you want, it will rotate the logs. And what that means is it will take the existing log file and move it to a new file with a number extension, and then it will create a new file. And what happens by doing that is you can then decide how long you want to keep logs for, and if you want to just let logs disappear after a month, and then your system might not run out of space and might not crash. Can the log searching process be automated? Because I can look at those logs right there, and there is a tool called LogWatch, which you can install, which will go through once a day, a little cron daily thing, scan through it and figure out if there's anything that looks suspicious, and then send you an email to let you know what things can or are bad. Can logs be stored on a different machine? Yes, they can. So your logging utility is usually your syslog program, and there are different syslog programs, but your syslog program can be configured to send your logs to a different machine, which can be useful if you want to save your logs. You can also configure your Linux machine to receive logs from other systems. So you have your Cisco routers and switches all send their logs to this machine, and you get them all consolidated in one safe location. Then if the router switches get hacked and the logs get messed up, well, they're already on this machine, they're gone. So you've got a copy and they're safe. Queues. What is a queue? Well, a queue is a line, right? It's a British word for line, kind of. You queue up, and well, that's what a queue is. So what is it on the computer? Well, on the computer is basically a line. You have these things that are getting ready to do something. So you get them ready. You can have your mail queues and things of that. So then what's a spool? Well, a spool is when you think of like a spool of thread or something, things are wrapped around it. Basically, it's kind of feeding things through something. You're spooling it through. So spooling your print jobs from your application to your print daemon, which then spools it off to your print server or to your printer, and it eventually gets printed. That's spooling, passing things through. And queues and spools can kind of be thought of as similar things. They're a little different, but they are used for the same kind of purposes. So what queues are used on a Linux system? Well, let's take a look. So I clear my screen there, jump down to the var, and there is a var spool directory. In this var spool directory, you can see a couple different things. We can see var spool postfix, var spool mail, var spool cups, var spool lpd, var spool cron, like lots of different things. So postfix is my mail server. My mail directory is my, well, incoming mail. LPD and cups are both for print services, so that's kind of nice. cron and at and anacron are all for timed task management. So yeah, you kind of get an idea there. Let's take a look at the mail directory. Oops, cd mail. You can see there is a Joseph and an RPC, but Joseph is empty. If I were to have a mail client installed, I can do mail, should mail Joseph, and I can have subject say something, and say, hey there, and have a period by itself, and close it. And then if I take a look around, suddenly I see Joseph got mail. So I just sent him mail, and it went into this mail spool thing. So if I cat out my Joseph file, I can see all of the mail that got sent to him. So you can see who it's from, information about where it's to, subject, the from line, and then the contents of the email all showing up right there in this mail thing. If I send another email, it will show up in the exact same file, just added to the end. If Joseph logs in, he can then read his mail and he'll pull it out of this file and into his home directory. So that's that directory. All right, what about cups? You can see just temporary stuff here. LPD. It's basically the same thing. They're just printing services. If I go into postfix, though, you'll see something more exciting. It's got a lot of different directories. You've got the incoming, you've got the outgoing stuff, the bounce directory. Well, if you think about it, a mail server is a lot more complex than you might think. I guess if you think about it, yeah. So what happens? Well, you drop your mail into your program. This mail program, it puts things in here. It looks at them. It tries to send the mail. It receives mail. If it can send mail, it sends it. If it can't send it, it might have to sit there and defer it or bounce it or something else. It depends on what's going on. And so this keeps track of every single piece of mail and what state it is going through this mail system. So that can be useful. So let's jump back over here. So where is incoming mail stored? Well, we just looked. It's in the var spool, and then you have to decide which one you're looking at. What do you mean incoming? Is it incoming that's already arrived or incoming that's incoming? If it's incoming, it'd be in the postfix directory if it's using postfix. And outgoing would be in postfix as well. So var spool postfix. But once it has gone through postfix and been processed, it'll get put into var spool mail. Why do I care about mail? Well, lots of different tasks and things on the system will use mail as a way to communicate with the users. So whenever you have cron jobs that produce output, it creates mail. Whenever you have log rotate, mail not log rotate, but log watch, looking at the logs and finding problems, it'll report these log errors or these suspicious behaviors and things you can see to your mailbox. So you can look at it. Why is mail stored in queues? Well, it has to do a lot of waiting and moving. And so you really need it in queues. Where are the print jobs stored? Well, they're stored in that spool directory, right? The var spool cups is our print server. Right now I don't have the print server configured for any printers, but if it were, you might see some stuff in there. And if I was sending print jobs through, you'd probably see that as well. So why are print jobs put in a queue? Well, printers don't always have enough space for all the print jobs that they receive all at once. And so you send it to a queue, and the spool queue slowly feeds it off to the printer as the printer is ready for another job. So that can be important. Make sure that you don't lose jobs. Otherwise, if you send too many jobs and it can't hold them all, they get lost. So that's why it's important. And that's our little quick thing on system logs and queues.
Linux installation. So we're going to talk about CentOS. CentOS is based on the source code of Red Hat Enterprise Linux, RHEL. The CentOS distribution is community-based, and it does get some support from Red Hat in the form of paid developers. Red Hat pays for Red Hat developers, they also pay for Fedora developers, and they also pay for CentOS, some of the CentOS developers. So where does it fit in the distribution families? There are a couple of different major sources of, well, Linux distributions. You've got the source code based Linux distributions. That would include things like Slackware, which is one of the oldest. You have Gentoo and Arch, and even Android's kind of a source code based Linux distribution. Then you have the whole Red Hat family. Red Hat family includes Fedora, which is kind of their development suite. You have CentOS, which is a version of Red Hat with a lot of the proprietary stuff and branding removed. There is Oracle, which is basically the same thing as CentOS, except it's paid for by the Oracle company there. Red Flag, which is the Linux distribution put out by China. And then there's also things like OpenSUSE. So these are all in the Red Hat family. So they all have a lot of similarities. They all have the same Red Hat package management system, so you can identify them that way. Then there is the Debian family. The Debian family would include Debian, but you also have Ubuntu and Mint. Basically, you have Debian, and some people thought, well, it's kind of complex, so let's make it a little better. And so then you have Ubuntu, which based off that, then they decided, well, that's a little bit too complex, so they added a little bit more. They gave some more proprietary drivers. You got Mint. And then you have other distributions such as Kali, which is your penetration testing distribution, which also is based off of the Debian family, probably based off of Ubuntu most directly. All right, when you're doing an installation, the first thing that you come across is you have the Anaconda installer. So Anaconda is just the name of the installer, but Red Hat based Linux distributions such as CentOS Linux use Anaconda as the installer. So you'll find that lots of these distributions have an installation wizard that looks the same. That's Anaconda. Anaconda is an installer written in Python. It's got some C parts as well, but it is responsible for making sure the operating system is correctly applied to the machine, put in place. You have the bootloaders and everything else in place, and it boots up. Anaconda works great some of the time. Sometimes it fails. It fails, well, a lot more than the actual Linux distribution will fail when it's running. So you got to be careful with that. Sometimes you have to start over, but that's usually okay. When you're in Anaconda, you have to configure networking. You need to make sure you configure a host name for the machine. Every machine should have its own host name. Don't stay with localhost. Make sure you have a host name. You want to make sure the machine has either DHCP or static manual addresses configured. You can go in there and configure it up. Make sure you have it set. If you do DHCP, you have to make sure that you have a DHCP server in the network it's going to be residing in. If it is not doing DHCP, then you need to make sure you configure all the important parts of static or manual address configuration. You need an IP address, you need a mask, you need to have a gateway, and you need to have a DNS server. Also, after you configure the networking, you want to make sure you activate the interface so that it will come up when you start. You want to make sure you configure the date and time. Well, it's not really date and time you configure, it's more setting the time zone. That's kind of the important thing. You want to make sure the time zone is set, and it's best to set your time zone after you've already configured networking, so it'll automatically decide that you have networking and it will use network time. Network time provides the NTP protocol, or the network time protocol, to allow it to synchronize with time servers and get updates automatically. Normally it saves the time on your machine as UTC time, basically the Greenwich Mean Time or Zulu time. Windows, on the other hand, stores it as local time, so what's written to the hardware might be different for Windows and Linux, and that can cause problems sometimes. if you have a dual boot machine or a machine that uses both operating systems. Software selection. You want to make sure you select which software needs to be installed. So when you're starting, the easiest thing to do is to select the GNOME desktop. GNOME desktop will give you all the essentials and get you a GUI so you can have this clicking ability and the ability to do, well, easier things. However, Linux was designed mostly to be run without a GUI. GUIs have been built afterwards, and they're nice and they can be very pretty, but you don't really want a GUI if you're running a server. So in a production environment, you want to start with a minimal install and just add the features you need and not have everything else, because there are security issues if you have too much. Any software you miss during the installation can be added after, as long as it's not something like network drivers, because you need the network. Installation destination. So Anaconda can automatically create partitions for you, or you can create them manually yourself. So there are two main kinds of partitions you will see. You can see the standard partitions you can create. Those are your normal fixed length partitions with older style device names, things like /dev/SDA1, which you don't need to worry about. Or you can use the LVM partitions. LVM partitions basically creates this giant, well, Linux volume management partition, and that partition is kind of a standard partition, and then within that you create these blocks that you can then use, and that allows you to be more flexible, resizing and adding things and allowing you to span multiple drives much easier. When you are configuring your partitions, there are lots of different directories you can consider to have as separate partitions. Normally you want to have a root partition, which is the /. You want to have your partition for virtual memory, which is your swap, and you also want to have a partition for the bootloader, the /boot. That also includes things like the kernel and initial RAM disk. So those three are your general three you have. Sometimes you add more. The var directory contains logs, and sometimes you can have problems if your logs fill up and it takes down your entire server, so some people put it as a separate partition to prevent that from happening. When you are done and you start the installation process, you are then given the option to create users. The main user for the system is called root. So root needs to have a password, needs to be nice and secure. The root user has all power as far as the users go on the system and can do many damaging, destructive things. You can also have additional users, and additional users are very good to run on the system because they don't have all power, which means that if they make mistakes, they don't necessarily cause as much problems. These users could also be administrative users. So what happens is if you click the checkbox to make it an administrative user, it will add the user to the wheel group. So there are groups, and the wheel group allows members to run commands as root using the sudo command. So you type sudo space the name of the command. It will then usually prompt you for the user's password, and then after that they can run the commands as root. When you are done with the installation, sometimes you see a license agreement portion. If you're doing minimal install, you don't necessarily see it. Sometimes you do. But you need to be aware that Linux comes with a license like any other operating system. It comes with a license. And most of the stuff, most of the packages you get on Linux are distributed under a free software or open source license. Free software licenses require all derivative works be distributed with a similar license. So if you have access to modify it, then this derivative license means that anybody else, when you redistribute it, has the same rights you received. So you have to provide those same rights. Open source licenses allow you to see and modify the code, and that's basically what they do. Now, free software licenses are a special type of open source license, slightly more restrictive, but it makes for more security of the source code in the long run. Once you have your system up and going, you should probably update it. Most Linux installation disks are not absolutely new, and there are updates that, well, need to be applied. So the first thing you should consider doing is updating your updating system, updating software. So you can type in yum update yum. Yum is your updater, so you want to update yum first. Now after that, something you need to keep in mind is that there might be updates that include, well, packages with libraries that are part of your GUI, and you do not want to update your GUI from within your GUI, so you want to make sure you get out of it. You can press the Control-Alt-F2 key sequence to drop into a terminal back place where you can type in commands and not be inside the GUI. You can also press Control-Alt-F1 to switch back into the GUI. On older versions of Linux or other versions of Linux, sometimes it's Control-Alt-F6 or Control-Alt-F7 to get into your GUI. Just make sure you try a few, you'll figure it out. Once you are outside of your GUI, you want to update your system. So I recommend you don't even log into your GUI until your system is fully updated. But just type in yum update and that will update your system. And that is it for this lecture. Network File System, or NFS. The NFS protocol was developed by Sun Microsystems, which is now Oracle, in 1984. It was built on the Open Network Computing Remote Procedure Call, ONC RPC. It has some open standards. These are RFCs 1094, 1813, 3010, 3530, 5661. So you can look those up and look at the protocol and find information. NFS was originally just a Sun Microsystems thing, and then it went to other Unix distributions, made it to things like Linux and Mac OS X, and eventually to Windows. So it's available all over the place, and it's pretty good. So in order to get NFS running, you need a couple of useful utilities. NFS-utils is a package you can install which provides NFS. You also probably want to have man pages. This is in general for everything. You want to have man pages for, well, reading the man documentation. The NFS service needs to be started after the remote procedure call service is running. If you don't have it running, bad things happen. So on a CentOS 7 machine, you want to do a systemctl start RPC bind and start that service. You also want to make sure that if you want it to start automatically at boot time, you do a systemctl enable RPC bind and make sure it's there as well. NFS should only be started after RPC. Once you have RPC running, you can do a systemctl start NFS server and get the server up and going. You can also enable that one as well to make sure it's running at boot time. Now the NFS server needs to have a list of directories it's exporting. These directories are listed in the etc exports file. So the basic format is you type in your share name, that's the directory location that you want to be exporting, and then you want to decide, well, you list who you are exporting it to. If you want to export it to everybody, you just put a star there, and then inside the permissions you list, well, information about what permissions you're exporting it as. So if it's read only, you do RO. If it's read write, you do RW. If you want to do something else, you can put other permissions in there as well for the exporting. So once that's there, you can use the export fs command to actually export the directories. Usually you type in export fs space -a to export all of your shares that are being shared in that etc exports file. You can type in the export fs command by itself to then get a listing of which directories are being exported. NFS doesn't really work well if you cannot get through the firewall. So you need to make sure you allow it to get through the firewall. So you go in there and you use the firewall-cmd command, and you give the options. You can give it the -- zone equals public. That's actually optional. It's just default. But you want to do an add -service equals RPC bind, just like it's displayed here. So it's -- add -service equals RPC bind. That will allow the RPC bind to get through. You also want to add the NFS service through. Now, these are both great. If you then restart your firewall, they will no longer be there. So you want to make sure you use the -- permanent option if you want them to be written to the firewall configuration file and be there after the firewall is rebooted. All right, you can then verify they're there. You can use the firewall-cmd command -- list services to see which services are there. You can also use the firewall-cmd space -- list all command to list all of your firewall rules. I like the bottom one better because it gives me more of a big picture of what's actually going on. Okay, once again, to make services available at boot time, you need to make sure the system has a proper symbolic link for you to run it. So each run level has a set of symbolic links. In CentOS 7, they have simplified it. In earlier versions with the init, before you had the systemd, you had these 7 run levels, 0 through 6, 0 being halt, 6 being reboot, and 1 being just your basic system, 3 being your multi-user system, 5 being your GUI, and they decided to simplify this down to just a couple. So you got your multi-user one and your GUI one. And what happens is when you use the systemctl command with enable, it will create a symbolic link from that run levels directory over to the actual script that starts. So you just do a systemctl enable and enable your services, the RPC bind and your NFS server. When you want to mount NFS shares, and I would recommend mounting NFS shares as a test before you put it in anything like your file system table FS tab, you want to make sure you can mount them manually. So after the remote server has the shares exported and the NFS server is running and the firewall is out of the way, you can mount the shares. So you just type in mount the remote server's name or IP address, the share or the directory being exported, and then the mount point you want to mount it at. So the directory name of the location you want to mount it to. So if I had, let's say, a friend who was exporting his music files and I wanted to see the music files, assuming this is all legal music files, of course, he might be exporting it from myfriend.com or example.com, and it might be the /music directory, and I might want to mount it into my local music directory. So I might type in mount space example.com /music space /local music, and then it would mount up and hopefully everything would work perfectly and smoothly. Alright, so in addition to just being able to manually mount things, sometimes you want to have it automatically mount on boot time. This is especially important for situations where you have a machine that is getting its home directory from a server. So you can have the server exporting the /home directory. It might be mounting the home directory from the server, and you want to then go into the etcfs tab file and, make sure it's mounting. And there is a standard format for all of the mounted partitions. You want to give it the device name, the mount point, the type, your options, the dump number, and the file system check number. The device is the server, and with a colon and then the share. So if you are going from example.com/home, then the mount point would then be where it's mounted to. So maybe it'd be something like /home. The type would be NFS. And then you have your options, any options for mounting, whether or not you want to allow it to mount smoothly, or if you wanted to make sure it's got this hard mounting, whether or not you want it to crash when it goes down. Usually just defaults. And dump and file system check usually just leave zeros. Anyway, you can read all about using the FSTab file and the formatting in the man pages, which you should have because you have installed the man package. When you're troubleshooting, you want to verify that your IP address is correct. So go take a look at the IP address, make sure it's correct, make sure the IP address of the server is correct, make sure you are in the same network, things like that. Verify that the services are running. You want to make sure the server is exporting everything, it's running. You can use netstat, you can use exportfs to make sure it's exporting. Verify the firewall is on the way. You can use the firewall-cmd --list-all command to see what's actually being allowed through the firewall. You want to make sure that the remote server is up and you can ping things. You can use tools like nmap. You can install nmap and use that also to verify ports are available when you're scanning the remote server. So good luck with your NFS installation. Samba. The Server Message Block SMB protocol was originally designed at IBM for use in DOS operating systems. Microsoft started working with it in 1990 and has incorporated it in Windows since Windows 3.1.1, which was Windows for workgroups. The Samba package implements SMB and uses it for communication with Windows devices. The SMB protocol has many security concerns. The SMB protocol has received many security updates since Windows Vista. However, it is known to be a security risk because of older implementations and even some newer bugs. We can use SMB to hack into Windows XP and Windows Server 2003 machines. With Windows XP, all you had to do was have file sharing ports open through the firewall, or just have your firewall turned off, which was very common for gaming back in the Windows XP days. Windows Server 2003 came right out of the box open for attacks and complete takeover through the SMB protocol. Many major companies, including Sony, have been hacked through the SMB protocol. There are a lot of useful packages in Samba. On the Samba set, there is the Samba package, which installs Samba and dependencies. You have the Samba client, which provides the SMB client, which allows you to navigate through remote Samba share and download and upload files. You have CIFS utils, which allows you to mount Samba shares, and you can even set it up so they mount automatically in your FSTab file. The Samba service can be started using the systemctl command. You just use systemctl start SMB and it will start the Samba server. You can also stop, restart, and check status. If you wanted to start at boot time, you just use the systemctl enable smb.service to enable it. In order to allow other machines outside of your individual server to mount your Samba shares, you need to open up a hole in the firewall. So the easiest way to do that is to add the Samba service. So you can use the firewall-cmd command. You can add the zone if you want. Then --add-service equals Samba. You can verify the service is present in the firewall using multiple commands, my favorite being the bottom right there, which was or is firewall-cmd space --list-all, which will list all of the services that are available through the firewall. When you want to configure Samba, the main configuration files are found in the etc Samba directory. The most important of those configuration files is the smb.conf. you might be able to find a file like smb.conf.example, and you might want to copy that over the smb.conf file before you start editing, and then you can go in and set all kinds of configuration settings because they'll be available and easy to see. Here is an example of an excerpt of, well, part of the smb.conf file. We have a share called software, which is being exported. That share is based on the /share/software directory. So whatever files in that /share/software directory are being exported. When that directory shows up on a remote machine, it will be called Windows Software Packages. It is public, so you can see it. It is writable, so it's read-write, but it is not printable, so it's not a printer. So that's the information you see right there. When you want to share your Samba shares, you might have issues with SE Linux and their context. SE Linux is very good for protecting you from very bad mistakes you might make, but files shared using Samba should have the correct SE Linux context type of Samba_share_T in order to be able to be viewable by the Samba service. To change the context of the file, you can use the chcon command, which is change context. So chcon -t for the type, Samba_share_T, and then your file name or directory name, and it will change the context type so that the Samba service can see the file. If you're having trouble with Samba, it's good to verify the IP addresses are correct. You want to verify the services are running. You can use netstat to view that. You can verify the firewall is not in the way using the firewall-cmd --list-all command to see which services are allowed through the firewall. You can verify the SE Linux context is set correctly. You can use this ls -Z or ls-al-Z, and that will tell you the context type of all the files in the directory. Or you can just do ls-Z of the file to list its context type. If it's a directory, you want to add a D in there. So there's all kinds of things. You can verify the remote host is up using ping. You can verify remote ports are open using nmap from a remote machine. And you can also check the logs to see what's happening. And that is your overview for Samba. Apache Web Server. The Hypertext Transfer Protocol, or HTTP, was created by Tim Berners-Lee and his team. They proposed the World Wide Web project in 1989. They had a first working version in 1991, and then the RFC that defined it, RFC 1945, was in 1996. However, by the time many web browsers were already out there and people were using the web. There are multiple RFCs, including 2616, which is for the HTTP 1.1 protocol. The HTTPS protocol, or the Hypertext Transfer Protocol Secure, layers the HTTP protocol on top of the SSL and then now TLS protocol. So SSL 3 is the same thing as TLS 1, so basically it's just kind of transferring over to the newer ones. So you want to make sure you have TLS, not SSL. It was created by Netscape Communications in 1994 for the Netscape browser. So the Netscape Navigator browser, and used, and everyone else started using it. It created an industry for signing digital certificates. So many companies were able to make money off of this, including the Ubuntu project was funded by Mark Shuttleworth, who made his money off of this as well. HTTP security concerns. There are some concerns you should think about. All communication over HTTP is plain text and easily sniffed or wiretapped. People can read it. They can also inject their own stuff into it. Some ISPs are starting to inject ads or JavaScript into your sessions and break things, and that's always nice. Gotta know who your ISPs are. Web servers and web browsers cannot prevent programmers from making mistakes or malicious users from exploiting these mistakes. So you have to keep that in mind. The HTTPS protocol also has some security concerns. There are various SSL and TLS protocols with different levels of security, so you need to keep that in mind. If you get a browser that allows you to have keys of size 0, that's not so good. You just need to make sure you know what your browser allows, and if you're running a server, know what your server is serving. Certificate authorities are sometimes exploited and used for further exploitation, so you need to be aware of that. And then government agencies such as the NSA have promoted protocols with secret vulnerabilities, such as random number generators that don't produce random numbers. Some useful packages include the HTTPD package, which provides the Apache web server. You have Lynx, which is a text-based web browser for testing things if you are not running on a GUI environment. Sometimes you want to test things from the server, and Lynx is pretty good for that. Also, OpenSSL, which allows you to make certificates. You can also sign your own certificates. You can get the certificate signing request. You can then use and send to a third party who will sign them for you. So OpenSSL will do that stuff for you. Mod SSL will allow you to integrate into Apache the HTTPS functionality and then serve secure web pages. The Apache web service can be started using systemctl. You can use systemctl start HTTPD. You can also stop, restart, check status, and also you have this reload option. Reload is interesting because what it does is it will send a signal to the server. The server is then prompted to reread its configuration files, and the server is actually multiple servers running, and when you send this over, the main service can reread the configuration files and respawn new children, and then just let the other children, well, kill them off. And then you won't have to worry about it anymore. So you can keep your server running while you change configurations, which is kind of nice. There are some other issues. Whenever you want to connect to your web server from the outside, you need to get through the firewall. The firewall is not open by default for the HTTP and HTTPS services, so you need to open those up. You can do that with the firewall-cmd command. You just need to use the --add service equals HTTP or HTTPS options. If you want it to be permanent, you can use the --permanent option as well, and that will make it so the firewall is open and, well, permanently open. You can use the firewall-cmd space --list all command if you want to see which firewall rules are in place and which services are available, so you can know if you will be able to get to the firewall. The main Apache configuration files are found in the /etc/httpd/conf directory. Also, you have this etc httpd conf.d directory, which has these other configurations such as user directories and SSL configurations. But the most common file you'll work with is the etc httpd conf httpd.conf file. This httpd.conf file is the main file, and there is a directive in that file that loads all the other files in the conf.d directory. So in that directory you can, well, in that file you can configure your Apache web server, tell it which ports are open, you can tell it whether or not it allows certain types of data or other types of pages such as server-side includes and CGI. You can turn those things on or off. You can also change which directory index files are used when a file is not specified within a directory. So normally that's index.html, but you can have it be index.cgi, index.php, index.shtml, many different options. So you also have a directory setting in there where you can change where the directory root is, and you can also change your document root. Your default document root is your var www HTML directory, so you can go there and see your web pages or set your web pages. When you are creating web pages, there are a couple of SE Linux context types you should be aware of. The following are some that are used by Apache. You have this httpd _sys _content _t, which is used for regular system-wide web pages when you're serving web pages for your web server. You can also use CGI scripts, and I like CGI scripts a lot, and so I think it's very important for me to know the httpd sys script exec t type, which you have to set on all of your CGI scripts, as well as setting your execute permissions or execute bits. If you are not in the normal system directories and you are in userland, well, all of this is userland, but in home user directories, and you've turned that on in your user dir configurations, then you can use this httpd user content t or httpd user script exec t and keep those in mind. In addition to those types, you also have types for directories, whether or not you are allowed to upload files or not upload files, and so just keep that in mind. Troubleshooting. So when you are having trouble with your Apache web server or web pages, it's good to first verify your IP address is correct. Sometimes it isn't correct. Sometimes you have DHCP. You want to make sure you have a static IP address, or if you're doing DHCP, that's fine too. But verify the services are running. You can use netstat, and you can check to make sure they're there, and listening. Verify the firewall is not in the way. You can use the firewall -cmd space --list -all command in order to verify the firewall is not blocking anything. Make sure it's open. You can use the SE Linux commands. You can use the ls -al capital Z in order to see the context types of files and make sure they are correct. Sometimes this is really important in a situation where you have SE Linux running. You have all your permissions set correctly, and you think a file should be available, but Apache just can't see it. So SE Linux. Also, that tends to throw up SE Linux, well, errors in the audit log. So you can go to var log audit log, I believe, to look at the audit logs. You can also verify to make sure the remote host is up, and you can ping it. You can use nmap to scan it, make sure the ports are open. You can also check the Apache logs, so var log httpd, and make sure the access log and error logs don't show anything, or if they do show something, use that to troubleshoot. And you can also check system logs and see if you have trouble starting the Apache web server. And that is the end for this presentation. Database servers. MariaDB is a database based on an older MySQL database. It was also created by the same people. MariaDB is a drop-in replacement for MySQL. MariaDB is a relational database management system, so that's RDBMS, and implements the structured query language, or SQL. So here's a little bit of the history. So MariaDB, well, it's kind of a fork. First, MySQL was created and replaced Oracle in many projects, especially in open source. Oracle was not very happy with this, and it wanted to do something to solve the problem. So there was a time when MySQL was not financially able to continue on, and so that became an issue. So Oracle was trying to get rid of MySQL, and it acquired multiple companies that provided libraries to MySQL, and that was a bit of an issue. Eventually, Sun Microsystems acquired MySQL, did the whole white knight thing, and saved it from Oracle takeover. However, a little bit later, Oracle discovered that they could grab MySQL, Java, and other things all at once, and they bought Sun Microsystems. Eventually, the developers of MySQL decided to fork the MySQL code, and they formed MariaDB. The current versions of CentOS use MariaDB as the database. There are a couple of MariaDB security concerns. First of all, the default MariaDB installation does not have a root password, so you can create users, database, tables, all without setting up a password. Also, this might not be a major security concern, but administrators can reset the root password for the databases and get full access if they want to. It might actually be a helpful thing if you lose access to your database and you can't get back into it. The root user can then help you get back into it. There are many useful packages. There is the MariaDB, that is the client programs, the MariaDB server, which is the server, and then there is the MySQL-Python package, which provides a way for the Python language to communicate with the MySQL or MariaDB servers. Generally, the configurations for MariaDB are just fine and you can leave them alone. However, if you do want to go in there and make some kind of a change, you can go into the etc/my.cnf.d directory and you can find configuration files in there you can mess with. The standard format of the configuration files is a name equals value pairs. For example, you can type in port equals 12345 and you can change which port it runs on. Here are a couple of sample MariaDB commands. So from the command line, you can type in MySQL to get into MariaDB. You can also do options such as -u and the username, or -h and the host name, and -p to prompt for a password. And this will get you into the MySQL or MariaDB databases, depending on which one you actually have installed. So once you're inside, you can create databases. You just type in create a database and then the name of the database you want to create. And then to actually use that database, you use the word use and the database name, and it will change your prompt and indicate that you are now inside of that database. Once you're inside the database, you can create tables. So here's an example: create table people, which gives it 2 columns. You have name and age. Name is a primary key and it is a varchar 250, and age is an integer. So with those tables, here are a couple of sample SQL statements. You can insert values into that people table. You can update the people table and replace information. You can do select statements to pull information out, and you can also delete records from the table. So these are the 4 basic commands. You have insert, update, select, and delete. There are other commands, obviously, but those are the main 4. You can also do things like insert into the table, and then if there are duplicate keys, you can just update instead, which is very common for things like logs, and so I do that quite a bit. So if you're using Python and you want to do programming, here are a couple of pieces of, well, a bunch of code examples thrown together onto one page. You want to import the MySQLDB library, and you want to make sure that you pay close attention to case here, because the case is important. You want to connect to it, and then once you connect to the database, you want to create a cursor. A cursor is where you send your commands. So you just send your commands, you can execute the SQL statements, and after you've executed the statements, you can sometimes grab back data. If you make changes, so inserts and deletes, sometimes you want to commit that, and that is committed not with the cursor but with the actual connection. And then when you want to close, you can close the connection itself. If you're trying to troubleshoot MariaDB, you want to make sure your IP address is correct. If you are going to a different machine, which is not usually the case, but you could, You want to make sure the services are running. If it's not running, it's very difficult to connect to the database. You want to verify the firewall is not in the way if you are going over something. Normally, people just run it on their local machine and they use Apache to actually get out. So you're interfacing with a web server, and the web server is talking directly to the database. And so the firewall is not an issue. You want to make sure that any SE Linux stuff is not changed. If it is changed, you go and verify things. You want to make sure if you're going to remote machine that the host is up, and make sure that ports are open if they need to be. And if there are any problems and you can't figure it out, just take a look at the logs. Most of these things only matter if you are using a remote machine, which is very unlikely. Anyway, this is your MariaDB or database overview. Secure Shell. The Secure Shell or SSH protocol was created in 1995 to prevent sniffing of telnet and rlogin traffic at Helsinki University of Technology. SSH is encrypted, and telnet and rlogin were both not encrypted and still aren't encrypted. So the SSH protocol uses the Diffie-Hellman key exchange for key generation that it then uses to symmetrically encrypt data. Many programs use SSH to create tunnels and transfer data securely. The SSH package is normally, or the packages are normally installed on a CentOS or other Linux system by default. However, if you want to install them or take a look at them, they are the OpenSSH server package, which provides a server, OpenSSH, which provides some of the tools, the OpenSSH clients, which provides, well, clients, and then another useful package, which is not actually SSH, but is closely tied to it, is rsync. Rsync allows you to synchronize data on two ends, so a client and server can synchronize data over SSH. I can do it itself without SSH as well. When you're configuring SSH, there are a couple of configuration files. The main SSH configuration files are in the following two files. You have the etc ssh sshd_config, and the same thing without the D. The one with the D is for the server, and the regular one, the ssh_config, is for the client. Individuals can also have additional override type information for their clients in their .ssh directory, their home directory. So some common configuration changes you would see on the server end is disabling root logins, which is very important in situations where you're constantly being attacked by people trying to log in your system. If you don't want them to have the option of doing a brute force login, you can just disable root logins, and then they have to log in as a different user and then switch over somehow using sudo or su. You could change the port number. Sometimes people change it from 22 to something else, and then they log in with that number. You can disable password authentication, which means you have to use keys to get in, which makes it more secure. This is very common. Amazon Web Services does this by default. It makes it more secure and less likely to be hacked because, once again, you can't do the brute force logins. And you can also do changes to things like X11. X11 is your GUI system. You could set it up so that you can export your GUI or not export your GUI. The Secure Shell service. So SSH is on Linux systems OpenSSH, and it can be controlled using the systemctl command. You can use systemctl with start, stop, restart, status. You can enable or disable if you wanted to either not start at boot time or not start boot time. And so systemctl start, and then the service name which is sshd, and you can use the .service if you want. By default, SSH is allowed through the firewall. To make changes, you can use the firewall cmd command, and you can either add the service. If it's not there, you can remove the service, or if you want to, you can, well, additionally, you can make the rules permanent with the -- permanent. Note that if you use the -- permanent option, it will not change the active firewall settings. It will only change the configuration files, so when the firewall is restarted, it will have the new settings in place. You can verify the services are present in the firewall as well using the firewall-cmd command with the --list-all option to see what's in the firewall. When you connect to unknown servers, SSH prompts you to accept the public key that it is presented with. Keys are remembered and stored in a file called known hosts, and remote keys will change very rarely. It's only when the machine is replaced or new keys are generated, or if someone's trying to hack you and there's some kind of a man-in-the-middle attack where they're trying to impersonate the server. You can manually add and delete entries. This is useful when you trust the changes, but not so good when you don't trust them. SSH has the ability to use keys to authenticate. In order to authenticate using keys, the client machine needs to create a public-private key pair set. The public key needs to be installed in the server, and the server has a authorized key file in each user's directory that can be used, and then you can just log in directly using the authorized key. You can create the key pairs using the SSH keygen command, and then you can install them either using the SSH copy ID command, or you can manually copy them over and then put them into the authorized keys file. Here are a couple example incantations of things you can type in. You can type in SSH keygen to generate keys. You can tell it what type with the -t option. You can copy the key over, the public key over to the server using the SSH copy ID command. You can manually copy it using SCP, and once you get it copied over there, you need to log in that machine and use the cat command or some other command to get it into the authorized keys file. If you want to, you can also tunnel. Here are a couple of exciting tunneling incantations. The tar command can create, well, archive files. And this command, basically the first command right there, you're creating an archive file, and the destination of that file is actually the standard out. So that kind of works. And then what we're doing is we are piping this into the SSH command, which is then on the other end using the cat command and redirecting its standard into a file. So what we're doing is creating a tar archive that is being put into a file on the remote machine. And you can look at the rest of these things. They are kind of weird incantations, but it gives you an idea of some of the things that SSH can do. If you want to troubleshoot SSH, you want to make sure that you can connect to the machine. That's usually one of the biggest things. You could either have the address wrong, or you could have the host name wrong. You want to make sure the service is running. If it's not running, then that can be a problem. You want to make sure the firewall is open and you can get through it. You want to make sure the remote host is up, and so you can ping it. You can use Nmap to scan it to make sure the SSH port is visible. And you can also be on the server and look at the logs to see if you're having trouble logging in. And this is a brief little overview of SSH. Mail servers, most specifically postfix. So the Simple Mail Transfer Protocol, or SMTP, was published as RFC 788 in late 1981 by John Postal, who is considered the god of the internet. John Postal produced many different standards. Lots of different RFCs have his name on them, especially the early ones. He disappeared toward the end because he died, but he was one of the founding inspirational members of the creation of the internet. So this SMTP protocol uses plain text commands to communicate with remote servers listening on TCP port 25. You also have webmail and application client programs that send mail, and what happens with those is you have this front end, but you still have a mail server in the back end. So this local mail server that handles all the communication with the remote servers. It sends and receives them, and then use the webmail or application clients to retrieve it from the server and send it to the server. There are many different directories involved with these mail servers. The etc postfix directory contains all the configuration information for the postfix server. You have the var spool mail directory, and that one contains all the email that has been received and processed and put into users files. So there's an mbox style file. Basically just lists all the email messages one after another in one long text file. So you can go there and grab the mail messages for each of the users. And then there is these var spool postfix directory, and that's where postfix stores data it's using as it's acting as a server. All the incoming mail, outgoing mail, it stores them in different folders. There are lots of things in the protocol, such as the ability to retry sending mail when the server's down and other things like that. And so it has to maintain and hold things that are still on their outbound direction. Also inbound as is processing and looking at things. The var log mail log file is a log that can be used to troubleshoot email related problems. All kinds of things show up in there about the mail server and mail messages coming in and out. There are some SMTP security concerns. First of all, plain text messages can be viewed in transit. So if you are sending or receiving mail, anybody along the way between the source and the destination could look at the mail and read it. Now that doesn't mean you can't encrypt your message inside of your mail, but the header data would still be unencrypted. So you have to keep that in mind. All of the messages are plain text. If the message itself is encrypted, that doesn't mean the headers are encrypted. Anyone can send unsolicited messages at a very low cost. So spam is very cheap. You can send all kinds of mail. You can claim to be anybody you want. There are a lot of different changes in how mail servers are handling this. And so they can look at things and say, well, you're claiming to be from one server, but you're actually sending it from a different server. And then they can mark you as spam. And there are other things they can do to try to filter things out. Also, the protocol allows for things like relays, which make it easier to spoof sources, so you can send mail messages through a server. Most mail servers now are configured by default to not allow relaying, but relaying is still possible and it can still be turned on. The messages themselves can carry malicious files or content. You got things all the way back to the I Love You virus that was hitting people's machines and then being processed locally and causing all kinds of problems, to more recent malicious things. You can have all kinds of tricky messages. You can have messages telling you about a Nigerian prince or selling you things, claiming to be somebody they're not. And yeah, those are bad. And rejected messages can be used to perform directory harvesting attacks. They can just send email messages to everybody in your system and then decide which messages get bounced and which ones don't. And the ones that get bounced probably mean there's nobody there. The ones that don't get bounced, well, they probably mean there's somebody is there. So you can use that to find who's on the system and then use that information to then try to log into their account by guessing passwords and things like that. So some of the useful packages, Postfix is the SMTP mail server. You have other things that are related. Dovecot, which we will not talk about much, does provide your POP and IMAP servers. So Dovecot's a nice thing to look at. Telnet is a great terminal emulation program that allows you to connect to ports, and you can use it to telnet to your local host port 25 if you want to walk through the mail protocol and try to figure out what's going wrong. Alpine is a great email client. It comes from, well, it's based off of Pine, which was based off of Pico, and Nano is based off of Pico. So you get this kind of thing happening here. Anyway, Alpine is a great text-based email client, and you can use it, but you have to first install the EPEL libraries. So if you don't have the EPEL-release package, you'll need to get that in there, and then get Alpine. Postfix is available and running on default CentOS Linux 7 machines, but it is only listening locally. So it's receiving local host type email messages, and some of the services use mail as a way to communicate with the administrator. So one example would be the cron process. Whenever there's a cron job that produces output, it will send an email message to the user, usually root, indicating what the output of the command was. So normally you write cron jobs that have no output unless there's an error, and then they produce output and it gets emailed to the administrator. But if you wanted to do more than just listen locally, you need to make some configuration changes. So in order to configure postfix to allow external connections, you need to edit the etc postfix main.cf file and allow listening on all interfaces. So you can scroll down a little ways through that file until you find a section with 4 lines. The top line would be the iNet interfaces equals all, which will be commented out. You need to uncomment that one. And you want to take the one that says iNet interfaces equals local, and you want to comment that one. Now when you uncomment it, make sure you just remove the hash mark. Don't remove it and leave a space there or something like that, because then it won't work. So make sure you do it correctly. And then once again, you have to restart your service. So if you want to restart your service, you can use the systemctl command. So systemctl start postfix.service. You can do systemctl with a start, stop, restart status to start, stop, and restart, or get the status of your service. You can also make sure it starts on boot time with the enable, or make it not start on boot time with disable. Now you don't need to worry about enable and disable because it should be running already by default. Once again, because it comes pre-configured that way. In order to receive mail, the mail server must be obviously listening, but it also needs to be allowed to receive communications to TCP port 25 from outside machines. So in order to allow inbound TCP 25, you can use the following command. Just use the firewall-cmd space add-service equals SMTP, which will allow the SMTP protocol to come through. Well, allow port 25 to come through. You can then verify the services are present in the firewall as well with the firewall-cmd-list-all command. And once again, if you want to allow your service to be there after a restart of your firewall, you'd want to add the -- permanent option to the top command so that it gets stored into the firewall configuration files. So when it boots up, it will automatically add it there. One more thing to think about, external email service identification. So postfix and other email servers follow standard protocols, which is nice, but it's also kind of confusing sometimes. In order to send email, the postfix server uses the host domain part of the email address to identify the server. So if it's a bob@example.com, it's going to check first for a DNS record for an Amex record for example.com. If it does not find it, it will check for an A record in the DNS service. And so it looks for example.com, and if it finds an MX record, it will use that. If it doesn't, it will use the A record, and if it doesn't find that, it will not send the mail. So it does not use the etc host file, so don't try to make that work. It just doesn't work. It refuses to do that. So you want to make sure you can use your DNS service, which means you have to have it configured. Troubleshooting. So if you are having trouble sending mail or receiving mail, you want to verify your IP address is correct. You want to verify the services are running. You have your mail server running and up and going. You want to verify the firewall is not in the way. You want to verify that DNS records are there so that it knows which server to identify and use. You want to make sure the remote host is up, and you can ping it to do that. You also want to verify that the remote ports are open, so you can use Nmap to scan the machine, make sure port 25 is open. You want to make sure you can check logs. So you can go in that var log, mail log, and take a look at that. You can also check the mail directory and see if mail is being received. So here are a couple things, and that is our mail server or postfix mail server overview. Dynamic Host Configuration Protocol, or DHCP. So the DHCP protocol operates on UDP ports 68 and 67. DHCP is based on a series of messages. You have a discovery message, an offer, request, and acknowledgments. So what happens is a client will come online and they will send out a DHCP discover packet. Then a DHCP server, assuming it sees it, will then offer a DHCP offer, and they offer an IP address that the client could then potentially use. It is then up to the client to collect all the offers it receives, decide usually the first one that comes, but which one they're going to accept, and then they're going to request that of that DHCP server specifically. After it has been requested, the request will be sent out broadcast so that all the other DHCP servers who made offers will see the request, and then the acknowledgement comes back letting the client know that the request has been acknowledged, and they can then start using that address. In addition to that, they will get a lease, so they get a certain amount of time they can use this address, at the end of which they will have to renew, well actually somewhere in the middle they will renew their lease, but at the end of which they would lose the address. So some security issues with DHCP. If you have rogue DHCP servers, they can give out addresses, and that can be a problem. It could mean security issues. It could mean someone's giving you something incorrect. Sometimes you'll have someone plug a wireless access point, some kind of a home router, in your network backwards, and it'll start issuing out addresses. You can block that on the switch, but if it's not blocked, they can cause all kinds of havoc. Clients can spoof MAC addresses to gain additional access. So if you want to get access and you know that a specific IP address gets it, or a certain MAC address gets it through the firewall, you can spoof addresses. And this isn't really a DHCP problem so much as an issue with MAC addresses and security and everything there. But you can spoof things and get more access. Clients can also obtain multiple IP addresses by presenting multiple MAC addresses. So if you have a client that is trying to create a denial of service type situation, they could present a whole bunch of different MAC addresses, get a whole bunch of different IP addresses, and then lock them all up so they're not available to anybody else. Some of the useful packages. The most useful package here is the DHCP package, which includes the DHCP server, which is DHCPD. There are other ones that are there. You have a DHCP libs and DHCP common, which are used basically in order to get DHCP in the client to run. So the directories that are interesting, there is the etc DHCP directory, which contains all of your DHCPD configuration files. So you can look in there and see what's there. You have your network configuration, and those are in the etc sysconfig network scripts directory. All of them start with the ifcfg, and then it's usually -eth0 or ens32 or something else. So you have to go look and see what interfaces you have, and then you can go configure those. If you're running as a DHCP server, you can see the var lib dhcpd dhcpd.leases file, which will contain all of the leases you've given out. You might note that there are multiple copies of the same lease that's there, because sometimes a client will request something more than once. It might go down, come back up again before the lease is expired, and it might get a new renewed lease. Anyway, that leases file keeps track of all your leases for you. And then there is the var log messages file, which contains all kinds of information, such as all of your discoveries and offers, and all those things can show up in your var log messages file. So the configurations for the DHCP server are in the etc DHCP directory. The following is example dhcpd.conf file. You can see right there on the top, you have the option domain name. You tell it your domain name, option domain name servers. You tell it what DNS servers people are using to get out. You tell a default lease time. This one has 300, which is 300 seconds. A maximum lease time, which right here is 1200 seconds. So these are very short-term leases. So a default lease of 5 minutes with a maximum lease of 20 minutes. Obviously, you want to have much, much longer times, but they're in seconds. The subnet right there, you can see we have a subnet being configured to give out information. So this is the 10.10.0.0/16 subnet, and we are handing out addresses in that subnet only to 10.10.0.100 through 10.10.0.150. So there's only 51 addresses that are being handed out, and then we're telling them that their default gateway is 10.10.0.1. So that is the routers is your default gateway. You can also, in addition to just giving out a range of addresses, you can give out static addresses. So the DHCP server can be configured to assign the same IP address to a machine using the MAC address. This is very common in situations where you have a machine that has to come up with the same address every time because it provides services of some sort. The following example to assign a printer. So the printer had the MAC address of 00:11:22:33:44:55, and then you could have a fixed address of 10.10.10.10, and that would be the information you give out. And so you put that inside that subnet section on the previous slide to make sure it gets that information, and also to make sure it still gets the router information and DNS information. The DHCP service needs to be started in order to start listening. You can use the systemctl command to start the DHCP server. So you do systemctl start dhcpd.service to start it up. And other options you have is stop, restart, status. If you wanted to start at boot time, you can do enable, and then you can do disable to make it not start at boot time. Having the service running won't guarantee you can get anything. You still need to make sure you can get through the firewall. And in order to receive requests, you need to make sure that the ports are open. So you really need to be doing both because it sends out and receives on different port numbers. But you can use the firewall-cmd-add-service equals DHCP command to add the DHCP service to your firewall. If you want to be permanent, once again, you need to make sure you add the -- permanent to the end. So firewall-cmd space -- service equals DHCP space -- permanent to make it permanent and make it there when you start it. You can verify the services are present in the firewall as well with the firewall-cmd space -- list all command, and that will get it there. Once you have your server running, you can go check your messages and stuff like that. But if you're having problems and clients aren't getting things, you can go troubleshoot the clients first. If it's a physical connection, you want to make sure that you have the clients there. You make sure the clients have NICs and cables, and you can use the lspci command on Linux to verify to make sure you have a NIC driver. That can be important. You can verify the server address is static. So your DHCP server must have a static address, otherwise it will not work properly. It doesn't work off a DHCP, so don't try. And you want to verify the firewall allows connections, so you can look at that. Verify or look at the logs to see if there's anything in there. Check the leases to see if it really is giving out leases, or if they're being handed out. If you are setting up a network, you can actually have your configuration have multiple different subnet sections. And then if you have multiple subnet sections, you might be servicing different subnets based on information being forwarded. So you want to verify the routers forward the request. If they need to do that, you want to verify the spanning tree is not a problem. Sometimes spanning tree is configured so that a machine booting up will be assumed to be a switch, in which case it will block everything until it is determined that the machine is not a switch, and then it will allow communication through. So you want to make sure the spanning tree is not blocking anything. And you want to make sure that the switches are allowing you to answer, so your machine needs to be connected to an interface that is allowed to send out your DHCP offers. So you can receive the discoveries, but you can't make an offer unless, well, you can make an offer, but your offer won't get out unless the interface is allowing you to get out. And so you want to make sure that the switches are not blocking you from making offers. And that is the end of this section. So good luck. Domain Name System, or DNS. The DNS protocol converts names to IP addresses and vice versa. It also does names to names and other things as well. But it solved some of the problems of the host file because the host file was getting too big. There was at one point a single host file, and people would send their submissions to the maintainer of this host file, and the maintainer would update this host file, and then people would download copies of this host file, and it became a regular full-time job basically. And so the DNS protocol was basically invented as a solution to this problem. How do you maintain this giant host file? So it became a hierarchical database of information. It was invented in 1983 and 84 and has been in wide use since the mid-1980s. The DNS protocol operates on both UDP and TCP ports 53. UDP for your normal inquiries and TCP for your downloads of zone transfers and things like that. There are a couple of DNS security issues or concerns you need to think about. If you send spoofed responses while making a request, the DNS server might get confused and keep your entries. Basically, the way this happens is you send a request to your DNS server. Your DNS server, if it doesn't have a cache, will have to go to another server to get the information. So it sends the request. If you know where it's sending the request and you can spoof that source address, you can send a reply as if it were coming back from the server that it requested from. And if you do it fast enough, your reply will get there before the actual reply from the server it's requesting it from, and then it will get loaded in the cache of your DNS server and cause it to have incorrect data. The next concern is that alternative DNS routes can redirect all of your traffic. So it's a hierarchy, and it starts from the root servers, which delegate to servers that manage the top level domains, and those delegate to individual servers that manage domain names and things like that. If you modify the DNS route, you can redirect all of the traffic somewhere else. So some countries have done this, and such as China did this for a little bit, might still be doing it. Other countries have done this where they have created their own root servers and redirect everything. In addition to redirecting traffic from the root servers, you can also do DNS manipulation by ISPs. Your ISP controls all of your traffic. They can manipulate your traffic. So if you send a request out to a DNS server and your ISP decides to modify the DNS query or response, they can do that. Also, there is registrar-based DNS manipulation, because the registrars are where the individual domain owners have their data stored, and those could redirect and point to different places. You can also trick registrars into transferring names over to you, and it can be all kinds of a mess. So on Linux, we tend to use the BinD DNS server. Usually you'll hear about it being BinD, Bind, or Named. Anyway, there are a couple of things to think about. All host names end in a trailing dot. Normally when you see a host name, you don't put a trailing dot on it, but the DNS server knows it has a trailing dot and it puts it there. So you need to be aware of that, because Bind treats it like it should be there. Host names and IP addresses in DNS are written with the largest grouping on the right and the smallest on the left. What does that mean? Well, if you look at a name like example.com, com is a much larger grouping, and so it's on the right hand side. Example would be on the left hand side because it's smaller. So the larger it is, the further to the right. But if you think about IP addresses, something like 10.11.12.13, and you say, well, which one's the largest grouping? Well, the 10 is the largest. So it's on the left-hand side. But that's not where the DNS wants to put it. It wants to put it on the right-hand side. So if you were to write out your 10.11.12.13 in a DNS type format, it would actually be 13.12.11.10. And then it'd have a .inaddr.arpa. So keep that in mind. Also, some types of records have a single value and some have more than one value. MX records have a priority and a value. So an MX record will take a name, usually a domain name, and then it will give you a priority, and it will also give you a host name of a machine you can talk to if you want to send your mail. In addition to that, there's things like the SOA records and other records that have multiple different pieces in them. Some of the useful packages in installing bind, well, you have bind and you have bind-utils. Bind-utils is really good. It provides all those really important tools like NSLOOKUP and dig, which are good for, well, doing DNS queries. You want those. When you are configuring your bind server or named, the main configuration file is in the etc directory, etc named.conf. So you go in there, you modify that file. Sometimes it's etc named, then named.conf, but you find the file there, you modify that file, and that file lists all of the data that you need to know about. So where is the data stored? Well, the data is normally stored in the var named directory. So you have the var named data, which would be all of the zones that you control. And then you have var named slaves for all of the zones that are acting as secondary or slave zones. And those would be zones you get from somebody else. Now there is a big push for renaming things. And so while it is var named slaves right now, you'll probably find that words like master and slave will start to disappear because they have a negative connotation. So just be aware that the name might change to something like secondary or something else. What does the named.conf file look like? Well, you have different zones in there. There's lots of data in it, but you have these little entries for your individual zones. So that top one right there is for the domain.ext. So you could have a example.com zone, and then inside of it you have, well, information about that zone. This one, because we own it and we control it, we have the type as master. And then you list the file. Where's the file? Where the file is going to be called domain.ext.zone. And where would you find that? Well, you're probably going to find it in the var named maybe data directory, but you have to look at the rest of the configuration file to figure out where things are actually stored. Alright, if you look at the IP addresses, let's say we were doing something for the 10 dot range. We want to do the entire 10 dot range all in one file, which is quite a bit actually. So you might do zone 10.in-adder.arpa. And that would be the zone that you'd be doing. And you'd have it be a master because you are controlling it and configuring it. And then the file type would be, or the file name would be something like your IP address .zone. Now the file names don't have to match the backwards orientation or anything like that. So you could just put 10.0.0.0.zone. It doesn't even need to add an end in the word zone, but some editors treat different files differently depending on the extension, so that's something to keep in mind. So you have forward zones and reverse zones. A forward zone is a zone that uses names as its lookup. A reverse zone is something that goes from IP addresses back to names. So forward zones have multiple different types of records in them. So here's an example forward zone with, well, a bunch of things, a bunch of variables and so that. But we can see the very top line right there is $, then TTL 3H. which basically means your time to live for each of your entries is 3 hours. That's the default time, but it can be overridden and changed. And then you can see the @ sign. The @ sign means for the entire zone. So @ in ns dns.domain.ext dot. You see that trailing dot? That's important. So basically what this is a record for this zone, and this zone is defined as whatever's in the named.conf file. It's saying that the name server for this zone is dns.domain.ext. Well, you're going to need to make sure you have this dns.domain.ext defined somewhere. So we're assuming this is the domain.ext file, and you can see at the very bottom line there is a DNS in A, and then you put the IP address there. And the IP address right there is written in normal IP address format, so it'd be 10.11.12.13. No trailing dot in that one. So what you have is the word DNS in the front of that line, and then your IP address at the end. And if there is nothing after the DNS, no trailing dot, it assumes that you are just giving an address in that domain. And so if this is domain.ext, it will assume that is dns.domain.ext dot. And that would satisfy the name server record at the top with an A record at the bottom. Inside of each domain, you have a start of authority type record and SOA, and each one of these records has a couple different pieces. You can see the domain that it's doing everything for is the domain.ext, and then you have this root.domain.ext. Well, what is that? That's actually an email address. You don't see the @ sign in the middle of the email address because the first dot is supposed to be replaced with an @ sign when you write the email address. So it actually be root@domain.ext dot as the email address for the administrator of that record. And then you can see the serial number. The serial number is usually written in a 4-digit year, a 2-digit month, 2-digit day, and then a serial number. So every time you make an edit to the information, you'd want the date written there, and then you start with 00, 01, 02, 03. You just count up. This would only allow up to 100 edits that day. And the serial number is used when you do zone transfers in order to figure out if the zone is already, well, if it's new or if it's the same zone. So if the serial number is the same, it will assume there are no changes and will not download the zone. So when you have your secondary servers out there, they need to make sure that the root server has serial numbers changing. The other numbers are refresh, retry, expire, default, time to live, those kinds of things. And those are all written in a number of seconds. So you can kind of get an idea of how long each one of these is. Some of the different types of records include your A records, your quad A or AAAA. You have your MX records, you have your CNAME records, your TXT records. There's all kinds of records. So you can see a couple of different examples here. The A records are for taking a name and converting it to an IP version 4 address. Your quad A records take a name and convert it to an IPv6 address. Your MX record is a record that takes a name and converts it into a priority and a name, and that is for your mail exchange. So if this were for the domain.ext or example.com, if you wanted to send an email to that domain, you need to figure out where your mail server is. And so that MX record right there indicates that you would go to the mail in the domain server. So maybe mail.domain.ext, and you can see the record right above it is an A record that tells you the IP address of that. Then you have a couple of CNAME records. CNAMEs are aliases, and CNAME stands for canonical name. So you can see that POP and IMAP both map to mail, and you can see mail maps to an IP address. And then you can see under the mail, in addition to having an A record, mail also has a TXT record, and the TXT record has what is called an SPF, and this is used to indicate which machines are allowed to send mail for that domain. So if you received mail for something, and this would probably actually be in the app, but if you receive mail for a given domain, you'd want to know who is authorized to send mail. So you can do a lookup using the SPF information in a TXT record and figure out which IP addresses are allowed to send mail. And this indicates that the entire 10 network is allowed to send mail, but nothing else. So all other ones are not allowed. You also have reverse zones. So the top part of the reverse zone looks the same. You can see it jumps down to this origin thing. So origin to specify individual pieces. This is doing the 192.168.0 range. And you can see the 192.168.0.0 is that second to the bottom line, where it is in 0 in PTR for pointer network.domain.ext dot. So it's telling you what the name of that, well, IP address is when you do a reverse lookup. And you can see the .1 as well. The named service needs to be started in order to start listening. You can use the systemctl command to start the named server. You just type in systemctl start named.service. You can leave the .service off if you want. Other options you have is the start, stop, restart, status. And then if you want to make sure it starts at boot time, you can use enable. And then if you want to remove that, you can use the disable to remove that, so it won't start at boot time. In order to make DNS available, to really make it available, the DNS server needs to be able to receive data through the firewall. You need both UDP and TCP/53. 53 is only necessary if you're doing zone transfers, but normally DNS servers should be able to do zone transfers. So you want to indicate who can do zone transfers. So you can add the services or the service for the server with the command firewall-cmd space -- service equals DNS, and that will add in the service so that DNS can get through the firewall. If you want it to be permanent, you can do that same exact command with the -- permanent option, and then it will put it into the configuration file. So the next time the firewall starts up, it will add that rule in there. You can verify whether the services are present in the firewall currently with the firewall-cmd space -- list - all command, and that will indicate whether or not it is in the firewall. When you're troubleshooting, make sure the DNS server is set. And you can go look at the etcresolve.conf file, and you will see which DNS server you have set, which is kind of important. You want to make sure you can talk to your DNS server in normal ways. You can use NSLookup, you can use ping, all kinds of things to make sure you can talk to it. Make sure the record is download okay. You can use NSLookup or dig. You can do a DNS hierarchy trace. So if you do a dig plus trace command on something, it will start from the root service and work its way down. You can figure out if you are in the DNS hierarchy. If you're not, then it's not likely anybody else will use you. You can make sure your firewall is correct. You can make sure logs look good. If you have any MX records or CNAME records, you want to make sure they point eventually to a valid A or quad A record. So CNAMEs can point to other CNAMEs, and MXs can point to CNAMEs, or they can both point to A or quad A records. But eventually, if you keep resolving it, it should get to a quad A record. You want to verify the service is running. So you can use netstat, make sure it's running, and you want to make sure that any SE Linux contexts are not strange. So you can go look in the var named directory and see if anything looks like it doesn't have named in it. It might not work properly. And that is it for DNS. So good luck. Simple Network Management Protocol, or SNMP. The SNMP protocol is commonly used to gather statistical information from networking devices. It can grab all kinds of information such as bandwidth consumption, ports, whether they're on or off, names of machines. All this information can be gathered together, and is usually used to manage an entire network. Some variables gathered can also be set using the SNMP protocol tools. SNMP typically operates on UDP ports 161 and 162. 161 for normal communication and 162 for traps or indications when there is a problem. There is a management information base, and well, this is for information. SNMP provides a lot of information. Each individual element of information can be addressed with a hierarchical dotted decimal number called an object identifier, or OID. The object identifier for system name or host name is 1.3.6.1.2.1.5, and this has multiple different pieces in it, and the very first one, which would be the system name, is .0. So if you have more than one name, it might be a .1 and .2, and it kind of increments up. To make things easier, the MIBs provide names for the numbers. You could get the same host name with that number above, or you can also use either system.sysname.0 or sysname.0. So those are a little bit simpler, easier to read and recognize and remember as well. Community strings. SNMP does not want to provide information to just anyone, so it requires a password called a community string. There are two default community strings. For read-only information collecting, you can use the default community string public. For read-write information collecting and setting, you can use the default community string private. SNMP uses the UDP protocol, and the server ignores messages with the incorrect community string, so you do not know if datagrams were dropped or ignored. It's kind of confusing, makes it difficult. You send it out, you wait 10 seconds, nothing comes back, you say, well, it didn't work. But that could be because your community string is being ignored and there is no reply. Many network devices have active SNMP support the administrators are not aware of. It's very common for printers, for example, to have SNMP support turned on and running, and they might have both the public and the private community strings available, so you might be able to do all kinds of fun things with the printer, and the administrator wouldn't even know how you're getting in. Sometimes you have routers or wireless devices or cameras that all have SNMP support turned on and running. So you need to make sure you turn things off that should not have it running. Most SNMP messages are not secure. They send things in plain text, they come back in plain text. If you want to intercept something, you want to see what the community string is, just watch the line, see what it is. So some useful packages. NetSNMP provides the SNMP server. NetSNMP utils provides some utilities for performing queries and making changes. So you can do your SNMP get, SNMP set, your SNMP walk, all kinds of activities and utilities right there. When you're trying to configure the server, you need to go and edit the etc snmp snmpd.conf file. One of the most common changes people make is change the community string. You'd want to probably make it not be public. So you find the line that says com2sec not config user default public, and you can change the string to something else. For example, aloha123, which is also a super secure and secret password that no one will ever guess. The SNMPD service needs to be started in order to start listening. You need to use the systemctl command to start the SNMPD server. So just use systemctl start SNMPD, and you can use the .service if you want. Other options include stop, restart, status, enable, and disable. Enable is for making it start at boot time, and disable is to make it so it doesn't start at boot time. In addition to having the service running, you need to make sure it can get through the firewall. You can add the service to the firewall with the firewall-cmd space -- add - service equals SNMP, And if you want to make it permanent, make sure you add the -- permanent option to the end of that, and it will make it permanent. You can verify if the service is in the active firewall using the firewall-cmd space -- list -all command, and that will tell you which services are in the firewall. If you have it working, you might want to verify it's working. So you can use the SNMP client, which is provided, or the client utilities provided by NetSNMP utils, and I would recommend using the SNMP get and the SNMP walk commands to test your server. The following two lines assume your community string is aloha123, and you are just connecting to your local host, although you can put the IP address of the server you're connecting to if you have the firewall open. When you do the SNMP get and the SNMP walk commands, you want to make sure you pass the SNMP version. You can use 2C or 1, and you want to make sure you pass the community string with the -C option there. In the top one, you are getting the system name or the host name, so it's sysname.0, and the SNMP walk, you're going to walk the entire system set of information. So sysname would be one of those items in the system set, and it'll just list a whole bunch of them, walk through it until it runs out of responding OID values. For troubleshooting, you want to make sure your DNS server is set correctly. Sometimes when you're trying to look things up by name, it can be a problem. You want to make sure you can talk to the SNMP server. You can ping it, you can port scan it, make sure it's up. Make sure the firewall is correct. You can check your logs. You want to make sure the community string is correct. If you change it, you want to make sure you change your commands you're using to talk to it. You want to make sure you have the correct object name. And if you're having trouble talking to it, try something you know will work. So sysname.0, it's a good one to try. You also want to make sure the service is running, so you can use the netstat -tunap command to get a list of what services are there. And that is the end of this chapter.